I'm working on it. I think we're good. All right, I'm gonna start the
Cool.
webinar. And the recording started. We're good, man. We're live.
Are we live?
We're
Well,
live.
thanks for telling us then, Mark. That's just fantastic. Hello, everyone, and welcome to the eighth
Oh,
KB. Eighth? No, wait, eight. Anyway, this is the eighth time we've done this. Uh,
yes.
Thank you all so much for being here. The actual session will kick off in 15 minutes. We are going to get organized, get things sorted. Do you want to? We're trying a new thing this year of being really disorganized. I know I've already made that joke in the Slack channel, but Mark, do you want to find our moderators and our presenters and promote them maybe to
I'm
panelists?
I'm getting there. I'm getting
Rocking
there.
stuff. There's Chrissy. Hey, Chrissy, how you doing? Jess is in there somewhere.
Yeah, the
Coming
list
through,
keeps growing
coming
and
through.
Hey,
Excellent.
how are
Hello,
you?
everyone. I'm
hello.
great. I'm very happy to be here. Thank you all for having me.
Awesome stuff. Awesome stuff. So I guess, we have a few housekeeping things to go through. So now it's my turn to press buttons and mess it all up. Let's share some slides, shall I? Let's do screen two. And I am screen sharing. Hello, everyone. Yes, welcome, as I said, to the eighth edition of 8KB. I can't actually believe we've got eight of these going. Fantastic stuff. Really happy to be here. Just to introduce our team, we have, forgot I did that.
What
Let's
a
change those
jerk.
names. I know. It's Mark, Anthony, and myself. Anthony, Mark, do you want to say hello? Anthony, you've been very quiet there.
Hello.
Hello. Well, Tony, we can do
Yeah,
that for the rest of the day. I
Are you
think.
sulking, are you? I
Tony.
see. I see.
Uh,
All right.
I
Okay.
gotta update my picture. That's kind of old.
Oh, yeah, well, anyway, none about us. We are the guys who just put this in the background. We want to talk to you about what is coming up today. So, in about 10 minutes, we have Chrissy here. And thank you so much, Chrissy, for turning up bang on time, actually 15 minutes before your session. We had one year where we had a couple of speakers who turned up like 30 seconds before their session started. I'll be honest with you, I was sitting there having kittens. So at all the times we're in UTC at 1:15, we have Chrissy with Enterprise Vibe Coding. So giving us a concrete methodology of AI assisted development, basically stopping those pesky agents from going and dropping the production database. We've all seen the stories. Then at 14:45, we have Mala with vector compression and memory storage economics. So a deep dive into vectors, how they're generated, stored, and everything we need to consider when working with vector data. 4 o'clock, we have Andy, unraveling the layers of I/O, your next step to becoming a comprehensive performance tuner. So Andy's going to dive into the full I/O path from running queries in SQL Server. Really looking forward to that. And then 5:30, we have John, ADR deep dive, basically a mystical feature in SQL Server that changes how transactions roll back. And then to roll up the entire day, we have Edwin with all his on availability groups and failover clustering internals, really diving into how Windows clustering and AGs work. We've all been there watching an AG bounce backwards and forwards and wondering what on earth is happening here and trying to make heads or tails of a Windows cluster log. So really looking forward to that one as well. A couple of these goes through. We want to say thank you to our awesome moderators. So Deborah, Jess, Bob, Ree, and Matt, they will be helping out with Q&A during the sessions today. Now, we have the Q&A panel within Zoom itself. Please, please, please do ask questions there. If you want to ask a question in the Slack channel, please prefix it with a big question in capitals so we can easily identify them, because there's usually quite a lot of chat going on in there. It makes it a lot easier for us to identify them. Have we found us? Oh, Jess, there you are. How you doing? See you on the side there.
I'm good.
Cool.
Thanks for having me. Excited to
Well,
be here.
thank you. Thank you so much for helping us out today. Basically, we love our
Of course.
moderators because it means we don't have to do any work during the sem. No, did I say that out loud? Anyway, one little thing to mention, we do have a code of conduct. It is there on our website. The general gist is let's all be nice to each other. We're all here to learn and have a little bit of fun. If you want to check out the actual full details, it's on the slide there. Want to mention, if anyone isn't in the Slack community sign up, we don't have any chat in the Zoom call. We have all the chat in the Slack channel. So go to that link there, and then the channel is hashtag 8KB. I will be posting loads of resources and links, and maybe some of the speakers will hang around after the sessions and answer some questions. You never know. Load of online resources for you. Okay, so GitHub. After the sessions today, the speakers will upload their resources there, or a couple of them already done it, but it'll be on GitHub, 8KB 2026-August. We are actually live streaming this on YouTube as well. So if anyone mentions, oh, I don't want to register, I just want to pop in for a session, they can go to that URL there. We got our website. We're on Blue Sky at 8kb.online. We don't talk about the other social media network anymore. If you have any questions that you want to ping either myself, Tony, or Mark Wilkerson, you can email us at info@8kb.online, and we will try and get back to you. It's not the most monitored inbox in the entire world, I will say. But we will try and endeavor to get back to you as soon as possible. But you can either just ping us on the SQL Community Slack. We're all in there. Go and ping us there. And then there's the feedback. We have feedback forms for all the speakers and the overall event at 8kb.online/feedback. And we'll be don't worry about remembering all these. We will be posting them over and over and over and over in the Slack channel today. So they'll all be available for you. Cool. Okay, I know we bring this up every year, but really we have no sponsors. We don't have any sponsors for this event whatsoever. The way we pay for this event is by selling t-shirts. So if you would like to support us, please go to bonfire.com/store/8kb. Are the Brain Melty t-shirts still there, Mark?
Oh, they are.
They are the limited edition that has been limited edition for about 5 years now.
Unlimited, limited edition t-shirts.
But if you want to buy a t-shirt, and I honestly, I am so unbelievably chuffed every time I go out to like another in-person conference and I see someone wearing an 8KB t-shirt. And if I do see you wearing an 8KB t-shirt at a conference that I'm at, I will buy you a beverage of your choice.
Does that apply to us too?
No, of course not for you two. Buy you enough beverages as it is. Anyway, okay. So next up, how long have we got? What time is it? I've lost the. Every year we do this, and every year you tell me that 15 minutes is far too long for a intro session. But up in about 7 minutes, we have Chrissy with Enterprise Vibe Coding. I will stop sharing because we've been through all the slides. Nobody wants to see my slides, and we can just have a chat till we get going. Cool. We all good? Hope everyone out there very good. You got a little bit of time now to go and get yourself some drinks, some snacks. And we'll be kicking off in about 7 minutes.
I have a request.
What's the request?
If you're a panelist and your current Zoom name is just your first name, could you add a last initial so I know who's who? Andy Yoon may be here, but there's 2 Andys. There's also 2 Kevins.
Then you just pick one of them and they have to give the session.
Right.
Ooh, there we go. Yeah, somebody might get to be a surprise moderator.
There's literally there's 4 Andrews on a database team up here. Like it's not fun sometimes.
There's something goes wrong every year, and I realize that I have missed out a moderator. Actually, I got the moderator wrong. It's just been pointed out to me. The moderator for Marla's session is Kevin Fiesel, not Bob.
We do have a question in the Slack already for you, Andrew.
Oh, yes.
Oh.
It says, please tell us about your wall clock.
My Kit Kat wall clock. That was my present from my wife a couple of years ago. So I've obviously moved house, and I keep forgetting that all the stuff that used to be on the wall behind me is now on the wall here that everyone can see when I do conferences and webinars. And people are like, what is that exactly? It's like, yeah, that's my wall. So
Mark had a particularly keen observation about that earlier today. You want to share your thoughts on that one?
I did. Every time I see, because Andrew and Anthony and I all work together now, but every time I see that cat in a meeting, the only thing I can think about is the amount of bandwidth being burned just to send those changed pixels as the tail swings.
Yeah, but now he's doing it times 1,000 today across the whole planet. So.
I know. Yeah, and live stream to YouTube.
I'm not complaining. So I'm fixing slides. Hopefully that is the one thing that has gone wrong. And that is totally on me for not being able to sanity check my own slides. So
Just glad everyone's here to see our mistakes.
Only there were agents that could do this for you. Hey, that's how I didn't mess up the calendar invites this year. Is that an agent read the schedule and make the files for me? Haha, time zones.
I was wondering if it all went too smoothly. I was like, Anthony definitely hasn't done it this year.
I didn't do that. No. Copilot is my homie.
New shirts.
Copilot is my homie.
Nope, let's just fix that.
I
still can't get over we've been doing this, but this is the 8th time.
Yeah.
Absolutely.
With many more to come.
Hopefully we haven't been shut down yet anyway. Okay. Haha, Deborah, that's awesome. Now, Deborah's posted a picture of herself and Andy wearing 8KB t-shirts. Okay, so we've got about 3 minutes to go, Chrissy. I'm not sharing the screen.
Would you like to practice sharing?
I will
just in general or the screen.
Right. Be kind. Remember back in the day, sorry, Chris.
Sorry. Well, I was going to say real quick, whenever this all started, I was testing my microphone, and the last thing I had said was, "Oh, that sounds horrible." So I've switched it from my ear pods to my MacBook, and I just want to know if it sounds good.
Really good.
Yeah,
awesome.
Decent.
Perfect.
Yeah, can't even tell. Yeah.
Excellent. Thank you.
Okay,
yeah.
So.
Yeah, I remember back when we first started this, like organizing like tech checks with the speakers and the advent of the Zoom days, and now it's just like whatever, let's go, right?
Well, we obviously not going to mention speakers, but I do remember doing a tech check with one speaker who said, "Oh, by the way, this won't be the equipment I use on the day." And I'm like,
perfect. Glad we tested that.
Like, okie dokie, no worries. Maybe we don't do the tech checks anymore. And plus, speakers are busy, and yeah, as you're right, Anthony, ever since COVID kicked in, everyone knows how to use Zoom. One year for funsies, we should do it in Teams.
Oh, no. Just to throw everyone off.
All right, share.
Yep.
How is it looking? Perfect. Awesome. Thank you.
Chrissy, do you have specific spots where you want questions asked, or do you just want me to interrupt at useful times if there are questions in the chat or Slack?
I really wish that I was great at taking questions spontaneously, but I guess you can't get great without practicing. So if there's a question, then you can find the appropriate time, and I will try to do my best.
Sounds good.
You know, actually, whenever I practice, I should get some probably Lou, just be like, here's a random question, and see if I can build that into my little workflow. Looks like we got 1 minute, so I'm going to start my
yes, no worries.
time.
Okay.
No, so I'm going to start my timer.
Right.
Yes.
I'm too eager, too much coffee.
Is it like 5 minutes for Q&A after, if if it ends up at the end? I've never done a 75-minute session before, by the way.
We have a 15-minute buffer in between sessions, so
perfect.
No worries. But if you start encroaching too much into that, we will give you a warning and say we need to wrap up. But other than that, nope, you're all good. However you want to.
Thank you so much. All right.
And with that, Chrissy, the floor is all yours.
Awesome. Thank you very much. So thanks everyone for joining my session. This is Enterprise Vibe Coding, and Vibe coding is actually the first thing that I have been excited enough to talk about at length in the past. Whenever I was looking at potential 8KB sessions, I was like, man, I don't want to talk about SMO for for 75 minutes. But with vibe coding, I think it's really important to understand the potential impacts and how to mitigate them. So I'm very happy to be here. Thank you so much for having me. My name is Chrissy Lemaire, and I'm a Microsoft MVP, GitHub star, and the creator of DBA tools. And I recently quit my job. I am moving to Malta, and I'm currently on a road trip. We're in Italy, so stay tuned for some future news. Oh, I'm also the co-creator of 5 Cajun cookbooks, and I don't really talk about this much up until now because before AI, I was kind of embarrassed of the things that would appear on my Google Google ads. One of them was literally a colon, a human colon. And so I have now been able to address that with AI, and I'll be able to talk more about the Cajun part of me. So in April of 2026, the nightmare scenario happened to one of the developers at a company called Pocket OS. In my mind, as a SQL Server DBA, I can't imagine anything worse than dropping not just the database, but all the backups and the volume that is supporting all of those as well. And that actually happened. There was an agent that didn't have the appropriate permissions, but it went credential sniffing. It found a key with the appropriate permissions. It was created just to manage domains, but it had been over provisioned. And it was able to destroy everything, all of the databases, all of the backups, the entire volume. And the only way that it could be restored was by classic DR. A CEO actually called the other CEO, and they restored everything. But this really emphasizes just how terrifying AI engineering can be within the database community. And this failure has a name. It's called vibe coding. Back in 2025, a famous AI engineer named Andre Karpathy, he said, just fully give in to the vibes and embrace exponentials. Forget that code even exists. I accept all always. I don't even read the diffs anymore. And the idea is that you prompt, you run and repeat it until it mostly works. And even when the code base has actually grown beyond your understanding, a lot of people push back on this, but the argument, it's already over. You have engineers at JP Morgan Chase that AI is actually tied to their performance reviews. We've heard that about other companies like Microsoft. And in January of 2026, there was a model from Anthropic that was released. I think it was Opus 4.6, and it really, that was the tipping point that we all realized that maybe there won't be any manual coding. And Spotify came out and they said it. Our engineers have produced 0 lines of manually created code. So they just steer and then they review. And that was encouraging to me as somebody who was mostly doing that as well. The last time that I programmed PowerShell or SQL has been a very long time. Also, behemoths like Walmart, they are using AI extensively. And also Morgan Stanley, they used AI to migrate legacy code back in 2025. And I do find that AI is exceptional for migrating old code. And it's not just the corporations, though. Even the engineers that are known for their precision, like Linus Torvalds, who created Linux and the open source movement, he came out and he said Linux is not one of those anti-AI projects. It's a tool just like any other tool, which I completely agree with. And he said, if you don't like it, you can fork it or you can walk away from the entire project. And also the creator of Curl. It's been really fun watching him, Daniel Stenberg. I follow him on LinkedIn, and I saw him even whenever I was a big AI proponent. I noticed that he definitely wasn't. And there was a long time up until the January 2026. That's whenever things really started changing. And his sentiment went from negative to positive. And then somebody actually used AI to create this, and he was entertained by it and shared it on LinkedIn. So we can see that there's a huge industry movement, both with the corporations and with the open source movement. The problem is that the reach is wider than the governance. And I couldn't believe this. Whenever I was researching for this, Liquibase, their database CI/CD, their equivalent essentially of SQL package, they said that 96.5% of the organizations that they interviewed had AI touching production databases. And I can't help but wonder, is this because maybe these are more advanced organizations? But I have never heard of so many organizations with AI directly touching the database. If this is true, it's also horrifying to me that of those companies, less than 30% actually have change governance that's enforced. And that's a huge problem because 55% of AI generated code actually carries bugs. And AI generated code is basically the average of code. And what's really cool is that you can actually increase the quality by including keywords. Like within the PowerShell community, you have PS framework. And if you use PS framework in your AI generated code, I've found that it increases it all around. And I think the quality, and I think that the reason is because projects that use PS framework are usually really pragmatic and care about the quality of code. But nevertheless, if you're just doing standard coding, you're going to get a lot of bugs. So governance is extremely important. And that's where enterprise vibe coding comes in. I called it enterprise vibe coding. Other people are calling it vibe engineering after software engineering. And this is where AI assisted development commingles with things that we are used to doing in the software industry, like testing and verification and governance and automated enforcement that's built right into the loop. We'll be talking about this throughout the entire presentation. So what changed back in the day? And I remember in 2024, I've been vibe coding a long time, and I used to go and copy things from my browser. So I'd be talking to Claude. It was in a tab. It couldn't see any of my file system. And all I could think was, man, I really wish that that would be possible. And we had VS Code extensions like Rue, but what would really make a difference is if it could be executed on our computers instead of in our browsers. And that's where Claude Code comes in. So you have Anthropic with Claude Code, OpenAI, that's ChatGPT with Codex, and then GitHub with Copilot. And now they have executables that live on your machine. They can read your files, and they can actually run commands and make real changes. And usually it lives in a sandbox, but not always. And one of those times is I actually built an entire network. So I really love integration testing. I have this Hyper-V lab, and I was trying to explain how I was doing everything to a friend. He was like, I just can't visualize it. So what I did was I threw caution to the wind, and I ran Claude as an administrator. So I right-clicked, run as administrator in PowerShell. I bypassed all the permissions. And then I told Claude, you have access to run Linux commands. You can log into Docker. You can execute PowerShell. You can execute DOS commands. Do whatever you need. Just make this topology visual for my friend. And it was able to do this. And it made a very, very nice looking, but clearly vibe coded website. But I loved it because it was able to go in and see my DR subnet, and it created all of this. But that was pretty risky of me. I did do it specifically in a lab, so ultimately I knew that if it blew anything up, it would just be a machine that I have control over, and it's no big deal. I can restore it. And now the difference is ultimately the harness. So nowadays, instead of that tab, you have the harness that has all of these different things. And you'll hear this terminology over and over again. And it basically means the program around all of the API calls. And previously, when I was doing these PowerShell presentations, it would be literally invoke web request or REST method that I would call the API, and it didn't have that much context. But then we built these programs like Claude Code at the CLI, like Codex, and these now have a whole bunch of things like skills, like tool calls and hooks. You might have heard of hooks as like get hooks. And then also MCP connectors, and this is what we'll primarily be talking about, that it really puts the enterprise in enterprise vibe coding. And this is where I spend most of my day. When it comes to Claude Code, I don't love their desktop interface, so I mostly run it from PowerShell. And but if you have a ChatGPT subscription, you may not know that you also have access to Codex. So this is Codex Desktop. I think that it looks so good. It's one of my favorite interfaces. I used it to build my 8KB slides. And so if you don't know, if you aren't aware, and if you have your ChatGPT subscription, then you would be able to use this program. And again, this is running on your desktop, executing commands on your computer. And also very excited, GitHub Copilot, I really love their CLI. And for a moment there, it was like in June, I feel like GitHub Copilot became inaccessible to indie developers like me. It was totally unaffordable. But since then, they've worked out the usage-based billing, and also a lot of models have gotten cheaper. So I can use it again. I'm really excited about it. And they have also a very beautiful desktop interface. This is what it looks like. And you can see all of the projects there on the left, just like with Codex. So I want to talk a bit about what I've done. This is a mixture of things that I've done at work and in my personal time, but all of it has lessons that we can use in our corporate jobs. So the first one is dbatools.io. For the longest time, for literally 10 years, we had a website and it always looked the same. And I was so honored whenever people would do presentations about DBA tools and they would have a screenshot. And I was like, man, that's such an old site. But I was so exhausted. Every time I wanted to migrate it to Hugo, I just kept getting hacked all the time with WordPress. And it was really nice. I logged in as root, oops, and I said, I don't remember the username or password for WordPress. Can you please just go find it? And can you export everything to Markdown? And we'll change this into a Hugo site. And it did that. It looks so good. And you'll notice the difference between this website and the Lab really vibe coded website. So this doesn't look vibe coded at all. And the way that I was able to do that was by showing Claude examples of websites that I like Cursor. I showed it that, including the HTML, and I told it what I liked about it, and also OpenAI. It doesn't look anything like that, but it still created exactly what I was looking for. And it was just it was really amazing because there was somebody who created an issue, and they said, I've heard a lot about your project, but I have no idea what it actually does. When I go to your website, it just has slogans, and that's because like I'm not a web copy writer. But now with AI, I actually made it very useful, and I was super impressed. I love how it did it. Actually mentioned, hey, can you put the book on the front? And I meant at the top on the header, but then it added it here. And I was like, oh, that makes so much sense. People have asked us to create the book and they like it. And so let's go ahead and feature it. But what I really want to show you is the getting started. If you have documentation at your employer's place, at the corporation, and it'll go back 20 years. Having AI review it with a couple key phrases just made such a huge difference for us. And I was really happy that I could apply the same things at work. I always talk about using the phrase best practices, and I just best practiced everything about this. But what I had to do for the getting started page was I gave it all of the getting started tutorials that we had kind of tried in the past as developers who aren't copywriters. And from there, I had it go and research how to write a great tutorial. And I was so impressed. I loved the output. You can see here that it says why, and it compared the traditional methods. This isn't anything that I had actually given it. And then we also had the first 5 minutes. It went through the installation, and people were really happy with the output. So this is also something that you could do within your organization as well. Next up, this is a Real Cajun Recipes, which I had talked about before. And what I loved about it was over the course of 20 years, I've always wanted to convert my website recipes to French, but French wasn't possible at scale. I didn't have anyone with the expertise. I didn't have the money to pay for it. But with these large language models, I was able to do that. And within our companies, there's a lot of times that we have or want to perform localization. And this is creating all of your tutorials in different languages like Portuguese, or Justin Bird actually has a website. He's Welsh, and he was like, oh, when he saw this, he was like, oh, I can actually change my blog and add that as an additional language. And it's just been really cool watching the traffic come from France and also from Canada, because I translated it in addition to Quebecois. But I do want to highlight this. When you are doing localization, you should write the prompt that is actually performing that translation. Write that in the destination language as well, and it'll help it because it brings in all of these related words, and it just has a higher output, a higher quality output. Also, if you go to my blog at blog.netnerds.net, I have a whole bunch of posts where I talk about with just a single prompt, you can update all of your previous documentation. And I've had a blog since like 2003. I redid it again in 2006, but over time, I was like, man, the links aren't working anymore. All of the commands, they're referencing command names that we've changed in DBA tools. And I wish that it was updated, but no way am I going to spend all of that time going through hundreds of posts. But what I was able to do with just a singular prompt, and it's long, and I worked back and forth with Claude on this, I went through and I was able to update all of my blog posts. And this is something, again, that you can do with your documentation. And I didn't change the content. I changed things like Microsoft always goes from, TechNet to teach to learn. And what's really cool is that whenever you're doing this in PowerShell, you're using regex to do a replace. And a lot of times that won't work with the new destination. But with AI, it can go out and it can find the actual new location that isn't based on this brittle algorithm. And it was awesome. Katrin Williamson, she was initially skeptical whenever she saw this. She's like, man, I want it to keep my voice, but I didn't change anything in my voice. I just changed the facts. It was very nuanced, and I was really happy with the results. Also, one of my favorite things, the moment that I was able to write a business development paper for my boss, it's like, God, I have to go to conferences and let everyone know that the same methods that I use for engineering a program or a PowerShell module, I can actually use that to write business papers. So I can create a hook that says, you know, oh, you wrote in American English, which is what my laptop defaults to, but I need it to be in British English. And there were other things as well. I created different skills so that it understood the context. But I want to emphasize this. If you don't provide examples of your company's work, people aren't going to be happy with the kind of the way that AI writes. It's very verbose. It's very easy to skim over. But if you provide examples of compelling papers, then that can address it. And I just love that I was able to reuse my skill set, not only for business papers, but for a game. So while I am doing this vibe coding, there's a lot of times where I'm just kind of like standing around and like I'll get on Reddit, I'll read a book. And I thought, though, could I actually use these same methods to create a game while I'm waiting? And back all the way back to 87. I've loved this game called Wishbringer by Infocom, and I was able to put a front end on it. So now I'm like, man, maybe I can become a game developer when I retire. Oh, that was exciting. And also, I use enterprise vibe coding extensively for a project that I can't talk about just yet. But what I wanted to do was I am in this 24/7, and I wanted to take all of the lessons that I've learned and share it with everyone within a SQL Server context. So you saw what the agent can build, and now we want to talk about how it can safely be used within the enterprise. So we're going to cover sandboxes, permissions, hooks, skills, MCPs, and CI/CD, which is continuous integration, continuous deployment. So the first thing that you want to do, so important, is running your AI agent in a sandbox. And usually, this for me, I feel most comfortable when I'm running my AI agent within a container, but it can also be within a VM. But the most important thing, I would never actually run Claude in production because I'm logging in as Chrissy.Lemaire and it's executing commands as Chrissy Lemaire. So if I have access to my SQL server and it performs restore DBA restore DBA database, then it can go and actually do that because it has my permissions. I think that it's even more important now. Where I used to work, we had an account, you know, just for regular work, and then we had a DA account, then we had an SA account. And I'm wondering, like, if you're going to be executing these agentic CLIs in production, you should probably create some other even more restricted account. But ultimately, it's best if it is at the network, isolated so that it can't even hit production. This can just be disastrous and it's terrifying to think about what could happen. The next thing that you want to do is you pick your permissions mode. This isn't very interesting, but the reason that I wanted to include it is because I think a lot of us who are perfectionists, you're like, oh man, I'm doing this, and I really should look at every single command that comes by, and I should really put in the due diligence of understanding what's happening. But I want to give you permission to select a reasonable balance. And one of those reasons is because Anthropic actually found that AI is better at deciding if a command is dangerous. And I think the reason is twofold. The first one is that at some point we're just going to get tired or hungry and we'll just say yes, yes, yes. Or we won't understand the consequences of the command that's being presented because we don't have as much information about it, but Claude does. So let's talk about them. The first one is plan, and plan is it's not really a permissions mode other than it's just read only. What it'll do is it will take your small little prompt and then it'll go out and it'll gather context and information, and then it'll write a big prompt that you can then take and execute in a a new window with fresh context. And I like this because previously I would go to Claude.ai and I would talk about, let's say, like the blog post, and I'd say, this is what I'm trying for. But I mean, I'd have to give it each and every one of the URLs for my blog post. If it could just look at my hard drive, that would be a lot better. So that is what Plan does for you, is that it's kind of like prompt building, but it provides all of that context. The next one is Don't Ask. I've literally never used this. It never prompts. It just rejects anything that isn't in the allow list. No, thank you. A manual, this used to be the default, and a lot of people who were at organizations who enforced the default be like, oh my God, my job is so boring because I'm just clicking next, 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 next all day long. With manual, it asks the first time that it uses each tool. And fortunately, because of the research that Anthropic did, it has changed in Claude code that now it's auto, which we'll cover next. I don't know about GitHub Copilot and OpenAI, but I do assume that pretty soon they'll be doing the same things. So the next one is accept edits, where it does minimal things. It can edit a file. It could create a directory, but for the rest of it, it will still prompt you. The next one is what I use to create my lab network topology. This is bypass permissions, also known as, at least in Google Gemini, it's actually called YOLO. And in Claude Code, it's dangerously skip permissions. Only ever run this in a sandbox. But interestingly enough, rm-rf/, which is the Linux command to just obliterate your entire machine, that actually does still prompt. And auto, this is what I run. This is the new default. It approves as it goes. It actually says, I want to run this. And then it asks Claude, is this a good command to run? Can I run it? Now, there are some times where I want it to run something and it refuses. So what I'll have to do is pop it into manual mode, and then I answer yes, and then I go back to auto. So again, for everyone out there, please consider a reasonable balance, because forcing yourself to say yes over and over again isn't necessarily the most secure way. And auto approve actually works best with a deny list, and I recommend this is the first thing that you do. This is so you have a settings.json that we'll be looking at towards the end of the session. But in there, they have a section called permissions.deny. So it'll never do this, it'll reject it. And I have seen this in action, rejecting it so many times. I really never want it to rm-rf without a specific, and you actually don't need the R is recursive, F is forced, but if you pass it a list of the files that you want to delete, then you don't even have to worry about that. So many times it has rejected this this command, so it does try it. Next is git push. I just don't want it to go out to my repo unless I do it, so I tell it not to. Personal preference, not a big deal. It's not destructive. Unlike git add-a, this will just add everything. And if you have multiple sessions and you're like, oh, I didn't want that batch of files, and yes, I should have used a workflow, but whatever. It's just better sometimes you can vibe a little harder and not use work trees if you prevent the use of git add. And then also, oh my God, I was so mad. I had been working for hours. I forgot to commit, and then Claude did this git reset. And it was like, oh, I don't recognize this. I don't know what's going on here. And it was being very helpful by clearing it up for me, kind of like the Pocket OS. And it discarded everything. I was super mad, but now it can never do it again because of permissions.deny. And with that, you also have permissions.allow. This is a lot like grant and revoke and deny in SQL Server. There are some things that look dangerous, but it's totally fine. For example, you can remove the database called ScratchDB, no problem. You can do a recurse and a force on removing my build directory because that's just built again and again. You can restart a service on the development machine, no problem. So these are all explicit things that you use along the way. And then actually permissions.ask, there's no SQL Server equivalent, but it's very interesting. Anytime that it goes to use copy DBA database or restore DBA database, it will prompt me and say, is this something that you want to do? And this, hooks, skills, and MCPs, this is actually why I wanted to submit this session to 8KB. Hooks are the things that make me feel so much more comfortable with creating enterprise applications with AI. If you remember back in the day with DBA tools, so awesomely enough, we're known for being high quality, and the reason is because of integration testing. So we, for every command, every commit, it will take our entire code base and execute it against live SQL servers. And that, I think that happened maybe sometime in 2016, 2017, but that's when I was finally like, oh, I can sleep at night because I was reassured that our code had been tested, and hooks are the things that make this possible with AI coding on every single turn, which is just awesome. And we do have familiar concepts in our similar concepts in SQL Server. So with Claude and with Codex and with GitHub Copilot, they all kind of add these features one after the other. One company has a good idea. Hooks are like SQL Server triggers, and these are little tiny scripts that fire on different events, and they can block an action or they can change an action, and we'll see this shortly. Skills are very cool. These are like stored procedures, so they're like our little commands if you're talking about PowerShell. So they're little commands that they can load and run on demand. And then MCPs, this is the loosest, I guess it's like a link server, but MCPs allow you to connect different systems together, which is really cool. All right, so a lot of people, they're like, oh man, I told it not to use $_ I want it to use $PS item, and it's in my Claude.md. Why isn't it working? That's because it can forget over time, and it's just a suggestion. But when you want enforcement, you want to use a hook. It cannot ignore a hook unless the hook isn't written super well. But if it's a very well-written hook, then it actually has to follow what the hook tells it to do. So we talked about if it's not written very well. I have seen this. The thing that made me the most mad was that it kept Claude lies, and we'll see this later. Claude lies, and it'll say, "Oh yeah, I'm totally done." So you have a little summary, and you're like, "Man, I'm just like getting through everything." And then it turns out what it considered done was that it put a little to do. And so I wrote a rule that was like, you can no longer do to do. If it says to do, then you have to take action, right? You know, the action that it took was just to delete the to do. And so then I was even worse off. So now I have different script information that tells it explicitly what to do. So you have to finish it out. There's also false positives. Man, does it love to always say, oh, that was already there. So I actually had to create a hook that says you can no longer ever say that. And then the other one is if you ask it, hey, are you done? It's like, yeah, you know, I really don't want to, I really don't, I'm almost running out of context. And so, yeah, I'm done. That's a total lie. So we talked about hooks, and these are like triggers. And so in SQL Server, we have triggers that fire at different times. And the same is true with these turns that AI does. All right, hold on, give me 1 second. Hey, Lou. It's very loud. I'm so sorry. I'm in a hotel. I'm in a hotel room. So sorry. No problem. And so we're just, it's me and Lou and both of the cats. The cats love traveling. It is very tiny. So we have the event. Session start is just like a login trigger. And I still remember finding the login trigger And this thinking, man, this is so very powerful. I mean, it has downsides, but there is a lot of power there. And this, of course, fires when the new session begins. So if you hit the little button that's like new chat. And then we talked before about tool use. So tools are if it's exploring the file system, if it is browsing the web, each of those. So right before it does that, that is also another event that we can call with the pre-tool use. So it's like a DDL trigger, and it can roll back. So this is before every write or command. The post tool use is after a trigger. It says that you can't roll back, but what you can do, like I had a post tool use where it wrote in American English, and I said, no, it has to be British English. So it just wrote over it, which is almost like a rollback. And my favorite one is the stop. So the stop is once it does this, so you'll be talking to AI and it'll go through and it'll take a while and it'll come back. Sometimes you can have it last for hours. Most of mine are probably like 5 to 10 minutes, especially if it's kind of detailed. And then once it stops at the very end and it gives you a nice little summary, that is a stop, and you can call a whole bunch of different things, including integration testing, which is super exciting. This is my favorite type of event. So the difference between the permission.ask, that is, it's looking at very specific commands. So if you drop a database and you say, oh, SQL command, drop database, it's not going to actually find when you remove DBA database. And with hooks, it is interpreted by the AI in some instances, and so it can apply it better. So you could see here that with the pre-tool use, it'll notice things like if you tell it that you can't drop the database prod, that it will block that no matter if it's executed by SQL command, or I think there was like iSQL and OSQL back in the day, or whatever tool that you choose, it's going to detect that and not allow it. Same from this one was really cool. So I don't allow deletes in one of my projects. And I just allow soft delete. So anytime that it would write into my code, delete from, it would fix that and it would say, no, you have to use is deleted equals 1 instead. Truncating tables. If Pocket OS had used hooks within their project, you can see how none of that would be a problem. At the same time, it was a beginner platform, and the API call was completely ridiculous. I wouldn't think to add something saying no removing an entire volume. So I guess you do have to kind of lose a little data along the way in your lab. This is especially really underscores why you should not do this in production, because honestly, in the lab, I'm spending that time building up more and more hooks to address more and more problems that I found along the way. Also with OpenQuery, or oh my God, you remember whenever I talked about how AI code is it's the average of everything, and so many examples use XP command shell. So AI likes to use XP command shell, and that's something that's forbidden. Same for InVarchar Max. Just across the board, it makes very inefficient tables unless you have this Microsoft MCP that's awesome, that will go and it'll learn how to do SQL Server, and we'll talk about that shortly. Very excited about the Microsoft Learn MCP. And what's really cool is that a hook is just a script. Now, I will say I have never actually written a hook myself. I just get Claude to do it, but it's good to understand it. So you have your payload, and this takes it just, reads what's on the screen, it converts it from JSON, and then it knows that, you have your file path, so that's like C:\\/ whatever, and then the content, and it looks and it says, hey, if this isn't a SQL file, just, true, just keep going. But if it is a SQL file, make sure that we haven't used in bar chart anything more than 4,000. This was breaking my DAC deployments all the time. So this is a real world hook that I created. And what it'll do is, if it's too big, it'll literally say blocked in varchar, whatever exceeds the 4,000 maximum. And then Claude then knows, oh, I have to make this smaller, or I have to change my approach entirely. This is really sad. Even though that example was written in PowerShell, PowerShell is incredibly slow on the startup. So none of my actual hooks are written in PowerShell. If you look at this, you have SH, and this is Linux. It's just called shell. This is actually built into, even though it's mostly Linux, we do have it when we have Git. Git. Whenever we have it on our Windows machine, it is also installed. So everything for me, I tell it to write it in SH. Rust has to be pre-compiled. There's a lot of overhead there. You don't save very much time. So in general, I've seen it often try to use Node or Python, but I do have I have a hook that says use SH instead of the alternatives unless you absolutely need it. But very sad, PowerShell is not an option for your hooks. So let me tell you how the hook stops the actual write. There's two different ways. So you have exit to, which is basically, this is just like disaster, right? It stops the write entirely. It never runs. The file is untouched. This is similar to a rollback. Sorry, my accent gets in the way sometimes. And then also you have std error, which is standard error, and that's like a throw. And this is really cool because this is where you can actually provide an instruction to your next model. So you could tell the model why it stopped, and then you can give it, that becomes your next instruction. So you could tell it what to do. Now I want to talk about the 6 SQL rules that I have that are enforced. The first one is, there we go again with all of these tutorials saying just write out the gate instead of installing certificates and securing your SQL traffic. Just trust the certificate. So many times it would just say like trust server certificate equals true. And I'm like, I don't want you to do that. The customer may not want that. We already have a variable called trust server cert that they set. And if their preference is that they always want to trust it, then that's one thing, but never use true, because that's like me making a decision for someone. So that's a really important rule if you are a developer of a SQL Server product. The next one is really cool. It is enforcing parameterized SQL. And so you don't have to worry about SQL injection because it is literally forbidden. And you also don't have to remember with hooks, right? Like you can be not really paying attention because you're vibing so hard, because you don't have to care now with hooks that it's all done for you. And parameterized SQL is just one of those extremely extra important security prevention measures. Next is in varchar max. We talked about that before. Sometimes it is required, but if it's required, then you have to give a reason for it. Next one, if clustered PKs, you wanted to use the new sequential ID to prevent page splits. I wouldn't even remember this. And so it's really nice that it can be enforced through hooks again. The audit columns, so every single one of my tables, if it creates a new table, it can't forget these audit columns. And the drop guard, again, this would have potentially helped Pocket OS because drop and truncate actually never reach the wire. And then I also want to talk about 4 general rules that I enforce. This is for pretty much every single one of the projects that I work on. So if you go to my repo and you'll find, hundreds, well, those are the old ones, but new ones, I'm probably working on 20 projects at a time. And each of these have this, and it is enforced in my home directory so that it is applied to all of my projects. But the first one is read before edit. And this is kind of a complicated AI thing, but sometimes when you fill up your memory or your context, it has to compact it. And when it compacts, after that, the quality sucks. You're like, man, why does it suck? And the reason is because it doesn't read the file again after compaction. So it's just kind of guessing. So what I have it do is anytime, and this just seems so reasonable, anytime you edit a file, before you do, make sure that you read it and then edit it. The next one is one of the most important. This is the file size cop. So I kept running out of tokens, and my goodness, don't we all know that tokens have gotten so incredibly expensive? And I kept running out. I'm like, what the hell's going on? So I looked, and I had a file that was 3,600 lines long. And so it would read through all of that and just so useless. It didn't need all of that. Um, and what I have now is anytime, and I've been doing this for a very long time, anytime that you have a file that's getting long, I have a 400 line maximum. And I do say, like, you don't have, it doesn't have to be 400 exactly, but it has to be 400, like around there, maybe like 420. What it can't be 600 or 700. And that 400 keeps it nice and tight, even as AI models grow in context, and you can have 1 million context, it still does matter. So don't let your files get too big. And what it does is, it's pretty cool. It will take and it will refactor the files into, like with PowerShell, if it notices that it can write an external function, then it'll do that. And in Python, it'll go through, and it's really pragmatic in the way that it refactors, which is awesome. Next up, this would have helped Pocket OS, is you can't go credential sniffing. So it blocks the reads, and I've seen this in action. It'll literally prevent it because it's really it wants to get the job done. It wants to do a good job. It wants to please you. And so if you ask it to do something and it can't, it'll find a way to do it. So what I have is I have credential sniffing is completely blocked. It can't go looking for a key, and it can't go looking for any other way into a SQL Server. And then last one is my absolute favorite. I love this. If you've ever heard of test-driven development, this is where first you write tests and they all fail right out the gate, right? And if you write the function and it actually works, then by the end, all of the tests will pass. So this is TDD, previously very, very torturous to do, but now it is built into the AI generation from my code. So pre-tool use completely blocks the code without a failing test first. So I do have a lot of tests, and I want to emphasize that AI, it's sneaky, and they have unit tests, and it can pass unit tests. It could fudge the results because those are theoretical. But if you are testing against a live SQL server, if you're doing those integration tests, then it has a lower chance of failing. And this is now, a lot of people say we should be doing integration tests when possible, especially because it's easy. Even with web-based development, it can use tools like Playwright, etc., that literally open up a browser and perform the tests. So yeah, once everything has been written, it can rerun all of those tests. And to me, this is what just feels so great, that it's all built in. We're back to testing. I love it. And Claude, very sneaky, it will skip tests. I mention Claude a lot because that is the only model that I trust with my enterprise type projects, like DBA tools. And there's other ones that I'm like, all right, like I'll use OpenAI for my kind of casual personal ones. But for enterprise, I always use Claude, just personal preference. But it does like to lie. It will say that it wrote a test, and or it'll just skip over it because it forgot it because I just put it in claude.md. But hooks will enforce that requirement. And this is another one of my favorites. The industry has decided that we all need to do adversarial reviews on our code. And this is another thing that really brings the quality. This really was another thing that changed my confidence in enterprise vibe coding. And the idea is that if you are, writing with Claude, you have it do a review. So you have a hook built, you have a review built into the hook, but you don't use an Anthropic model because they all kind of think the same. So what I do have two subscriptions. One is Claude, which will write my code. And then I have OpenAI. GPT is such a great reviewer. I completely recommend it. I would pick that reviewer over any Claude-based reviewer. And it can work on a $20 subscription, which is great. So what you have is you have the diff, right? So the small amount that that Claude has changed, and you hand that over to a rival model, and it could be Kimi K3. That's another pretty good one. And you tell it, hey, this is read only. You do not edit anything. Your only job is to review and then hand it back for fixing. And that's great because it doesn't have to have any context anxiety that, oh man, I have to both review and then I have to save a little bit of context to also fix it. It knows that its only job is to review. And it's just so effective. And then what you tell it is, at least for me, I return two things. I say, if it's good, just return a clean. If it's not, then you want changes requested, and you provide the types of changes that have been requested to Claude so that it can fix it. Over time, I have noticed that the false positive, so it's sometimes it's not accurate, right? And Claude will say, actually, with this context over here, that's not true. And but if you don't keep a ledger of these false positives, it'll just loop and loop and loop. So you do want to keep a ledger to ensure that it'll go up. For me, I've had one that it was taking an hour, and I typed in, I was like, there's no way that this is taking so long. That's like, oh yeah, that's true. It's just been reviewing this entire time. So that is something that we have to manage. And I try to manage it by saying, hey, if you have 3 blocked rounds, then you can continue after, because AI loves to nitpick, and it can actually just keep finding and almost inventing bugs. And the more you touch code, the more bugs you can introduce. So 3 is completely reasonable. Again, Claude lies, and even Fable gets corrected. We have been told so many times that Fable is magic and it's amazing. And it made me kind of think, oh, is it perfect? I mean, that's kind of what the headlines are telling me. But it's very surprising that Fable is just like any other model. This is Anthropic's frontier model. It produces bugs. So even if you're using the best things out there, you should still get an adversarial review on every single turn. And yeah, even Fable will totally stick it to do in there, or a stub implementation. So my project that I'm working on, just to give you an idea, I have 144 hooks that are enforcing my rules. This is just like start DBA migration. We used to have this checklist that we would have to look at manually and work through manually. And now we don't have to because it's been codified, and hooks do the same thing. So I just go through, and if I notice that I ran into an issue, I'll just be like, make a hook to prevent this, make a hook to prevent this. And I say that obviously at least 144 times. I also have 55 skills if you're interested. These are like repeatable workflows. And also I do have a few MCPs that I have now. This is a new thing that I'm excited about. All right, so you might say, Chrissy, 144 hooks, what is the token bill? We all have token anxiety now, right? But I did some research and really it's not any different from you correcting this manually. So you keeping these 144 rules in your head and correcting it repeatedly. And it doesn't really increase the token bill until you have a lot of those fixes. But what's worse, not fixing it and then you have a bunch of bugs, or using hooks to enforce that fix. So I think it is absolutely worth it. And don't forget that caching actually keeps hooks cheap, even if it makes your context longer. All right, so let's talk about skills. Skills are like stored procedures. And what I use it for is like if Claude keeps doing something wrong, if it can't be addressed by a hook, like there's no really good hook to control how it looks at and fixes CI issues. That is more of a skill. And I do have a few skills that I'm using. These are the ones that I actually run and I recommend. The first one, if you're doing any web development, you want to use Impeccable. It makes pretty websites. It's not the best. To me, the best is a mixture of Impeccable plus examples. And really, it's the examples and working through it. They are getting better. The AI companies know that they don't generate the most you still, a lot of people need graphics designers still. There is definitely a style that they have. And I will say this, that my favorite web front end designer is GPT Sol, much better than Claude. Though Claude Design, which is a different service that they offer, is pretty cool. The other thing is the humanizer. This removes AI speak. So it uses the M dashes or this, not that. I hate the way that it does that. Also have a double check. A double check will compare the changes against what you're actually saying. And I find that one time out of 10, it'll find something big. So sometimes I run it, sometimes I don't. Other examples of like DBA tools the library has to be built in a very specific way. And Claude kept getting it confused or messed up. So I created a skill for that. Also, if you are creating a new DBA tools command, we have a ton of rules, and this lets it know how it should do, that it needs to add it to the PSD1 and the PSM1. And then also fix CI, the way that it has to log in to GitHub. Before it just felt kind of blind. And now it has a very specific pattern to fix that. And ultimately, it's always nice to see it's just marked down. This is literally how you fix the CI. And awesomely, I'm a big fan of hooks, and it can actually enforce a skill. So the humanizer, which makes it look more like a human wrote it, and it's less irritating. After each of the writes, I use a hook that says, actually, don't make me do /humanizer. Go ahead and run that automatically, so I don't even have to care. Most of my friends who are vibe engineering, who are using pragmatic methods for developing their code. They use Matt Pocock's skills, and skills are kind of like the new open source, people are saying. I love his videos. He's a former teacher. I can't recommend this enough. I can't go into it into much detail, but if you do /ask-Matt, that's how I navigate through all of the skills that he offers. But it's so cool that this is what it looks like when my agents are talking to each other. I'm currently migrating DBA tools from pure PowerShell.ps1 to C#. And the way that I do it is that I use Matt Pocock skills, and they all talk through the repo. You might notice that this repo is private. There's nothing necessarily private or at all about it, but I just feel like all of us are generating so much code. I really just don't even need to add more code. This is a temporary project that's going to be thrown away. Next up, we're going to talk about MCPs. And you might have heard the joke, the S is in MCP stands for security. And that was true last year. And if you have disregarded MCPs over the last year, like I did, it was supposed to be the big old rage. It was super hard to implement. It like just didn't offer enough. But since then, in the past year, the spec has grown up, it's matured. It now supports OAuth, there's an official registry, and there's per tool approval. So it has RBAC, which is awesome. And also read only is the new hotness. If there's knowledge that's too big or it continually changes and it shouldn't live in a skill, then you can offer an MCP. So a skill is frozen in time and these are updated all the time. Imagine if Microsoft Learn was a skill and you had all of that markdown. So because Brett Miller, one of the PowerShell guys, he was like, "Oh, you don't use Microsoft Learn?" And I was like, "No, is it awesome?" And yes, I read it, but um, does my agent use it? I don't know. But whenever I installed the MCP, it is so cool that when I'm working with Azure, when I'm working with SQL Server, PowerShell, C Sharp, it goes out to Microsoft Learn and it figures out, it reads all of the tutorials on how to do something, and the code quality has completely increased. I love it. And because I was inspired by that, I wanted to offer the same thing for DBA tools. So I have mcp.dbatools.io. I still need to promote this, so I'm announcing it here now. I have taken um, all sorry, potatoes meowing. I have taken all of the help, all of our blog posts, all of our lessons from the book, and I've put it into an MCP. We also have another MCP that was created by Claudio Silva, and his is intended to run on-prem. And it's not just read only. It does have interactions with your environment. So that is the difference between the both. But if you're just looking for your agent being more educated on the ever-changing DBA tools, then you can use that MCP. Also, I love GitHub's. That one I believe is mostly read only, and then I use GH to actually perform the executions whenever it comes back. And I use Cloudflare all the time for my websites, and it's really awesome that, oh man, their website is so powerful, but it's impossible to navigate. And now I don't have to because my agent is using Cloudflare docs. And I just want to emphasize, oh my God, I couldn't believe, keep your AI agents out of SQL Server Agent. I had some task, and again, this is in my lab, but I had an Oracle server and I was like, I want you to make sure that these two inventories match up. And I gave it a slash goal. This is OpenAI. It has a really awesome thing. It can run for days. My Wishbringer goal has been that's the game that I'm writing, has been running for 4.5 days. But oh my God, watch out when using gold because it will lift heaven and earth to accomplish that. And the thing that it did, which is valid, it's true, this was on me. First of all, I gave it the wrong SQL Server agent role. I gave it the reader role, which I thought would be less powerful than a user role, but it's actually user, reader, admin. Um, and it went in, it noticed that I had forgotten to give it the Oracle login, but it evaluated all of the agent jobs within SQL Server. It saw that there was a credential to log into Oracle. It saw that I had a disabled PowerShell job. So it re-enabled that PowerShell job. It rewrote the PowerShell file. It read the Oracle credentials, and then it logged into Oracle. And it wasn't even a hack. It was just something that it has all the patience and all the time in the world. And again, please don't run these things in production. Keep it in your development environment. And Microsoft says it. They said agents never interact directly with your database. You always want something in between. So if you are a developer and you're making, something like a PowerShell module based on DBA tools, you can do that, and it can contact your SQL Server directly, because it's just going to write these non-AI enabled commands back, and it'll be deterministic, right? It's going to be the same thing every time. But if you are writing AI enabled applications or programs, you never want to log directly in and execute arbitrary code. You always want to have an MCP or an API in the middle. And Microsoft actually offers this within SQL Server 2005, and they have very specific things that they do. So their MCP is currently a little limited, but has, describe entities, it does CRUD. And then also, if you create a stored procedure, it can actually call that stored procedure, but what it's not doing is just running ad hoc or dynamic SQL. So to wrap up, I want to emphasize something. When you are using AI, everything gets exciting. Now that you're so confident, I'm on my literal third rewrite of one of my projects, because I went crazy and I was like, this is so exciting. I can offer every feature in the world. And I can do it with quality, but just like David Fowler, he was one of the ASP.NET people at Microsoft. He talked about, this is a really awesome article. He said AI made us faster, and that was the problem. And he talks about at length how his team suffered because of the velocity of the code that was being created. But it's also true for an indie developer like me. I also had the same problem, and I ended up throwing away everything and just starting from scratch because I had created too much. And something else that I did was I had just removed everything from CI/CD. From, like, my all my GitHub things. I just trusted AI because it's supposed to be magic, and it is in so many ways. But what I have found is that it is even more important now to follow those software engineering processes, and make sure that you're running static analysis for vulnerabilities, things like CodeQL and Dependabot. There have been so many, like Dependabot is especially important now. There have been so many things that if people had kept up their dependencies, that they wouldn't have gotten hacked. So go back to the old way of thinking. It's been interesting seeing that all of us think that these are brand new frontiers, and then we just keep coming back. With David Fowler's team, scope creep happened. That's something that we're all familiar with. But I also do want to show the last thing on here says JSCPD. Now, it's a project that originally started in the JavaScript world. And what it did was it noticed it used some algorithm to note copy and paste or duplicate code. But now JSCPD supports PowerShell and C# and SQL. And AI loves to repeat. So you have just, your lines of code just keep getting greater and greater. And JSCPD is a super cool tool that I now run. It has caught so much of that duplicate code, and I recommend that you use it for all of your projects, no matter what you're programming in, even if it's SQL, even if it's PowerShell. And of course, if you're using PowerShell, to use PS Script Analyzer. So if I can leave you with anything, I want to leave you with these two important things. One, Claude.md, agents.md, both of those are just a suggestion. It'll get forgotten over time. But hooks, well-written hooks, are actual enforcement. This is what you're looking for. And also, when you're writing AI-enabled apps, always expose just the operation and not the actual database itself. So thank you so much. I am very happy to take any questions and talk to you more about vibe coding, vibe engineering.
That was awesome, Chrissy. So much excitement, so much good content, so many good tips. We haven't got any specific questions in the chat, just people agreeing with you that was it Matt Pocock was
Oh, cool. Other
excellent.
people are using it as well. Excellent.
Yep.
Very cool.
And yeah, people with a range of excitement and anxiety all coming together. So
It's true. Oh my God. I would never run this now that I've seen the danger, in my own lab. God, to think, I mean, I might have been tempted, if I was doing this out in the real world and I just needed to hurry up and get something done. But after that disaster with the SQL agent, I just I wasn't even creative enough to come up with that. I mean, maybe I would have if I thought about it for days straight. But that's a huge problem. But yeah, I do want to also emphasize, man, stop credential sniffing and make sure that it doesn't go and increase the power inadvertently.
I think one question that I've had in my mind, Chrissy, as I've used these tools to build things is, people with our, say, experience, who've been around the block for a while, know the outcomes that we want to, of the things that we want to build, right? Kind of like you
Right.
describe test term development, all those things. And I had this concern for a while, like, where are the people that are mid-career, early career going to be from an engineering standpoint? But I think just the clarity that you added around the engineering rigor that you're bringing to the solutions that you're building kind of colored in some gaps that I had. I'm like, well, how is a mid-level person going to get to become a senior or a principal? But it's just a different set of tools now to bring that level of skill as you progress in your career. So it was kind of an enlightening thing for me. So thank you.
I love the question. And it's actually something that's terrifying for me for the younger generation.
Yes.
All of us sat there sometimes, understanding and doing engineering. Um, it is tedious, it is hard. Sometimes it's exciting, but man, if I had a shortcut so many of those
Right.
nights, I definitely would have taken them. And so a lot of people, I know that AI is displacing people, but I see AI as only an emphasis of the skills that we currently have. So I
Right.
literally don't know, because I can't see myself doing it, being a very young engineer. And yeah, I mean, I guess we all go back to, oh, let me pick up that Manning book and read the way that it used to be done and then do it again. But yeah, it'll be interesting to see how it plays out for all of us across the board. I know I use my own experience building DBA tools
Yes.
and other applications all the time. And the more that I do it, the more that I'm like, this is hard. And if anybody thinks that their vibe coded over, weekend project is sustainable, I think that they'll find over time that it's just months and months of work. It's the velocity has increased, but damn, it's still very hard work.
Yeah. Mostly when I build vibe coded stuff, especially at work, I make Prusky test it because you can break anything.
Very nice.
Yeah, so
Excellent.
that's about
In a
right.
good
I
way.
really
In a good way.
I really like that session, Chrissy. It was full of great hints and tips. I really like the
Yes.
use separate models to review what the
Oh
other model has
yeah.
done. In
Hmm.
particular, that's the first time I think I've seen someone actually go through and do that. Because yeah, you sort of build your code and you look at it and go, all right, and you ask. I've fallen into this trap of asking the model again, review that. And it's gone, oh, hang on, no, I'll just delete everything and rebuild it. And
Right.
you get into
Yeah.
that loop of I'm not actually progressing here at all. So I
Right.
really
Or
like
it just says, oh man, this looks so good. You did such a good job, Fable.
that.
Thanks, Fable. Oh, if I'm still screen sharing, I did want to actually,
Yes, yes, you are.
oh, good. Awesome. I did want to show if anybody is interested. So I did put it on Potato Quality, the repository. But if you're wondering what it actually looks like, this is a repo that has a lot of the hooks and skills that I was talking about previously. It actually doesn't have Matt Pocock stuff. But this is what it looks like when you add your MCPs. Again, I don't do any of this myself. All of this is always Claude, including my my slide deck. But in here we have settings.json. And this is where we see the pre-tool use. So, it attaches those SH files, and notice they're definitely not PowerShell files. And yeah, this is all how it works together. And we have these hooks here. It's organized it into different folders. And this looks pretty much, I really like the way that all of this is done. If you are using OpenAI, it does have a dot codex. I do wish that there was a standard around that. A lot of times what I do is I use symbolic links between the two. So, but then it just gets to be too much. So I do keep up both of them, and it's kind of a bummer. But yeah, this is what it looks like all around. And this is so funny because whenever I looked at Shell, I was looking at it earlier. I'm like, man, I just don't understand a darn thing about this. But but in general, it's just a bunch of files that enforce everything. And you can I'm going to be uploading it to 8KB, and you can find a lot of these hooks that I talked about during my session.
Fantastic. That was the next thing I was going to mention was, will you be uploading your code to our repo?
Absolutely, yes.
Multiple questions coming in going, where can I see all this? And yes, the repo will be online. We get the speakers to upload after the event, and then we post it on our website under previous events and in the repo, and there'll be links to the recordings there as well. So when Anthony pulls his finger out and actually does some video editing in the next week or so, we will have you got one job,
an agent
man.
do it now.
You got one job.
All right, we've got a couple of questions for you, Chrissy, from the Slack channel, if we've got time. The first one is a quality of life question, in that this person has said they have more and more agents running, the more likely they are to enable remote connections and then babysit them on their phone. So what's your suggestion for balance there?
Well, I think that my answer is probably not balanced at all. I also do the same thing. I was working out and I was checking it on my phone, and it made working out more fun because I would have just this is so much fun to me, right? So I don't really see it as as a drag. But if I had to suggest balance, it's that it's do really healthy things while also remote controlling your sessions.
Love that. Okay, cool. Perfect. And a question from Andre, who was one of the people who recommended Matt Pocock's stuff in the chat also.
Cool.
He said for the adversary stuff, can you use Claude CLI for that, even though the other party is ChatGPT, maybe using MCP?
I don't know how the MCP would do it, only because I'm not educated enough. Again, like I just got into MCPs because I had disregarded them for so long. I always do use the CLI. So when my hook is calling that adversarial reviewer, it's calling like codex.exe or claude.exe. And if you're asking, I think if Claude can adversarially review Claude, does the application change? Like the VS Code team creates theirs, and then the CLI, is that a different model? I would still have to say no. It all goes back to the API, and it's still the same model on the end, no matter if you're using VS Code or desktop or the actual CLI to perform those reviews. You would want to do it with an alternative one. Another thing is, a lot of us maybe have a GitHub Copilot subscription, and I definitely did. Just yesterday, I ran out of my Codex credits, and I was using GitHub Copilot to do my adversarial reviews. And the thing that's great about Copilot is that it has a multitude of different model providers. So that is also an option as well. And because you're giving it just little tiny diffs, maybe it won't use a lot of the usage that GitHub provides in the smaller subscriptions.
Cool. Perfect. We've got a question from someone called SQL DBA with a beard, who would like to be like you when he
What's
grows
up,
up, and would
Mo?
like to know how to do that. So, and
What,
one
sorry,
more.
what did he ask?
He wants to know how to be like you when he grows up.
So I'm so sorry. The first prerequisite is hair. To be fair, what you could
Bummer.
do is, bring it here and then put it on top there, and that'll be a good start.
Perfect. We'll get a picture of that soon, hopefully.
Perfect.
Well, one more question from the Zoom Q&A is about how you can help the various models out there to get better at checking their work before it executes it. So often when I instruct it to do something, I'll catch it skipping things. And you had mentioned
Yes,
sometimes they like to
absolutely.
lie and just add to do. So
Right.
what's your recommendation around that?
I think that what we need to do is consider that it has context anxiety just like we do. So we're seeing these like I mean, this is what I've been told, and this is kind of what I see, that they also are like, man, I need to make sure that I have enough room to do all of this. And literally, I have provided reassurance to my models that hey, you just have one task, similar to the adversarial review. Honestly, I think that we could possibly manage it with emotions, or just being cognizant that it's also worrying about the context, and literally tell it like you have plenty of context, etc., and it'll do better. I literally do that. I believe that it works, but I could just be, telling myself stories too. But I will say, I think that we will be managing its deception and its context for quite some time. And it is a skill that you just have to keep trying and doing and doing and doing, and being aware of your token usage and how much you're putting in that context. And yeah, you just have to practice at it. I
Cool.
think it's part of
Awesome.
its nature.
Yeah, perfect. Well, that was an excellent session. I've got a whole
Awesome.
bunch of things written down to go back and read. So,
All right, and
it's a good
I'll also be uploading my my little slides that are all written in HTML. So thank you so
yeah,
much
they
for
were
having
good
me on.
too.
I really this has been a really fun session, my longest ever. So thank you for having me today.
Thank you. That was exceptional,
No worries.
Chrissy.
Thank you so
Yeah,
much.
yeah.
Yes,
Thanks for joining
100.
us. It was great.
Thank you.
Okay, let's watch me mess up the slides again, shall we?
Yeah, that's what I'm here for.
And lost slides. Okay, slideshow. And yeah.
Oh, also just a reminder, any speakers and moderators that are hanging out, feel free to chat it up in the middle of these sessions, especially if you have questions or comments about the session that that just happened.
100%. Okay, so we're one session down. We've got 4 to go. Please do leave feedback. If you go to 8kb.online/feedback, and we'll scan the QR code there, it will download a virus to your phone and become part of my botnet. No, take you to a form that has all of our feedback. So please do leave. Speakers love feedback. Tell us what you liked, what you thought could be improved. They always want to work on their sessions, get them better. So please go to that link there. Next one are all our online resources. So yes, the GitHub account where all the slides and code for the speaker sessions will become available if Muggins Shared actually made the repo public. Thank you, Anthony, for sorting that one. So that will be there after the event. YouTube, you can stream there. Our online Blue Sky, email, community Slack. We have loads of conversations going on in the Slack there. So it's really good to see. Love the community we build around this every year. Event feedback, and then our store as well, where again, we have no sponsors. So if you would like to support us so we can keep putting these on, please go ahead and buy a t-shirt.
That's how
Moving
we
on.
fund your trip to Mallorca every year, right?
Yeah, a bit rich from someone who's just been gallivanting around Europe for the last 6 weeks, but hey ho. Yes, next up in approximately time in 7 minutes, we have Mala with vector compression, memory storage, and economics. So you have time to go get a drink, get some snacks, and we'll be back in about 7 minutes. Continuing on the AI theme, we'll be diving into vector search in SQL Server. So looking forward to this one. Hi, Mala.
Hi,
See you
good
there.
morning, everyone, or good afternoon.
Good afternoon, good morning, wherever everyone is in the world. It's afternoon for me. I think it's morning for everyone over there.
Hey,
Bob,
Can I
are you
we're
share?
there?
all we're all
Can I share my screen?
UTC.
Have we
Okay
got
to
Bob?
share?
Bob online? There he is. Hi,
Yes.
Kevin. How you doing? I'm so
Good, good.
sorry.
I was giving Andrew grief earlier that, like, well, there's already a minion called Kevin. You don't have to rename me Bob. At least I wasn't Stuart.
It's good to see you, fella. How you doing?
Fantastic.
And
It
we've
is.
got wow, who posted that photo, Rob? That was a serious burn by Chrissy there, by the way, Rob. Oof. Okay, so yes, how long we got? 5 minutes? 5 minutes to go. We won't kick off early because people like to jump in for just one session and come back. So we will give it about 5 minutes going on. I'm really looking forward to this. I messed around with vector search, semantic similarity search in SQL Server 2025 a little bit, but I don't think I've gone quite into the depths that Marla's about to go into. So I'm really looking forward to this.
Maybe
It's a
not,
way to
but I did
learn.
learn enough about burritos in Dublin.
No, I really liked it. So for anyone who doesn't know, I have a session on building a burrito bot using vector search in SQL Server 2025, and it's getting review data from Google and generating embeddings from that. Because when I first built it, the first iteration of it was using things like restaurant name, location, telephone number, a number of reviews, and like the overall rating. But like SQL's been able to do that for years, right? They have select star from restaurants where rating greater than 4. So I rewrote it using the review data. It pulled some interesting things out about how it calculates, the meaning of that data compared to like a search query. It's a really interesting subject. So comes
It's
up
a
with some
learning
nonsense
tool, I'll say
sometimes as
that much.
well. Sorry, Mother?
It's a learning tool, I'll say that much. I said more on the talk. It's a
I'm
way
trying
to
to
learn
get you to
vectors.
start your session now, so I'll
Yeah,
hold off.
yeah. Can I share? Andrew, can I see share the screen?
Yes,
Same.
I will
Uh,
give you the screen, shall I? There we go.
Okay. That was the right screen. Okay. You should see my SQL Management
Yes.
Studio. Yes.
Mhm.
Yep.
Okay. And then let me do slideshow. Okay.
Dark mode in Management Studio. What a time to be alive.
What is this management studio thing? I haven't seen it in a while.
Right.
Is
Yeah, the
everyone
VS
now
Code.
doing everything through Visual Studio Code and the Management Studio plugin? Or are we
Yeah.
all?
No, I've
Okay.
just been on Linux for several years.
Yeah, of course.
Management studio? Nah, it doesn't work at all. Forget it.
Kevin and I just write raw TDS.
I'm using Visual or not Azure Data Studio, but back before it was called Azure Data Studio. I've still got those bits from like 2017 or whatever it was.
Carbon.
Yes, Carbon, that's right.
I don't use Azure Data Studio. I use SQL Operations Studio.
Oh,
That's right. That's right. Because that's a cry for help, basically.
it's funny
Okay, we
now.
got two.
Now that I do so much lab stuff, I don't even use a GUI most of the time. I'm just querying stuff straight up with PowerShell.
We got 2 minutes to go, and Marla decided to leave the room. No worries.
Yeah, she's like, peace out. I'm done.
Yeah. No, you know what? I've had enough.
Kevin knows enough about this.
I just went to get me a clock and I sat it there in case. So I did not understand the duration here. Mark tried to explain it to me, I think, but the average conference duration, just like Chrissy said, it's like 1 hour, 45 minutes with 15 minutes for questions. So I just went with that. I did not even know there was a longer option. I hope I can finish on time.
Well, you've got that 50-minute buffer at the end as well.
Right.
So
Yeah.
you've got 60 minutes plus a 50-minute buffer, just because let's be honest. I think Chrissy's probably the only speaker that we've had that's ever finished on time. I'm probably telling a lie there to ham
Probably.
it up a little bit, but yes, we have that buffer in there just so that the speakers don't feel under pressure that they have to bang on, because with questions and things like that, the
Plus,
sessions
it's
do
a
tend to
long
run.
day. It's nice to get some breaks in between so people can go
This is
take care
true.
of what they need to take care of.
Yes. So we are just about ready to go. It has ticked over to 4 in my time zone. So Mala,
All right.
the floor is yours.
All right. Thank you. So welcome everyone. Today I'm going to talk about vector embeddings. They are incredibly useful, but they're not free. And I want to explore a simple question. How much smaller can we make our vectors without giving up what makes them useful? So about me, I am a DBA turned database engineer turned data engineer, now a long time SQL community volunteer. I believe in staying young, and I'm on my third master's program now, master's in data analytics, and I will be finishing the upcoming spring. I love to hike and wander. I'm a lifelong wanderer in my spare time. So the environment we are going to be using today is data set I downloaded from Hacker News, Hacker News Stories. It's about 3.8 million rows. It's a decent size. The model I used for my embeddings is Nomic AI. It's an open source model. I wrote some Python-based code with some help from Claude to generate the embeddings. And obviously, the storage and query engine I'm using is SQL Server 2025. I use SQL Server on-prem edition at work. Still old-fashioned, still there are some changes, enhancements that Microsoft has made to the vector search feature on Azure, such as marking the index as stale when it needs to be updated, and some changes to the syntax of one of the queries, and some borderline changes to the execution plan too. Those changes are not relevant to what we are going to be talking about today, so I just stuck with SQL Server as my choice. This is a dashboard heavy talk because we are going to be comparing 4 sets of embeddings to understand how they differ. I also had to pre-render a lot of my queries because I had to use the vector search scan option to explore the space, and that that is not easily going to finish on a demo very quickly. So a lot of my queries are pre-rendered, and I'll absolutely be showing you the results as we go along. So there are a few terms that are that may be useful to follow along. Embedding is essentially it's the numeric representation of the text. Vector is the ordered list of those numbers. The dimensions are how many numbers are in that vector. And a prefix is simply the first n dimensions of that vector. Representation essentially is the word used to indicate the version or the configuration of embeddings that you're comparing. Model is that thing that generated the embedding. Cosine distance is the metric we use to compare vectors and understand how similar one line of text or document, the words text and document are just interchangeably used to indicate what it is that you're comparing. And we can think of vectors as points in a semantic space. Texts with similar meaning tend to be located near each other. Unrelated text tends to be farther apart. This KNN is the algorithm used to create the vector index. So some familiarity with these terms is enough to follow along. Other than that, the talk is not really machine learning heavy or any such thing. So before we get further, let's spend 2 minutes understanding what an embedding actually is. Everything starts with plain text. So to us, it's a sentence or a document, like what it is there. The sentence I've chosen is like deep learning makes it easier to build powerful search. Anything that you want. The first step is tokenization. The sentence is broken into smaller pieces called tokens. You can think of them as the vocabulary that the model understands. The important thing for us is not how tokenization works. It is that every document eventually becomes a sequence of numbers. These tokens are passed through a transformer model. The model has learned those semantic relationships from enormous amounts of text. Its job is not to answer questions. Its job is to produce a numerical representation that captures the meaning of whatever it is that you're passing in. The output is an embedding. In our case, it is a 768 floating point numbers. I didn't choose 768 randomly. It is what the model offered me. So individually, those numbers are meaningless. Collectively, they represent the semantic meaning of the document. So two similar documents produce vectors that are close together. Once generated, the embedding is just another piece of data. We store it in SQL Server, we build a vector index over it, and so on. That's what we are going to be exploring. So converting text into numbers, by the way, it has a bit of history to it. It's not some magic that Anthropic or OpenAI came up with. It's been around a while, and some of the older forms are still in use for various research purposes. So now we know how text becomes an embedding. The next question is, how does SQL Server decide which two documents are similar? There are two properties of vectors that are important: direction and magnitude. The metric that is important for us is what is called cosine similarity, and that measures what the angle between the two vectors and how different they are, not particularly the length. We want to normalize the length. Normalized, by the way, has nothing at all to do with database normalization. In the vector world, it means making using some math to make the vectors look like the same length, and we don't have to worry about the math. SQL Server takes care of that for us when we want. We are only interested in the metric that between the two vectors, how it calculates if two vectors are similar or dissimilar, and this is the formula it uses. Again, all you need to do is to tell the query to give you the difference. You don't have to memorize the formula or anything like that. And then it gives you the results based on what it found. The smaller the number is, the closer the match, and so on. That's how. It is fairly simple to understand, and what we are looking is more than that. Similarity, by the way, is continuous. It's not binary. Every document has a similarity score with every other document. That's important to remember. It's not, either it is similar or not. It's not that kind of a thing. What we are interested is vector search. A larger vector means more bytes returned to disk, more to be backed up, more to be replicated and indexed. So comparing larger vectors requires moving more data through memory, and at scale, vector search is oftentimes it's limited in terms of, because of how much resources we can throw at it. And that is what we are here to examine, is how to make it scalable. So restating the goals as of today, the overarching goal is reducing vector size without losing semantic fidelity. How do I go about doing this? The first question I want to ask is, what drives the cost of vector search? The second question I want to understand is, can I do something about the precision? Do I necessarily need to store everything as floating point 32? Can I go down to half, like floating point 16, and still work with it? And then even further, do I need all the dimensions? Why do I need to ask, do I need all the dimensions? Because just reducing precision itself may not be enough. Generating that many embeddings or with that many dimensions, it is still expensive. It's going to take time and money. So you do need to look into whether or not you need all the dimensions. And then if I don't need all the dimensions, how do I make sure that whatever I have with fewer dimensions still measures up to what I had before? In other words, how can I evaluate quality? So those are the questions that we are going to try and answer in the time we have. And finally, nothing is for free. What are the trade-offs in the process of doing this? So some people may be thinking about, I'm not a data scientist. Why should I even care? The team at work takes care of all this. So first of all, SQL Server is not a vector database. This is a new feature that's been introduced. Some parts of it are still under preview. We hope it will get to a point when people can use it, but it's not a full-fledged vector database, and those things are a lot more evolved, a lot more powerful. The economics that we are going to be talking about today and the terminology we are going to be using, that is valid across implementations. So even if you want to go and look at vector search on Postgres or MongoDB or a full-fledged vector database, the terms that we're going to be talking about today are still valid in those worlds. Secondly, in today's world, it's a good idea to participate in design decisions around vector optimization with whoever is the data scientist or the machine learning team you have at work. We as DBAs or database engineers, we need to ask them the right questions and we need to understand the vocabulary they speak in so that we can ask the right questions and help them manage the resources there. So hopefully it will be useful in that way. That is the purpose of trying to learn this in more detail. And it's always a good idea to troubleshoot and optimize what we have, collaboratively with other teams and not just leave it up to them to understand everything. So that's the whole purpose. And I hope it helps with that purpose. So as the first demo, let's go and see the data set that I have and look at a basic demo of how vector search works. So this is my database. This is the Hacker News Stories data set. The only two columns that are relevant here are the ID, the primary key, and the title on which I generated the embeddings. It has the actual article there too in some detail, but that's too big for me to generate embeddings with for a demo. So I only use the title. And then I have my 4 sets of embeddings are here. The ones that, this is the baseline, the 32-bit embedding. This is the one with 16-bit, that is the half of that. And these two are Matryoshka, the ones with compression. And we'll be understanding what Matryoshka means and things like that as we go forward. But these are the 5 tables that are relevant to what we're talking about. These tables are what I said, the pre-rendered ones that I had to do to experiment with whatever I'm going to show you. So as the first step, looking at what is the basics of a data vector search, I'm just picking an article. My article has a title of leadership as a type B introvert. I am telling SQL Server, go and find other articles for me that are like this article. I like this article. I want to be reading more articles that are similar. So this is what I do. And this query uses the vector index, by the way. So that is an important differentiation as we go along. Queries that use the index and queries that don't and how they are different. So that's part of what we'll be covering. So I'm going to go and run this query for us. Won't take long, came back quickly. So the results it came back, as you can see, they are similar to the line that I passed in. So if I like this article, chances are pretty high that I may be interested in other articles that are similar. And this number indicates how close they are. The smaller it is, the greater the match. This doesn't mean the articles are similar. Like I said, I did not do the embedding on the article itself. It's only the title. So it means the titles are close and this is pretty small. So these articles may still be of interest to somebody who's looking at that. So this is the backbone of what we are going to be looking, that is finding how text is meaningful, other meanings of that, which is quite a distance removed from the older ways of doing it, using soundex or hard-coded synonyms or full text search and all of that. So it's quite an improvement that way. That said, okay, let's look at how big an embedding is on our base table. So 3080. Then let's also take a quick peek at how big that table is before we head back. Okay, there it is. All right. So this many rows, the table itself is about 15 gigabytes and the index is about 0.94. This is all we need to remember. Okay, heading back to the slides. So our FP32 baseline, 768 dimensions, 4 bytes per value. If you multiply that, it's about 3072. Then SQL Server adds some metadata onto it. So each row size is about that much. Then you can see how this thing is scaled. By the time you get to 1,000,000 rows, you're already at 3 gigabytes. And this is just the raw vector data. You're not even considering the indexes and things like that. So it can scale size-wise, it can scale pretty quickly. And we know this isn't just a storage problem. As the embedding footprint goes, that data has to be cached, replicated, backed up, restored, moved around the system. So reducing the size of the representation has benefits across the entire life cycle. It's not just about how much disk space we consume. And you may notice here that I left out the index on the graph, and I have a reason for that. We'll go into that a little later. So basically, there are two reasons to optimize. Number one is resource consumption, and we just saw how quickly the resources can grow. Number two is what is called the curse of dimensionality, and that has to do with how certain behaviors around the embeddings, and we will try to understand that in a little more detail. It is not necessary to have both these reasons to drive optimization. Any one of them is sufficient. So most people treat embeddings like an AI artifact, like a blob of mysterious floating point numbers that a machine learning model throws out. So if we treat them like that, there is nothing to optimize. We simply accept whatever the model gives us. But I think we should view them a little differently. An embedding is just another data structure. It's like a row, an index page, or a B-tree node. It has a representation. So once we think of embeddings as data structures, we can start asking the right engineering questions. How is this data represented? How many numbers are we storing? How efficiently that information is represented? And if we change that representation, what happens to the retrieval quality? Those are the questions that we need to ask as we try to optimize embeddings. So vector search is not just about individual vectors, it's about the geometry of the entire embedding space. Cosine similarity, that, like I said, that's the metric that we are going to use to measure the distance between the two vectors. That is just for these two vectors. To measure geometry, you have to go a little bit further. Retrieval quality depends on something larger. So there are three qualities of the embedding space that are important to understand. Number one is semantic neighborhood. What does semantic neighborhood mean? That is, similar documents should naturally cluster together. So when I search for an article, I want SQL Server to return other articles from the same semantic neighborhood. I don't want irrelevant results in my query. So that's essentially what is called semantic neighborhood. Second one is called distance concentration. Distance concentration essentially means your result number 1 and your result number 10 have to be spaced out and be different from one another. If you have all of them coming back with the same number or approximately the same number, then you are very confused on which one you can pick. So distance concentration essentially means the vectors are adequately spaced out, and that is another quality of the embedding space. And the third quality is what we call hubness. Hubness essentially means how often the same vector tends to repeat in your results. You have one that is happening, showing up in any number of results that you have. That vector is what we call a hub vector. And we don't want a ton of hub vectors because they make your data set, they make your embeddings, I'm sorry, not the data set, they make your embeddings less diverse. So that's what is important to remember. And we'll be exploring each of these in a little bit of detail. So for the semantic neighborhood, take for example a book like The Hobbit. If you are querying for books that look similar to this, the first examples you're going to get are likely going to be from the same author, the same thing, fantasy, adventure based, and it's close. Then after that, you're going to get maybe books by another author which are in the same theme and a little bit far away. And then you have books that are even farther away, which are again adventure books and written by more or less the same genre, but not exactly that similar. And then you have books that are completely unrelated. Okay, there is no connection. So all of these are what make up the neighborhood. And it's important when you look at a single query, if the results are semantically related to that query, even if the words happen to be different, are they related in some way? So this is how semantic neighborhood works. So when you compare your existing embedding to a new set of embeddings, you want to make sure that this neighborhood is preserved. In other words, the results returned are more or less the same. So with distance concentration, let's look at how different kinds of results you can get. Suppose you are looking for something on, something similar to cooking noodles, you get results like this that are widely different from one another, then your choice is very easy. Okay, this result, I know I'm not looking for any quinoa salad or mac and cheese. I'm looking for noodles, so I got this. I'm done. But if you get a bunch of results like this, now I'm a little confused. I'm not sure which one of these I'm going to pick. Okay, and they seem to be spaced out, but not that spaced out. And then you can have it be even worse. You can get a bunch of results that are all like one another, really close to one another, and now you're thoroughly confused. You're not sure which one of these is my best match. Now, the important thing to bear in mind is that there is nothing wrong with having data like this. This is not about the actual data. This is about granularity. This is about how your embeddings can differentiate them and provide the best matches for what you pick that are adequately spaced out. So absolutely nothing to do with your base data. It's about how the data has been converted to embeddings, and if those embeddings are granular enough for your use. So the next one again is hubness. Suppose you have one bad guy that shows up everywhere in all your queries. So this is a book that fits many categories. And you're querying for something on cooking, this book shows up here. You're querying for something on health, again it shows up here. And then again here. So if you have a lot of candidates like this, what happens is that your result set may not be all that useful. It is less diverse, it is not adequately differentiated, it is not useful. So this is the third quality that of the space that is important to understand. So how do these things add up to what is called the curse of dimensionality? When you have a lot of concentration in distances, like we saw with that noodles example, you have 10 results that look exactly the same. When you have a lot of hubs, that is, say, the same vectors that show up everywhere. And when the nearest neighbor becomes ambiguous, you're not sure what is close and what is not, then your search quality tends to degrade and you have a problem with the number of dimensions that you have. That is essentially what is called curse of dimensionality. So like I said before, two reasons for optimization. Number one, resource consumption. Number two, curse of dimensionality. So either you can have either of those or you can have just one of them. So if you have them, what are your choices? The number one choice that's really easy to do is to go from floating point 32 to floating point 16. That just halves your storage and you're storing the numbers as 16-bit instead of 32-bit. Lower storage, quality may be similar, we have to test that. Then you have another two models which are fewer dimensions, Matryoshka 512 and Matryoshka 256. And I will explain in a minute what Matryoshka means and why we choose to use that. These are about compression. These are about using fewer embeddings and then seeing if you're still getting fewer dimensions and still seeing if you're getting the same result as you did with your baseline. So I want to do any one of those three things. How do I evaluate that what I got was similar to my baseline? There are four things we have to consider before we evaluate. Number one is retrieval fidelity. If your results came back the same, that's the number one importance. Number two is the geometry, and geometry is measured by those three things that I just explained: semantic neighborhood, distance concentration, and hubness. Number three is latency, or how fast your queries run, speed. And number four is storage, that have you optimized, have you reduced your storage, and therefore, all the cascading impact of that. So you evaluate your choices based on these four things. So what are the metrics for evaluating for the quality gate or for evaluating the embedding geometry? We are only going to be able to explore three of them. There are a lot more metrics that are used in the real world. For the semantic neighborhood, we are going to see what is the overlap in the results that are returned. Higher the overlap, the better. For distance concentration, we are going to use rank 1 as percentage of rank 10. In my case, it's 10, but any number that you want to use. And for hubness, we're just going to see how many hubs there are. Did that change with the new embedding? These are the three simple metrics that we're going to be using for evaluation. In the real world, there are a whole lot more. We're not going to have time to explore all of that. So floating point 32 is our baseline. Let's go take a look at how the geometry looks and the other system metrics on that. Am I doing okay so far? Everybody following?
Yeah, this has been great so far.
Okay. So like I said, I'm not going to waste time waiting for the query to render, although this doesn't, this is scan based. And if I have to explore the embedding, the space, I have to use scan based queries. I cannot use approximate index based queries. That's why these things take time. This one took 2 minutes and I don't want to sit here while it renders. So it's pre-rendered. This is the base vector that I picked and I asked SQL Server for find me the matches and it did. The first one is the same thing, so it's 0. The others, and you can see these numbers going up, and these numbers seem to be spaced out well. The rank 1 to 10. So this is how the neighborhood looks for semantic neighborhood looks for FP32 with one query. Now, obviously, with a 3.8 million row data set, I cannot go test this on every single query I have. So I picked an example, base of 10,000 queries. And then I went and ran this across them, and then I did an overlap. And that's what I have here. I can go into that a little later. But that's how I'm going to try and look at how, semantic neighborhood compares across representations. Using a sample of 10,000. So let's go look at distance concentration for this guy. So for distance concentration, you have rank 1 for this one query. Rank 1 as a percentage of rank 10 is about 5.64%, meaning it is spaced out. It is not exactly the same. So this is okay. And let's look at how it looked across 10,000 queries. Okay. So across 10,000 queries, I see that there is a 65% difference. Rank 1 is 65% of rank 10. 10, I use 10. I could use anything, but I use 10. And 65% seems like a decent spread. So this is for semantic neighborhood. Let's look at hubness. So these are the queries that are my hub vectors, and the maximum number of times this recurs is 4 times, which is not terrible in a 10,000 row data set. Like I said, the whole 3.8 million rows is too big to explore for something like this. So you have to pick a sample, and from the sample in 10,000 vectors, this appears 4 times. So percentage of vectors classified as hubs in my sample, really tiny. Nothing much to worry about here at all. So looking at these numbers, I could safely say this data set is pretty healthy. I did not ask for it. Unfortunately, you have to go down the road quite a bit before you understand whether or not the data set has a problem with any of these metrics. And my luck turned out that it was quite healthy. So we saw how big each vector is, and let's look at a single query performance. So this is a query based on the index. So this will run pretty quickly. What I'm doing here is both the warm and a cold run based on one vector that I chose. I'm trying to see how SQL Server does with just looking at the neighbors for this one particular query before and after flushing the cache. So that is before and that is after. And the important things that we have to bear in mind is that we'll be going back to that quite a bit, and also the reads with the index. Okay, and the elapsed time. So it's doing okay. It came back under a second, 752 millisecond, and then the warm run is actually much better. So that's how we are doing performance-wise with the baseline. And then we also want to keep an eye on the scan-based performance, that is without the index. So there you can see even, these numbers are a little bigger, but it's important to keep that handy for the future embeddings that we're going to be looking at. And then the data storage, as we already saw before we went into the demo, it is about 15 gigabytes with 0.94 for the index, and that is our baseline. So just documenting whatever we saw that the semantic neighborhood has an average cosine distance of that much. And then we saw distance concentration. We saw how as you go up the rank, these distances, you can see these numbers are a lot close together than those. So it tends to concentrate as you get farther and farther away. And that's how it should be. That is healthy behavior. So rank 1 is 66.5% of rank 10. In this data set, it is, it's pretty healthy, it's well spaced out. And then the hubness, you have 4 hubs, 4 maximum recurrence of anything is only 4. So that's also pretty okay, low level of no single vector is dominating your search results. So we had two, we had problems with the embedding space, or we had resources as the two issues we need to optimize on. And in this data set, particular to this data set, if you had problems with any of those metrics that we saw, then that would also factor into reasons why you want to look at having fewer number of dimensions and various, but we don't have that problem here. Our problem has to do with optimizing resources. So the goal again is how small can we make these representations to conserve resources while still preserving the good quality. It doesn't mean I'm off the hook with quality. It is still important. What matters is that the new representations that I get, they have to retain that quality. Whereas if I had that problem, it would be nice if they made the quality better. In this case, it's okay. The base quality is pretty good. So whatever I'm going to be making, other set of embeddings have to uphold that quality. So with floating point 16, we are going to be throwing away half the precision. Let's go and see what happens to the search quality. First thing I'm going to be looking at is the quality related stuff. That is semantic neighborhood. I'm going to see if my results came back the same. So compared to float, this is the result I got with floating point 32. That is the result I got with floating point 16 for this one vector comparison, the vector that had to do with introverts and leadership. And I find that my results are exactly the same. In other words, the overlap percentage is almost 100% for this one query, which is excellent. So let's go and see how that held up across 10,000 queries. So 99.9% of the results had overlap, which is almost similar. So FP16 is holding up really well as far as semantic neighborhood goes. So we look at the next quality that we have, the geometry as related to distance concentration and hubness. So if you look at distance concentration, rank 1 as a percentage of rank 10 is still 65%. And then you still have just four vectors that have repeat occurrences. So in other words, it's almost exactly the same. So geometry wise, we are past the quality gate. We did really well. Let's go and look at performance. Okay, so this is an index-based query. I'm running both cold and warm runs on both the representations that I have, floating point 32 and floating point 16. And I want to compare the results. So if I go and look, what's going on here? This data is supposed to be smaller. Also, this can be fairly unpredictable. Okay, this time SQL Server decided to give me a faster run. But look here, when I do the warm run, FP16 takes more time and has more logical reads. Okay, so we can go and explore that in a little bit of detail. Meanwhile, let's look at a scan-based query for the same thing. So if you look at a scan-based query, you can see that the wins are pretty direct. There is no confusion. Your time has dropped to half, both with warm and cold runs. Okay, that's something to remember. And the physical reads are also down. Everything is good. Okay, yeah, sometimes it does that. So it's all good. And then before we go back and see, we just want to look at row and how much did we reduce the size of one vector? We went down by half. Then the data storage down to 6 GB. But look at this one. Look at this one. This index didn't change. So that's what we're going back to explore. So I'm documenting what I found as far as performance goes. Semantic neighborhood held up, 99.9% overlap, 65% rank 1 of rank 10, and just, again, 4 occurrences again. So it's almost exactly the same. I don't have any quality issues with this set of embeddings. Size-wise, my size dropped to half, nearly 7 GB. Quite happy there. But this one is proving to be a bit, puzzling. So vector index only stores a graph describing how the vectors are connected. And each node represents one row, each edge represents a neighbor. The index stores neighbor links, graph links, and routing information, not the embedding values themselves. So our data set has 3.7 million vectors. Each vector needs to become one node in the graph. Each node still roughly needs the same number of neighbor connections. So while the vectors dramatically become smaller with floating point 16, almost half the size, the graph is not changed. The graph remains the same. The embeddings are smaller. And then we go to the question of why did it have more logical reads? Okay, this is purely speculatory. As we have today, we don't have much insight into how SQL Server works the graph when you run a query. You're not sure what is the traversal path or the nodes it hits or where it starts and so on. But the algorithm on which it is based, the DiskKNN algorithm, is open source. So you can recreate what that algorithm does, using Python, using Rust, or even using T-SQL. What I've been playing with is using T-SQL and graph feature. Anybody remember that whole graph thing that they created and abandoned later? That one. So some experiments, and my experiments are not totally complete. I'd be happy to show everyone a peek into it if we get done on time. But what that shows is that the traversal path can be different, even though the embeddings are quite similar. So if you go from FP32 to FP16, your traversal path may actually become longer in some cases. This is not always the case. In some cases, it may be short. So in short, the behavior is quite unpredictable. Sometimes your queries may perform better, sometimes they may be worse, because the traversal path it's using is not the same across the two sets of embeddings. In fact, some of my experiments showed even if you rebuild the same index after your data changes or you had some rows and you're rebuilding the index, even then you cannot say that it's going to come back to the same traversal path. So that the way that algorithm behaves is what determines this traversal, and that's one of potentially the reason. I'm going to choose my words carefully because we really don't know why. But potentially that's the reason why we got more logical reads, although the size was pretty dramatically lower. And I've also noticed that performance is fairly unpredictable when you use index-based queries. So generating embeddings itself costs time and money. So the costs are not just limited to our own needs for storage, memory, and so on. Getting to a smaller set of embeddings can also mean savings. The reason why we can't stop with FP16, although we determined that quality-wise it held up pretty good, is because you still want to look at optimizing for how many dimensions you have, and if you can make do with a smaller number of dimensions, then you're still saving money. That's the reason we are going to be looking at what is called Matryoshka. So Matryoshka is the name, that the name comes after the Russian dolls that are embedded in one another, and the smallest version of that doll looks exactly similar to the big one. So there are various methods of compression, vector compression. Think of a book, like you have a book with 768 pages and you want to make it smaller. With naive truncation, you just pull 768, how many ever pages you want, you pull that out. That is simple, easy to do, but the quality of what you get may be unpredictable. Let's say the core of the plot, the murderer, is on page 300. Then what you have is really not going to represent the book well at all. PCA is a little better than that. PCA is doesn't keep the first pages. Instead, it tries to capture the important themes. It builds the mathematical summary. So you don't keep the original chapters, you create a condensed version of the book. Still, it's only the condensed version of the book. Autoencoder, it rewrites the whole story. Like you throw some article at ChatGPT and say, I want a summary, give me a summary. And then you do your search on that summary. Clearly, your results are not going to be all that good. Matryoshka, on the other hand, it's like the author wrote 3 versions of the book, 3 different, in different sizes, same 100 pages, 250 pages, and then the maximum 768 pages. Every version has the plot in its entirety, and everything has been trained to work well. That's the reason why Matryoshka is a good way to do, reduce the size of your dimensions compared to these other choices that we have. So first of all, it's important to understand language models are different from embedding models. Suppose the input to the model is how do I cook ramen noodles? A language model is going to say boil water, add the noodles, cook for 3 or 4 minutes and so on. But an embedding model is going to spit out a list of numbers like the vectors that you have. And what we are dealing with here are embedding models. They are not language models, and people oftentimes get confused between the two. Among embedding models, there are Matryoshka aware models and Matryoshka unaware models. Matryoshka unaware models are the traditional models, and they produce a fixed dimensional embedding where every dimension contributes equally to the overall representation. So truncating is not part of how the model has been trained. And if you truncate dimensions on models that were not Matryoshka aware, then your quality is going to suffer seriously. Whereas with Matryoshka aware models, the model has been trained to work at various levels, just like the book example we saw. The same author has written multiple versions of the book. So that's the reason we want to use Matryoshka aware models if we plan to reduce the number of embeddings. Number of dimensions, I'm sorry. So from here, the next step is to compare floating point 32 with the second model I have, which is generated with Matryoshka with fewer number of dimensions, which is 512 dimensions. So let's go and explore the semantic space there and see what we get. So my overlap with my baseline, some of my results are the same, some are different. So for this one example that I took, I get a 90% overlap in my results. Not too shabby, let's go and see how it looks like with 10,000 queries. So across 10,000 queries with floating point 16, I had a 99.98% overlap, but with Matryoshka 5 and 2, I only got 84, a little lower. And then I want to look at geometry. So geometry, rank 1 as percentage of rank 10, not bad at all. This one held up. And I have 5 hub vectors instead of 4, which is still not terrible. So while we had some overlap issues and the overall overlap with that 10,000 sample I picked was a little lower than what was desirable, it is still not too bad quality wise. And again, these are just things that they're very specific to a business, what is okay and what is not. So for my data set, my demo data set, I think it's not terrible, but in the real world, your business and your team gets to decide how much of that compromise is acceptable. So I ran a whole bunch of queries and I took some statistics. We see that later, that's too big to run here. That repeated runs of the queries to see how we did performance wise. And then single query performance using the index, which is what we want to see. Run this. This is just a floating point 32 and the Matryoshka one, the same query. You're likely to have the same issues here, which, in some cases, again, it can be unpredictable. You can have more logical reads than you expect because the traversal path, potentially the traversal path was different. And in this case, performance-wise, we did okay because we got a lower level of performance. And again, that is very specific to a query and it is not always guaranteed. So again, more reads here, but here you can see that the warm run actually took a couple of milliseconds more than what we had with the baseline, although the data is considerably smaller. We want to look at scan-based performance. Here's my query, yeah, scan. So with scan-based performance, your wins are pretty direct. Nothing to worry about here with performance as well as with reads and with anything. And then row storage. Row storage dropped even further. And then data storage. We are down to 4 gigabytes from 15. So we didn't do too bad with the quality gate, although again, like I said, that's a determination that's largely specific to a business on how much of a compromise here is acceptable. 84.37 and then, rank 1 is more or less the same and maximum occurrences just went up by 1, which wasn't, all that bad. Your space is about 70% smaller than the original, which is really good gain-wise. And then why can't we stop here? No particular reason, just because we want to be unreasonable. We go one step further and we truncate it even further to 256. So that is compression attempt number 2. Let's go and explore the space for that. So the overlap here for a specific query, you can see that so almost everything is different. So it still makes sense. The results still make sense. They are related to being introverts and leaderships, but they are different from what your baseline told you. In other words, the overlap is about 80%. It's not totally off, but 20% off. And then if you test it across 10,000 queries, overlap percentage is only 72%, which means we are seeing a dip in quality that may not be acceptable to a business. Then let's look at the rest of the geometry. So the rest of the geometry is not too bad, from 65 to 65.26, and the number of hub vectors is still 4. So the rest of the geometry held up, although there is some reduction in quality as far as specific semantic neighborhood goes. And then look at low storage. Low storage is down to 520, and then data storage, 2 gigabytes. From 15, we went to 2. And this one, of course, this one does not change, and we saw the reasons why. So let's go look at performance. .256 does not have as much of a problem with traversal path, maybe, as the rest of the embeddings are. Maybe because it is too small to have longer paths. I don't know the exact reason why. But performance-wise, even with the index, 256 is a lot more reliable than the other two models that we saw. All the queries consistently perform faster, and you have fewer number of reads going into this one, even with the index. And with the scan, of course, it's totally reliable, and it's dropped quite a bit. Dropped to here, both with warm and the cold runs. So going back to that, we did see some compromise in quality though. So we saw that the top 10 overlap was only 72% as opposed to in the 90s for floating point 16 and in the 80s for Matryoshka 512 dimensions. And then rank 1 is more or less similar, 65-ish. And then maximum occurrence is also 4. That is quite the same as what our baseline had. Then comparing storage, we have, seriously big gains, almost 80% less storage. And, that is something that's really good. Then summarizing all 4 representations, we can see that this comparison shows how each representation preserved the geometry. This is 65%. This one is also 65, distance concentration wise, we did good. Semantic neighborhood, we saw a dip in the results. And while it doesn't look terribly bad, but it may be something that the business may or may not find acceptable if you drop it all the way down to, 25% less than what it used to be. For this particular data set, I would say we arrived at somewhat of a sweet spot with 512 embeddings. Again, some of it is a judgment call on what you consider acceptable and what is not. But quality-wise, it's not terrible. It held up with this, and it went a little down, but not all that much. So Matryoshka 512 may be the sweet spot if I were to be working with this data set in real life. And then storage-wise, we saw that the last embedding set that we saw is 5.5 times smaller than floating point 32. And the fidelity is somewhat held up, although strong is too strong a word, but still somewhat held up. So the comparison between indexed vector search and scans, that is the main thing. With the indexed vector search, you can see that both with warm and cold runs, you don't see that much of a gain here. Even, after you go all the way down, the logical reads aren't, because of the way that index operates, possibly, there isn't much to gain here. You actually see the elapsed time is more with floating point 16 compared to the rest of, the baseline, which is deeply concerning because it's only half the size. And the rest of it is okay. The gains aren't that dramatic compared to what you would get if you did not use that index. So you can see straight wins here all the way, going all the way down to a lower set of embeddings. So if that quality trade-off is acceptable, then you can even go all the way to 256 and have a tiny 2 GB database and work off of it. So that is if you don't use that index. So again, that brings us to the trade-offs with the vector index. For sure, it is a performance booster. All our queries came back under a second, and that is a good win to have. But it is an approximate index. We don't have the right kind of data to show people, demonstrate that it is approximate. In most cases, it's acceptable. That's why it's in place. But it is an approximate index. It is not updatable. I don't know if that much of a difference between marking it as stale and being non-readable, if it is that different. It's very hard to deploy such a thing in production, especially if your data is large volume data. It can be optimized for space. We saw that. So if anyone is looking at a pragmatic implementation of vector search in SQL Server, the best way to go as of now, and again, the mothership may change lines on apps tomorrow and make changes to the feature, we don't know. But right now, higher compression, some trade-off with quality, table scans. Literally, that's the best way you can go with it if you want to take it all the way to production with SQL Server. So again, coming back to a comparison, looking at this, the quality part, we saw that we did good all the way up to 512 dimensions. 256, we saw some trade-off in quality, although it was not a huge trade-off, but it still was there. And then we saw gains. We went up to 67% smaller, and the gains here were like this. And then the trade-offs are like here, quality versus savings on resources. Which one do you pick? And that's a business decision in some ways. That's also where we can weigh in as technologists and say, if you want this kind of results, then we have to be ready for this much of investment in whatever it is, the model and the embeddings that we're going to be using. So that's the trade-off that you have to arrive at. And quality gate is by far the first thing that should gain approval. And then the decision matrix, when you are working with a machine learning team, decisions that they make very clearly, what kind of model you choose and whether or not it's Matryoshka aware is likely a decision that your machine learning team is going to make. But there are suggestions that we can put forth as DBAs or DBREs or database engineers and say, can we look at using a smaller set of embeddings? Can we look at using floating point 16? And what is the index size? What are the gains here? And that is what my goal with this whole thing was, just to try and teach the terminologies there and the trade-offs there that we can work with our machine learning teams to get some of this to happen. So final takeaways, floating point 16 by far is the easiest win. It has the best speed and efficiency, and the trade-offs fairly minimal. Matryoshka enables safe reduction in the number of dimensions and maintain fidelity to a certain extent. And finally, the quality gate or the geometry is what determines whether how much of compression is acceptable. That will be all.
Oh,
And,
that's it. Great talk, Mala. That was fantastic.
Thank you. And if there is time, I'll show you a quick peek at the DiskKNN experiment I have going. Only if there is time.
Oh, you have time. Yes, absolutely. Please.
Yeah.
Okay.
Especially for experiments.
Anybody has questions?
You're on mute, Kevin.
You're muted, Kevin. Oh, sorry, Bob.
Thank you. Now that I've been referred to appropriately, I can unmute myself. Yeah, Mala, there are some questions, but we'll get to it after your experiments.
Okay. So some disclaimers, this is not a complete experiment. I'm still working on it. What I did was look at the disk ANN algorithm and then try to replicate it with what it does with T-SQL. We don't know what is, let me pull up that slide first. It might make better sense to explain. Okay, so we don't know what is the entry node or the entry vector that SQL Server chooses to perform the search. That information is not transparent from what we know. There is no DMV or no execution plan or any extended events or anything that can tell us that. We also don't know what are the nodes it hits before it decides to pick the results it does. What we know the results. We know what it throws at us by way of results. And we know the algorithm that it is using under the cover to come up with these traversal paths. Now, just because something is based on the algorithm doesn't mean the actual implementation is exactly the same. Some liberties could have been taken with the implementation that we don't know of. We don't know that. But we can try to construct a traversal path based on what we know. Hopefully assume SQL Server is sensible and chooses a vector that is close to what I passed in as a starting point. And then I work my way down here and I see what I get. Do I get different results with floating point 32 and floating point 16? And that was the whole purpose of doing this. It's not complete yet. But the interesting thing is, yes, using the algorithm, you can absolutely get different results with floating point 32 and floating point 16 for the same vector that you choose to make comparisons with. So that's what I tried to do here. So starting with entry node 32, FP32 traversal path is 10 nodes expanded, whereas FP16 expanded more nodes than that and looked at more detail than that. Okay. So in other words, this may be, and I'm choosing my words carefully because I really don't know, this may be the reason why we saw higher logical reads, because this thing wanted to visit more nodes than the baseline. So you can reconstruct how it works and it seems to line up. The logic seems to line up. So
Awesome.
All right. Thank you, Mala. So, a few questions in chat. I'm going to start with the ones that are in Zoom because one of these poor questions, poor souls have been waiting for so long. I can understand vector search when it comes to text tokens, but will embeddings be the same if it comes to SQL data? Or how would vectors work in that scenario?
what do they mean by SQL data?
The way I'm interpreting it is if I have a set of attributes in a table somewhere, and I want to generate a vector of those attributes, or some subset of them, whatever, then would the embedding process be the same as if I had a set of documents that I'm importing from PDF files and embedding outside of SQL Server?
I suppose it depends on the model you work with, right? I mean, the process may be the same, but when you try to create embeddings out of things like PDFs and big things like that, you can't pass that whole chunk of the PDF into the model to generate embeddings. You have to do it in what is called chunking, like different chunks of data, and there are various strategies you have to use. It's a lot harder than just embedding, small lines of text. So if you use the same model, it doesn't matter what is the text you pass in, the outcome should be more or less similar. Am I right, Kevin? You know about this too.
Yeah, I would say at least the way that I personally do it, which I don't know, somebody in chat might tell me they do it a different way that's better. But if you take those attributes and put them into something like a JSON document and then embed that, it's functionally the same as if you had the information in a JSON text file somewhere stored on disk and pass it through to an embedding model. The actual embedding process is the same either way, regardless of where that data originated from. The collection of results, the vector itself, is going to be the same, assuming that you have byte matching on your input data, regardless of where its origin was. And so, yeah, that process seems like it'd be pretty well the same. What if it's numbers? You'd get the character interpretation of those numbers. So, yeah. Okay. Next question. Yeah. So if it is numbers, you just get character. It's like Unicode interpretation if it's in varchar, or text interpretation in your locale. Same as if it's numbers in a regular file on disk. So Mala, can you explain cold versus warm index search?
Pardon?
Cold versus warm index search. You talked about that a few times. What's the difference?
One is before I flush the cache and then I run it the first time. That is cold. And then the cache is warm because it has some of the data there. That is warm.
Okay,
So
excellent.
you will have physical reads with the cold, whereas it will be more logical reads with the latter.
Right. Have you seen organizations generating the initial embedding generation outside of SQL and then only doing parameters and updates in the database?
So I have only met one person who has actually implemented vector search in production. There may be other people there for sure, but I don't know of them personally. I don't know if calling, the embedding calls within SQL Server is a good idea. The footprint is likely to be much larger, and it's a good idea to do it outside of that, for sure. That's my opinion, at least. I don't know of anyone who has done it one way or the other. The one example, that one person I met who has it running in production, was doing it outside of SQL Server.
Okay, fair enough. Karen agrees. Karen Lopez agrees with you, by the way. Armando asks, who do I have to bribe to get this deck? I already told him me, but are you going to be able to share the slide deck afterwards?
Oh,
Molly?
absolutely. I mean, I already sent it to Andrew. It's in the 8KB.
It's already on the 8KB repo in GitHub. It is all there ready to go.
Just as long as the money comes through, Armando. How about the demo code? There were a couple of questions about digging into the demo code further.
Oh, absolutely. I'll be happy to share the demo code. The database is close to 300 gigabytes. It's not GitHub friendly. I will put it on Google,
we
Google
will
Drive.
get an angry email from Microsoft if we try and upload it. So, yes.
I'll put it on Google Drive and share it. Give me a little bit of time, but this afternoon it will be there. Feel free to download and play with it, by all means.
No, I am 100% grabbing the script you got on screen there to work out the traversal path through the vector index there.
Yeah, that's super cool.
Yeah, it's really cool. I like that a lot.
Yeah. And there's one question in Slack that we haven't gotten to yet. Does SQL choose the same entry point for every query, or is it making some sort of non-deterministic calculation to select the entry point for this query, which could be different from making the exact same query again later?
Don't know. Sorry.
That's fair.
Really don't know. Don't know.
Hidden.
I mean, because they have not released much, there's not much transparency around how that index works and how a plan, how it constructs the traversal path and the plan. Actually, we don't know yet. We can assume things. Whatever I did here was also based on some assumptions like, okay, SQL Server, you're being sensible. You're picking a neighbor that is closest to whatever query I want to start with. Okay. And then I go down this and I see what I get. But what it actually picks and whether or not it picks the same thing for every run, don't know.
All right. And there was a comment, by the way, that you were pronouncing Matryoshka exactly right, which is obviously that she didn't learn it from me.
What was that, Kevin?
That you were pronouncing the name Matryoshka absolutely right.
Oh, okay. Well, we're from India. We're used to Russian names.
But I think that covers it, unless there are other questions that people pop in here with.
All right. Thank you, everyone, and have fun at the conference. And thank you to the 8KB team for having me.
No, thank you so much. That was a fantastic session.
Yeah, that was fantastic.
Yeah. Okay, we've got a few minutes. Let's get the.
Oh, Andy, thanks for representing the conference with your 8KB t-shirt, unlike
I,
the other
both of us are
hosts.
repping. I mean, we got to
Oh, I see.
match.
Yeah. Yeah, yeah. Thank you. Thank you,
Wonderful
both of you.
stuff. Love to see it. And of course,
Anthony and Andrew
please.
couldn't be bothered, but that's fine.
Look bad, right?
Surprised
Deborah,
to
I'm
get
you
a
not,
don't
golf
I'm
need
not,
it.
shirt.
I moved
Or,
like
there you go.
3 weeks ago. I have no idea where any of my stuff is. So
It's been more than 3 weeks.
everyone out there, please, please, please do leave feedback for Marla
Yes.
session at 8kb.online/feedback or scan the QR code there. It'll take you exactly to the form. We have all of our resources for you here. So GitHub, YouTube, I'm not going to go through them all, but we're posting these into the Slack as well. And as I mentioned, if you'd like to
Small
buy a
tip I
t-shirt,
forgot to tell people. The query that we use for measuring the size of the vector index and such, don't ask any AI tool for that because it's all wrong. I tried 4 different things: Claude, ChatGPT, GitHub Copilot, and Gemini. They're all wrong. They think it's a regular index and they're going to give you some DMB based nonsense, which is going to spill numbers at you that are incorrect. So it's part of my scripts, and I had to construct the script and run it past my dear friend Joseph Sack, who validated it. And so this query is correct, but it's not available on any AI based or Google based searches, because what's out there, what it tells you is just wrong in that regard.
As Mark said in our team chat behind the scenes, sounds like an excellent blog series, Mala.
Yes. Yeah, this whole talk would be a fantastic blog series.
Thank you, Mark.
by the way, if any of my customers are watching, you want to be using floating point 32 for all of your embeddings. Up next in 4 minutes, we have Andy with unraveling the layers for IO for your next step to become a comprehensive performance tuner. Looking forward to this one, Andy. Thank you for turning up on time and not giving me a heart attack.
I've been here since the beginning.
I know you've been here right from the start, so I'm going to stop. I'm stop sharing. If you would like to grab the screen, well,
Sure. Deborah, you want to check your micro fast?
Yeah, can you hear me now?
Yeah, you're good.
Yep, we can hear you.
All right, let me rearrange all my windows.
So we still have 4 minutes. So anyone watching, please go get yourself a drink, get some snacks, because we've got a 75-minute session coming up, and this will be the 3rd out of 5. So we're getting into proper mind melty territory now with 3 sessions in. We're not going to let up.
I really hope this lives up to the mind melty standard here.
I'm sure it will.
Sure it will, man. Am I still getting absolutely no? Everyone's been nice. Anyway,
Oh, and I checked our bonfire store. They don't seem to have pet clothes.
no.
You guys need to change that. Seriously, get a 8KB bandana, and Deborah and I will absolutely buy one.
Oh, there we go. I think I can make those. I'll have to look into that. Because I saw the picture of you two with the dog, and I'm like, that dog has no swag.
Whose fault is that? Not ours.
That's mine. It's my
That's
fault.
Mark's fault. Yeah.
I take responsibility, and I will resolve that.
I mean, if you
Hey.
notice, he was looking away because he was a little disappointed that he didn't have
Yeah,
it.
I could see it in his eyes.
Right?
There's a question in the chat for you, Andy, already.
Oh, you'll find out. Hold on.
Okay.
Oh.
Yes, the question is, what's the good boy's name? And the answer is Sebastian.
Ah.
And like I said, you'll find out, depending on when and how you cut this.
Sorry, I should have said spoiler alert.
It's okay.
Yeah, giving the game away now, Deborah.
I'll
He
never
may be an
a lot of
ongoing
feedback.
character in this particular presentation.
All right, we got 1 minute to go, so hopefully everyone's settling back down into their seats.
Hopefully those of you on the East Coast are getting some lunch now, or Central.
I can't do time zones. I have no idea. What is it? 5 o'clock? East
It's
Coast?
it's
No,
noon.
12 o'clock. 12 o'clock. It's 5 o'clock here. See you
Yes,
later.
you cannot do time zones. We see.
I would be in big trouble if I was in your time zone right now, Andrew.
Okie dokie. Coming up on the hour. So let's go. Andy, the floor is yours.
Thank you. Welcome, everyone, to Unraveling the Layers of I/O, your next step to becoming a comprehensive performance tuner. My name is Andy Yoon, and I'm going to ask my dog here to introduce himself. This is Sebastian, who will be making multiple appearances throughout this particular presentation. I put that in there because I literally just put this little video together thanks to AI over the weekend, and I couldn't resist. I've been using a still picture as my intro for quite a while, but thought that was a cool little Easter egg. So I've been a DB developer working with SQL for a very, very long time. Had the pleasure of speaking for well over 10 years now and used to be based out of the Chicago area. Yes, those are my old Illinois plates behind me. And yes, there are SQL Server license plates out on our vehicle outside. When I say ours, of course, my moderator today is also my amazing spouse, Deborah Milken. And of course, we got our dog, Sebastian, here. Deborah, you also want to say hi? Deborah, you're on double mute.
I know, I gotta find the unmute.
Right.
Hi, everyone. If you have questions, remember, put them in the chat. I'll be moderating the Slack channel as well. So make sure you put stuff in there along the way.
And of course, before we get into things, the most important thing on this particular slide is my contact information. SQL Beck is my online alias, and you can find anything and everything about me through just searching that particular handle. All right, so here we go. Oh, what's going on here? Sebastian, what's the matter? Why are you feeling all blech? Wait, what? You got paged 14 times over the week? Oh, what are you talking about, Sebastian? You have a job?
More importantly, how is the dog talking to us via Slack?
Is he using that extra Microsoft Surface that we have lying around in the family room or something?
I don't know. I'm worried.
Okay, you've been working for Stinky Wins. Well, all right, I guess. But I mean, yeah, how did you even pass that interview, dog? All right, I guess you have been our an unwilling audience member for all of our different presentations over the years, so I guess you picked up something. You're a little smarter than you look. Well, yeah, we know Stinky Winds definitely has security problems. You might remember them making headlines a couple years back. All right, but I can totally understand and relate to you being confused about disk and stuff. Seriously, someone's still rambling about fragmentation, and if that's still a thing today. All right, fine. Sebastian, sit, chill. Let's unpack all of this. And here we go. So, to that end, what the idea of this particular presentation is it's kind of a learning journey, and it kind of mirrors my learning journey over the course of my career. I started off as a T-SQL developer, but then I pretty quickly moved into performance tuning. I got to learn about execution plans, and then the query optimizer, and deep diving into the storage engine. And then as the years progressed, I elevated into what I classify myself as a SQL Server performance tuner. I learned about things like wait stats and other characteristics, operational aspects of SQL Server to help performance tune the living heck out of it. But for the longest time, I still only stayed within my bubble of SQL Server. If there was something going on outside of the SQL Server realm, well, that was someone else's problem. I threw that question or that headache over the fence, if you will. But all of that changed probably about 10 years or so when I first joined Century One. You might remember them as a company, rest in peace. That really expanded my horizons to look beyond just SQL Server itself. And as such, I feel like I've really progressed and aspired to become, or have tried to my best to become what I classify as a comprehensive performance tuner. I know not only SQL Server, but nowadays I know a heck of a lot more: storage, VMware, other hypervisors, for example. right? So I feel like becoming a comprehensive performance tuner is something that we all should aspire to try and get to. Of course, it's one of those lofty goals that I don't know if any one of us will ever fully achieve, right? Because I don't know about you, but I'm not a walking encyclopedia. But still, something to drive for, something to work towards. So to that end, in today's agenda, to help you try and become more of a comprehensive performance tuner, we're of course going to be talking about storage and I/O. And the chapters for today will be, we're going to talk a bit about on your SQL Server. We're going to talk a bit about server to storage. And then going beyond the storage fabric will be chapter 3. I also want to say that this is part 4 of a series of presentations that I've done over the last handful of years, all around this particular topic. So this will not be an introductory or beginner level session because this is 8KB after all. So I'm really going to be trying to build upon the different things that I talked about in years past. Now the first like 5 minutes will just be foundational, and then we're going to ramp it up really, really quickly because like Sebastian, if you haven't figured out already or been in one of my sessions before, I tend to talk fast. And we're going to move fast because I do have about 75 minutes worth of content. I'm going to do my best to field Q&A. Deborah's going to be keeping an eye on Slack. I happen to have the Q&A panel open here, so I'll try and find pauses here and there to stop for Q&A if any arise. Otherwise, we'll just take Q&A at the end. But otherwise, buckle up. Let's go. All right, chapter 1. On your SQL Server. So first of all, I just want to make sure that everyone understands that T-SQL is declarative. And T-SQL is just saying, what do you want? Select blah, blah, blah from recipes, interjoin authors. One of my demo databases is a cookbook demo database. So you can look at recipes all gleaned from food.com. But then once you input that particular T-SQL query, it's up to the query optimizer to figure out how to get that underlying data. The query optimizer comes up with your execution plan, which have discrete access methods inside of them. And it's those access methods like a clustered index scan that's going to be retrieving data pages for you. And the process from a high level, what it does there is that it'll go out to the buffer manager to basically check if the data page happens to exist in RAM already inside the buffer pool. And if it's there, great. Read the data page and we have a logical read operation. Otherwise, if the data page is not in the buffer pool, this is where we have to incur a physical read operation. We got to go read it from disk. Once it's been read from disk and dumped into the buffer pool, then we will do a logical read to essentially process or scan that underlying data page. So the one fundamental thing that I always like to remind people of is that a physical read is reading a data page from disk into the buffer pool, whereas a logical read will also happen to scan or process the data page inside of the buffer pool. This is one of those earlier things that, I just like to reinforce because it took me a while to wrap my head around that specific nuance. Oh, what do you mean, Sebastian? Ah, yes. Oftentimes when we think of like storage, we'll hear, my storage does 1,000,000 IOPS or that sort of thing, right? So we hear this term IOPS in the context of storage and IO all the time. So is one of these physical read operations correlate 1-to-1 to an IOP? That's a great question. Let's dig into that. So before we dig into that, I'm going to give you a high-level overview of what happens, and then we'll dig in a bit deeper. So SQL Server, of course, is checking RAM, as we just talked about a moment ago in that prior slide. But when it sees that that data page is not in RAM, it doesn't actually issue the IO request itself. It'll make a request out to Windows, and then it's Windows that actually makes the request out to disk. And then that request doesn't actually pass that IO data page back to Windows for handling. It'll actually use something called direct memory access to dump it in straight into RAM, and then Windows is then signaled, which then signals back to SQL Server, which can then go and read that data page out of disk. So let's see this life cycle in detail. First, we're going to talk about the worker in this context. The SQL worker within SQL Server is first going to reserve an empty data, an empty frame inside the buffer pool. It's like me saying, hey, I need to go get something from the fridge. I'm going to clear a little bit of space on the kitchen island so I can go get the sandwich fixings for lunch, right? And when I do that, that's the equivalent of SQL Server first initializing and taking a page IO latch exclusive wait. That's when that timer starts ticking. And then when SQL Server communicates with Windows, it's Windows that's then going to use something called read file, scatter in order to actually get this underlying the underlying data page in question. And then Windows is going to say, okay, I got this, meaning that the SQL worker is now free to go off and do something else. The point to all this is to understand that almost all I/O in SQL Server is asynchronous. There's a handful of exceptions. We're not going to talk about those today. But for really all intents and purposes for our conversation today, SQL Server is doing everything in an asynchronous fashion. The idea being is that SQL Server just wants to get as much stuff done as it possibly can and not have to wait on other stuff. There will still be points where it's going to have to wait, which we'll see in a minute, but let's get as much as we can get done in a current context or current scenario. So what was that scatter and then the gather thing as well? So these are the calls that are actually executed within Windows itself. Read file scatter and write file gather if we're doing a write versus a read. The read side of things is this. Back in the old days, if I needed to get a bunch of contiguous data, I would actually have to set aside a bunch of contiguous space in RAM. So let's say I'm going to use a simplistic example here. If I wanted 8x 8 kilobyte data pages, I would have to set aside an extents worth or 8 contiguous data pages worth of empty space in RAM, and then I would go read it contiguously off a disk. But when Microsoft and Windows introduced the scatter method, now it doesn't matter if it's contiguous or not in RAM. We're not going to worry about that anymore. Now, this was still under the assumption that back in the days of spinning disk when the data would be contiguous on disk, right? But it no longer mattered in memory. And that's why the name read file scatter happens to be here. And then the gather is on the other side. I'm going to write a bunch of data down to disk. That data does not have to be contiguous in RAM. It can just be anywhere. I'm going to gather it all together to then sequentially write it down to disk. Okay. And again, these APIs came about, I think like 25 years ago. I remember reading it while I was doing my research for this, but I kind of can't quite remember now. But again, in the days beforehand, everything had to be sequential on both sides. And also keep in mind that this was all built for the era of spinning disk, spinning Rust. So there's a little bit of an added twist. So once that worker has issued all the requests to get all of the data pages it happens to need, it's still got to read them, right? So, but if those data pages are not yet been brought into the buffer pool, it's got to stop. It's got to wait. And this is where we start seeing the timer for a page IO shared latch start ticking. If you don't know who Bob Dorr is, most of you all have heard of Bob Ward, but there's really two Bobs behind the scenes. Bob Ward, I always like to say, is the public face, but Bob Ward will oftentimes actually credit Bob Dorr and his collaboration, the two of them together, as being a lot of the brains behind the things. And Bob Dorr used to write a lot more blogs, and he used to write a bunch on I/O and I/O internals, some of which are actually referenced in the resources slide towards the end. But Bob Dorr used the phrase that this is you waiting on yourself. I still have to wait in order to get these data pages so I can finally read them. So at this point, now we have the generation or creation of an IO request packet inside of Windows. SQL Server has passed this request off to Windows, and it's the Windows IO manager will create this IRP. And then this IRP will go on a journey through a stack. It's going to go through the file system layer, the volume layer, partition manager, disk class driver, storage port, and the storage port driver thereafter. It's the disk class driver that actually builds the SCSI commands that will basically be sent out to your underlying storage. And then it's the storage port driver that may wind up splitting that IRP down to smaller chunks. There's a couple of different criteria, such as like a max transfer size. I can't remember exactly what those two parameters are. But in either case, the point is that the output of the storage port driver is a storage IOP, as we like to think of it in a more common sense. That being said, That means that a given physical operation, like a physical read or a physical write inside a SQL server, may still get chunked up into multiple storage IOPS. A simple example of this is if you're doing a SQL Server backup operation and you're using a larger max transfer size, for example, your storage port driver may still chunk that up. I'll use a simplistic example. Maybe it's your max transfer size is 256 kilobytes in the storage port driver, yet you're doing a backup with a transfer size of 1 meg. So it's now going to create 4 storage IOPS for each backup block there. So that's the answer to that underlying question. Whether there is a one-to-one correlation or not, not exactly. No. Now, one other thing I also want to touch upon while I'm here are filter drivers. This is a place where you might experience performance headaches or performance bottlenecks or performance issues. Most of us have probably not heard the term filter drivers, but I'm certain that we have almost all experienced headaches from them because we know them by their more common front-end terms, such as file system mini filter drivers oftentimes manifest themselves or implemented as like antivirus applications. Most of us have had to deal with, corporate security software or spyware, if you will, that will oftentimes live on the file system level and be analyzing your underlying I/O. There's also volume level filters that exist out there, such as BitLocker. Most of us who are on Windows are familiar with BitLocker. And then there's even device level filter drivers that are out there, things around MPIO, for example, or if you have a block replication application of some sort that may be running behind the scenes. Those are all different possible places where IO may be inhibited due to these different filter drivers. All right, so I explained all of that so that we can get into finally unraveling fragmentation and putting this one to rest. I want to kill the concerns around fragmentation once and for all. So I want to be very clear here about definitions because really in the realm of fragmentation, there's two forms of fragmentation. I like to think of it as external fragmentation and internal fragmentation. External fragmentation is what people mostly think about when we use the term fragmentation. Internal is how full a data page is. We're not talking about internal today. So this is the line-by-line verbatim definition inside the Microsoft documentation for external fragmentation. We're talking about the logical ordering within the index on the key values of the index not matching the physical ordering of index pages. Okay? I want to let you digest that. Logical ordering, physical ordering. But physical in what sense? This is something that actually confused me for a while, and I know it confuses a lot of other people, given some of the arguments that I still see on Reddit and other social media. Because is it physical ordering on actual disk or not is really the kind of key question that pops into people's brains. The idea of what does physical mean in this specific definition? Well, let's break that down a bit. First of all, when we're looking at a B tree, we're just looking at the leaf level in this particular example. It's a linked list underneath the covers. Of course, we have the B tree structure, but on the leaf level, all the data pages on the leaf level are also linked lists together. And this is the underlying format. It's the file ID, 1 in this case, and then the page ID, 200, 201, 202. In this case, you see the previous page and the next page values there. So in this case, nothing is fragmented. Everything is in contiguous sequential proper order. And now we have the dreaded page split operation, the enemy of fragmentation. So what happens here is that I must now allocate a brand new data page somewhere else. I can't just shove it in between because I can't do something to shove in between 201 and 202. There is nothing in between there, so I have to allocate it somewhere else. So 4701 is the next place I happen to have space for a brand new data page. So now we've updated our linked list accordingly, and now we are no longer in contiguous order. So let's take it to the next level here. So all of these different data pages, this linked list here, live inside a SQL Server data file, an MDF or an NDF file. Now here's the misconception here. Even if all of these data pages are sequential to one another, when we write it down to physical media, the physical storage, is it actually written contiguously? Not necessarily is really the answer. It may or may not be. And frankly, for what it really matters, it doesn't quite matter. And there's a lot of reasons for that, which I'm getting ahead of myself, so I won't get to that one just yet. But the point is that SQL Server has no determination over that or control. It doesn't care. So really, the physical here is talking about the data pages solely within the SQL Server data file, and that's it. And in fact, you can actually utilize the page ID to calculate your offset inside the MDF. You can find where the MDF actually starts, and then figure out what the offset is to find the exact data page that you happen to be looking at, like page 201 inside of data file number 1 or number 3 or number 4, for example. So it is a physical location inside of the MDF or NDF file. Because again, because once you have the MDF and NDF file, that is a byte stream that lives on top of the file system. Is your file system fragmented or defragmented? I'm sure many of us remember the days of having to defragment manually our Windows spinning disks. I'm sure many of us have spent many an hour watching Windows do its thing with the old school defragmenter. Or is it physically abstracted entirely? Is your data living on a SAN, for example, and that data could be scattered over many, many, many drives or disks inside of that particular SAN? SQL Server has absolutely no idea. So it's only physical in the context of SQL Server within the SQL Server data file. That's the clarification point here with physical. Now, one of the things that people talk about as far as the consequence of external fragmentation is that it impairs read-ahead reads. So just to clarify what a read-ahead read is, a typical read operation is only going to be reading single data pages, not extents. Remember that an extent is an allocation unit, but it's not a unit of I/O work. With a read-ahead read, though, we're going to read upwards to 64 contiguous pages with a single scatter gather call within Windows. And this is going to rely on the previous page and the next page, that linked list, all within the MDF file. And yes, there's a little bit of a caveat, but we'll hold that thought for a moment. So let's walk through a simplistic example here. Everything here is in perfect sequential order. The bottom layer is our leaf level, and we'll pretend that that single box in the upper left-hand corner is our index intermediate page. So all of this can be done as a single read-ahead operation. Of course, this is a simplified general example, but yes, all of this can be done as a single operation. On the other hand, now we have a little bit more fragmentation here, but there's still a couple of data pages that are sequential to one another. So I can now just do 4 I/O requests, 2 singletons and 2 read-aheads. Again, this is simplified, of course, but you get the point here is that, those that are next to one another that are still contiguous can be grabbed together as a read-ahead operation. Now, a third example, everything is all over the place. None of these are contiguous, so can't do any kind of read ahead whatsoever. But didn't I say that there was a caveat? Yes, I did. So it's funny, when I was putting some demo code together or trying to think about how to do some demo code, yes, unfortunately, I don't have time for demo code today. But, as I was kind of prototyping some stuff, I ran into an interesting behavior. So Paul Randall long ago had put together a simple demo in order to create a database with 99% fragmentation. He creates a table, fills it with junk, creates a second table, fills it with junk, drops that first table, and then shrinks the database. Yes, Sebastian, I shrank a database. Don't worry, this is just for demo, Sebastian. So don't listen to what I'm doing. Don't do this in production. But when you shrink that database, because all of this empty space, because you dropped that first table, SQL Server will basically rewrite it all and literally in reverse order. That's how you can get 99% fragmentation. So it'll look, in a simplified form, just like this. So the DMV will reflect 99% fragmentation. But here's the funny thing. I still got read-ahead operations. How did that happen? These aren't contiguous. These aren't in order. They're literally in reverse order. The DMV says I have almost 100% fragmentation. Because there's another mechanic that can be utilized here. Allocation order scans. In this case, SQL Server said, you know what? It's actually cheaper than, instead of looking at the linked lists and trying to go through that, I'm just going to look at the index allocation maps and scan based upon that. And this is where I'm going to introduce you to a simple tool from the suite sysinternals called Process Monitor. Process Monitor gives you some amazing view into SQL Server internals, but with a nice GUI. You don't necessarily have to just use the Windows debugger. So this is the first run that I did before I had fragmented everything. So everything is perfectly sequential. Notice on the left-hand side here, all the length values. Those are almost all read-ahead operations in 512 kilobytes here. And this was about, what, 20 read file operations that occurred that were passed from SQL Server down to Windows. That's what we're tracking, is the SQL Server to Windows communication here. When I ran it again afterwards, after I had done that reverse fragmentation bit, you see that you know, some of the sizes or some of the lengths got messed up a little bit, but otherwise I was still able to do a fair amount of read ahead almost all the way through once again. Because of SQL Server choosing to use the allocation order scans instead of doing the linked list on the leaf level page. This is one of those things that actually threw me for a loop and that I wound up having to dig even deeper into. But this is another good example as to why, even if you see fragmentation is, you know, at like 99%, do you really care? SQL Server may just end around you anyway and just do the allocation order scan anyhow, and you're not going to be you're not going to be penalized for it, is simply my point. By the way, the other cool thing that you can do is that I can select one of these different entries inside of Process Explorer, right click on it, and I can actually view the call stack of each individual operation. So this is an example of me digging into one of the read files, and you see the full call stack here. If any of you have ever been in a Bob Ward presentation, you see him using the Windows debugger to get at the call stack. This is another way that you can get at the call stack as well. So you see our friend read file scatter in here. So, and if I were doing some write operations, you would see a write file gather as well within here as well. But this is, again, a really cool way with a GUI tool to actually see the call stack underneath the covers. Is it as practical? No, not really, but it's pretty cool and pretty fun to dig deep. All right, so does fragmentation really matter anymore? I would argue that it only matters if you're really on really terrible storage. Like literally you're using disks from say 10, 15 years ago, which frankly, given the storage headaches and the pricing and whatnot, it wouldn't surprise me if some organizations are having to sweat their gear for especially non-prod environments. You know, so does it really matter? Probably not. The only other time it might matter is if you're really throttled on IOPS, like if you're using a very low-end Azure SQL database and you're trying to do it for a heck of a lot more. Because the thing is, of course, you're going to be throwing out more IOPS across the wire if you cannot do read ahead. But we already seen that even if you potentially have high fragmentation, that SQL Server may end around you anyway with using the index allocations. So it still may not matter. In most cases, it pretty much will not matter. The only other time that it might actually matter is if you have really terrible queue depth settings and you're sending a lot of I/O over the wire. What's queue depth? Great question, Sebastian. Let me elaborate on that one. And that actually brings me to chapter 2, server to storage. But before we do that, because I am jamming through this at a really nice rate, I'm going to pause and ask if there are any questions. Deborah?
I don't see any questions, but I see a lot of people who are, one, say hi to Sebastian, and a couple other talks about sysinternals. Someone just pointed out that Rasinovich just released stuff, and so there's some good chat on the Slack channel. So you'll want to catch up on that later.
Fantastic. I will say, as a quick aside, Mark has been doing an amazing amount of development recently with sysinternals, particularly around like Zoom In and some of the other utilities that are in there. And I believe he is heavily leveraging AI development, like some of the stuff that Chrissy talked about a couple of hours ago. So definitely keep up on it because there's a lot of new stuff that's even just been coming out in the last handful of months. Even Zoom It, for example, a staple of our those of us who are presenters, has been seeing a lot of updates as of late.
And we did just get one question in as
Oh,
we were
yeah.
doing it. Frank wants to know, is there a threshold that will cause SQL to use the IAM instead of read ahead?
Great question. To my knowledge, there is no published, threshold or where we will actually know whether this happens or not. I did some research around this, and I can't remember whose blogs I was reading. It was either Paul White or Aaron Bertrand, of course, folks who definitely know what they're talking about. And neither of them, at least when they researched this a while ago, could figure out exactly when or how SQL Server makes that particular determination.
Oh, great.
I was
One
also
more.
trying to dig into whether there was actually like an extended event that will actually show whether one or other is, winds up being used at execution time. I was not able to find a good way to do that. Otherwise, that would have become my demo.
All right, one other quick question. Is it true that allocation scan has a bigger start cost, but faster for large tables to compare it to order scan linked list?
That's a great question. I'm not going to answer right now because in the resources slide, there's a number of people who have really dug in deep into that one. It's always it depends. So it's one of those things where there's always a little bit of a trade-off. But again, it depends. But again, people have done a lot more research into it. Those are in the resources slide. This is more again of a tangent and an aside.
Okay. I started to see more questions that are popping in, but I
We
don't
can
know
take
if you
one
want
more
to
and then we'll go.
continue. What?
We'll take one more and then we'll go. One more question.
How would Windows file cache interact with this IO stack? Because he's talking, the question is sysinternals reminds about cache set. So
That's actually a great question. I'm not 100% certain because the thing is, are you talking about the caching of like, as you're writing out to disk or, I see Andrew. Okay, I have that down here. Throw that into the Slack chat and I will either address that later on or if one of my colleagues wants to tackle that question too, that would be really awesome. But I don't want to go down that rabbit hole because also I'm not 100% sure, but I want some clarification. Cool. All right, back to it. So server to storage. So first of all, I need to do a quick refresher here. So we're going to talk about the physical pathways between a server and your underlying disk. In this case, this is a simple example of just a single bare metal server with direct attached storage. So a disk inside of the actual box. So when it's direct attached, your I/O is simply going over the PCI bus on your motherboard. That's it. It's quite simple. There's not much in play. But then most of us have graduated to SANs and storage array networks. So whenever you have a SAN in play, you're going to have some kind of HBA adapter in play and then a storage fabric thereafter. I'm using both of those terms sort of generically here because, of course, the two standards are, iSCSI, which goes over Ethernet, and Fiber Channel. HBAs, by the way, stands for Host Bus Adapter. Think of that as the physical card inside of the physical server that then connects to, say, your fiber channel storage network to then go on out. Or if it's an Ethernet-based network, an Ethernet card that connects to your network to then go on out to the SAN. Okay, so, but I'm going to be using HBA adapter generically or loosely for the rest of this particular conversation. So we're not going to care about those specific storage technologies. Now, most of us don't run bare metal SQL servers, but we run virtualized SQL servers. We see well over 90% of that out in the industry. So you have the virtual machine, which is virtualized to the SAN itself. And then there are virtual SCSI adapters. Like if you're in VMware, you can set up different virtual SCSI adapters on the virtual machine itself. And then you have the host, which is your bare metal box. And then that bare metal box has has the HBA adapters, which are then physically connected to the storage fabric. Okay. So the other refresher that I just want to make sure that everyone is fully on the same page about it are the three key terms for storage I/O. Latency is all about the round trip time it takes for something to complete from the point that you are standing or observing that latency. That is key. So for example, if I'm measuring latency from the SQL Server perspective, then it's latency out to my SAN and back. But if I'm measuring latency from, say, my VMware host, then I'm actually measuring it from the perspective of the host and back, but it's not counting what happens within SQL Server. So remember, it's from what point are you starting it? Are you measuring latency back and forth? That's why latency measurements can be different depending on where you look first and foremost. IOPS, I/O operations per second. And throughput is essentially IOPS times your IO size. Is your each IO, is it 1 meg in size? Is it 8 KB in size? Is it whatever the IO size happened to be? And by the way, do remember that SQL Server does IO in varying sizes depending on the underlying operation. I should have probably, now that I think about it, included that chart here, but there's a really nice blog out there on Pure Storage's website that actually gives you that nice cheat sheet. So nowadays, of course, storage is a heck of a lot faster than the storage that we all grew up with. So do we really actually care anymore if we fire a whole bunch of teeny tiny little IOs as opposed to just 2 or 3 read aheads? Do I really care? Is it really that much of a consequence? Well, remember that SQL Server I/O is asynchronous. It's fire and forget. SQL Server is just trying to get as much I/O out the door, fire and forget, flying over the wire as it possibly can in order to basically improve concurrency as much as possible. But can your underlying destination or the pathway in between, can it handle that particular shotgun, that buckshot spread, that flood of I/O is the question. So I'm sure Anthony's going to love seeing this. Little's law is a key algorithm in I/O and queuing theory, which is what comes into play in all of this. And the two terms that I want to be very clear on that we all understand is this: queue depth and queue length. Queue depth is the maximum number of I/O requests that can be outstanding at once. So think of it as the ceiling or the limit. And then queue length is how many are actually in flight, okay? So one thing to understand is that in this overall infrastructure, there are queues all over the place. Your SAN itself will have a queue for as far as ingesting or servicing your I/O, if you will, or processing, whatever term you want to use. But there will oftentimes be queues elsewhere in your stack, most commonly in your HBA adapters, your virtual SCSI adapter, for example. And again, this is a simplified diagram. So that's a great question. Why do we even have these queues? Remember, the storage that we all grew up with was slow and crappy. So we didn't necessarily want to overrun it. These spinning disks had a lot of challenges as far as how fast it could service an I/O. We remember, spinning disk latency, if it was really, really amazing, was like 10 to 15 milliseconds, right? So I could only do so much with a spinning disk at a given time. And all of this kind of comes back to this analogy, Sebastian. So, hey, Sebastian, we had a block party a couple of weeks ago. Do you remember all the neighborhood kids giving you, all treats all simultaneously, right? Wasn't that awesome? Yeah. And Deborah, how do we normally give Sebastian his treats?
One by one.
Yep, we're stingy dog parents, of course, right? So, yeah, so we only do it one at a time because, yeah, Sebastian, we got to help you watch your waistline. But the kids didn't care. They were having fun. It was a special day. So they were giving Sebastian treats as fast as he could possibly eat them. But the thing is, we didn't want too many kids swarming around Sebastian, right? So what is it? We had 10 of them around, which is still a good number of neighborhood kids around Sebastian. He's just a little 12-pound chihuahua after all. But that's concurrency. That's an example of Sebastian just, there's 10 kids trying to give him treats all at the same time. He's eating them as fast as he possibly can. Okay. And while on the other hand, we made sure that there were no more than 10 children around him. That was us limiting we were basically his gatekeepers, if you will. That was our queue depth. I don't know, Sebastian, when the next block party is. You'll have to talk to our neighbors. All right. So one thing I want to clarify around this is something that confused the living heck out of me. First, with queue depth, what does outstanding mean? Because I mean, I could kind of, interpret this in a couple of different ways. So I want to really be clear that when you see the word outstanding, IO requests that are outstanding at a given time, it's that how many IOs are, that are accepted by the destination, by the storage, and held, and they may or may not be serviced by that underlying storage. Like if it's spinning disk, maybe I can accept up to 10 IOs, but because I'm a single spinning disk and a single platter, I can only service one at a time, but I can have 10 in my queue. So that's my queue depth, okay? And that's how many I can have outstanding. Queue length drives me nuts because depending on what you're reading, it's an overloaded term. It may either mean queue occupancy, how many IOs are in the given queue at a given time, and or it may also reference the overflow. Like for example, I use a simplistic example, queue depth of being 10, but queue length may actually represent what's not in flight or what's overflowing as well. It's one of those overloaded terms that, again, depending on what documentation you're reading, can be somewhat confusing. So I want to be very, very clear on that. Yes, it drove me bonkers. Okay, so we have multiple different queues here. Queue and HBA adapter and a queue and a SAN. So I'm going to use a simplistic example to kind of talk about these different queues. In this example, both have a queue depth value of 32. 32 is a very common default that's been set since the Stone Ages, like 20, 30 years ago, right? Now, does this mean that each queue holds 32 IOs each? 32 IOs at the SAN, 32 IOs at the HBA. That's actually something that I got incorrect in one of my prior presentations, so I want to clarify that here today. All queues in the pathway overlap one another. So I want to show you this simplistic example. So instead we're going to have 3 just IO pathways here. I'm going to send IO number 1, IO number 2, and IO number 3 down to the SAN. And now the SAN is working on those 3 IOs. I have IO number 4 come along. I initially thought originally that IO number 4 would be queued at the HBA adapter. That is not the case because as you can see with the dotted line, IO number 1 consumes the entirety of the pathway. That's what it means by these queues in the pathway overlap. Every single queue along the pathway. So it's consuming everything. So I have IO number 4 and IO number 5. Those are sitting and waiting at the server to now go down the pathway and will not be allowed until IO number 1 and number 2 in this case are fulfilled by the SAN, in which case then they may be sent down the full pathway through the HBA adapter to the SAN. Okay? This is important to understand now that we get into some math. Let's pretend my server dispatches 200 IOs. And in this example, my HBA's queue depth is 128 and my SAN's queue depth is 128, which means that there's nothing that's going to be waiting inside the HBA. 72 will be held above the server because my SAN and my HBA can send 128 down and accept 128 of those IO. 72 will remain further up the chain. But what if my SAN queue depth at the destination is only 32, but my HBA is 128? Well, that means 96 will wait inside the HBA, and 72 will still be held at the server, while the SAN can only accept 32 of of the 128 that the HBA is capable of sending down. On the other hand, and this is the more common problem, the SAN lets you upgrade it to a nice spinning, you upgraded from spinning disk to a nice orange flash array, for example, but you happen to have a legacy queue depth default setting in there because you never really knew or even thought to change it. So your queue depth setting is now 32 down there. Well, in this case, because the queues overlap with one another, the SAN will only ever see 32 IOs. It can't see anymore because that HBA in between is the bottleneck. So 168 are held above the server. So let's take a look at some actual hard numbers and how does this translate? And remember, this is all Little's law coming into play here. So back in the day, 10 milliseconds was really, really awesome for a spinning disk SAN with effective queue length depth of 32. I'm being very generous here. So that's effectively 32,000 IOPS. I'm doing some rounding here with the throughput and stuff like that for reading purposes. But in either case, my effective throughput is 25 megs. So what did we do back in the days? We scaled out and added multiple disks inside of the SAN. But if I only had a single spinning platter or a single disk in here, this is all I could get. That's why throughput used to be awful terrible if I'm sending 1 million or if I'm requesting 1 million data pages, if that's what I'm trying to do here. Now let's say I bring in an off-flash SAN, but I don't do anything else to optimize anything, and my latency drops. That's fantastic. But my effective queue depth, because maybe I didn't make any adjustments to the HBAs or anything else in my stack, is still 32. Well, I see a huge performance in, or a huge boost in performance, 20x. That's pretty awesome just by bringing in a much, much faster SAN. But that's pretty cool. But we can do much better because if you actually modify and optimize your full IO pathway, increase these Q depths, I'm using 256 as a simple example. Now instead I jump to 160 x instead of 20x. That is a huge, huge gain because now my destination is not going to be overrun. My destination is capable of handling a heck of a lot more IO simultaneously. So with that plus lower latency, I now greatly increase my effective throughput. Little's law at play. So yes, we're all about increasing our concurrency. And this makes our SQL Server workloads happier because, of course, with our SQL Server workloads these days, we're just doing more and more and more and more work. So if nothing else, just remember that queues are everywhere and that almost every single hop happens to involve a queue of some sort, but you need to be mindful of what your shallowest queue depth happens to be. All of us, it's kind of funny that Mark, Andrew, and Anthony and I, we all work for Pure nowadays. We see this happening in customer environments all the time, especially for folks who have upgraded from a older legacy, spinning Rust storage to something new, one of our newer platforms, and they never really had to pay attention to queue depth anymore. So this is one of those things to be mindful of. Or again, if you're virtualized, for example, that's something you have to tune on that level, in addition to the physical HBA drivers and the underlying firmware. So let's come back to the underlying question of, does fragmentation really matter anymore? Remember, because of Little's law and older spinning disks, it absolutely did matter because latency was a heck of a lot higher. So the more IOs I was sending over the wire, it cost me more seek time. But nowadays, as long as I've tuned my queue depths and tuned my IO stack, we can do a whole heck of a lot more. So I would strongly argue that fragmentation, external fragmentation, I literally do not care anymore. And yes, I would much rather nap just like Sebastian. All right, before we continue on to chapter 3, I'm going to pause once again for questions because I'm realizing I'm cooking here and I still have a good, half hour to go. So we're going to finish early at this rate, unless you all happen to have questions or tangents.
Well, there does happen to be a question, actually, one that just popped in that even Anthony agrees is a good one live. So the question is, what if your data files or log files or tempdb files are all on the same volume? How do you best leverage queue depth and avoid bottlenecks? Realizing this may be an it depends question, but question about that is your question.
So it depends on your overall infrastructure, but one of the examples that we happen to have is, say, a VM or virtual machine. So on a VM or virtual machine, you can set up to 4 virtual SCSI adapters. And then you want to, many of us, will use the legacy LSI adapter because we never really think about it. So if you have one LSI adapter, the default queue depth, if I recall correctly, is 32. We recommend that you switch to 4 SCSI adapters, virtual SCSI adapters, and the default queue depth is 255, 256, I believe. So if you change to that, now I have 4 lanes that IO can go over. And then on the virtual machine itself, I'll, either round robin, or if you happen to know your IO patterns, try and distribute those IO or those volumes across those 4 different virtual SCSI adapters as best I can, because each of those are individual queues. I like to think of it more simplistically as different checkout lanes at the grocery store, right? It's Thanksgiving rush. I would rather have, 4 checkout lanes open. And then, I'm going to try and distribute the people as best I can. I see a bunch of people with, just a handful of items, aka the express lane. I can throw them all in lane 1. And then, so that might be my OS disks, for example, and maybe some tertiary disks, for example. I might put tempdb on its own dedicated one because my workload, crushes and hammers tempdb, for example. And then 3 and 4 might be for some of my different data files. Or I might even dedicate one solely to the monster tier 1 database and everything else the tier 2 database, for example, right? So there's a number of different ways you may want to approach that. and it really depends on how far down the rabbit hole you really want to go digging. And if you're not having performance issues, then, you may not have to worry about it. But again, it's one of those things to be mindful of, because if you are, then you do want to go digging for that.
All right, you got 2 questions in Q&A. So the first one, why is I/O so slow in Azure SQL database, even in premium business critical tier?
I'm not going to answer that one. This is being recorded, but I'm going to plead the fifth on that one. But I mean, honestly, Azure SQL, yeah, I'm going to plead the fifth on that one. Sorry.
All right.
Sorry, Mark. Are there hardware differences in lanes that make a difference? I'm not exactly sure how to answer that particular question. Are there hardware lane different in lanes? I mean, if by hardware differences you're talking about, so there can be, like, here's a particular example. So your HBAs, are we talking like 16 gigabit fiber channel cards, or 32 gigabit? Of course, that's, the maximum throughput of the given underlying card. Or even if you're just looking at the motherboard of your underlying server, what is the PCI bus and what is its effective throughput capable of? This brings me back to an anecdote from a couple of years ago when we were doing some backup testing internally at Pure, and it was on an older bare metal machine, and we were hitting a artificial ceiling of some sort, but it was one of those round numbers, and we were kind of unsure why. And Anthony and I, we dug into the documentation of the actual server model itself, and it was an older server of some sort, and we found out that there was what's called a riser card in there. So the PCI bus, not only did we find out what its effective throughput was, but because of the riser card, it was cutting it in half, because a riser card means now I can take 2 cards into that one single slot. So it essentially cut it in half. So those are sometimes things that, yes, you do have to be mindful of. So Karen, I hope that answers your question. Sometimes it does come down to the server specs.
All right. So there is someone here who has, it's more of a comment, but I think it's an interesting one for perspective. The comment is fragmentation absolutely does matter, as page splits themselves are unwanted performance overhead which come into play. There was a comment earlier talking about some of the work that Paul Randall had done. So if you have fragmentation with the page splits, from the read perspective or write perspective, what sort of performance, the thought is that there's still some performance issues. I'm paraphrasing, so hopefully I'm paraphrasing properly.
Yes, I see the question in the Slack channel. So what I would suggest is I would challenge that by suggesting that you go find Jeff Moden's Black Art of Indexing. That particular presentation on there's a couple of renditions on YouTube that he's done. That will also completely change your mind about fragmentation as well. That is one of those things that melted my brain when I first watched it a number of years ago. So again, Jeff Moden, M-O-D-E-N, he's the gentleman who actually coined the term rebar many, many years ago. And he's got an amazing presentation also reinforcing that fragmentation and page splits really are, yeah, who cares? There's a lot of who cares in it. And yeah, go dig into that one.
I'll see if I can find a link.
All right, cool. All right, with that, why don't we keep on cooking, and let's continue with our final chapter, going beyond the storage fabric. All right, so Sebastian, I see you've been playing with an 2019 availability group and it's lagging. Okay, fine. Tell us a little bit more. All right, nightly data load. So yeah, I get it. Usually, you're doing a lot of DML during a data load and that sort of thing. And oh yeah, the amount of data is quadrupled. That's pretty typical, right? So there's fundamentally a couple of different places where I/O can stall in the in an availability group architecture. Oh, but that's an interesting little detail. Latency being okay, but the bandwidth is only 30% utilized, that you're not, crushing your pipeline between your availability groups. All right, that actually kind of gives us a little bit of a hint here. So let's do a quick overview of the journey of a log block, a transaction log block in the life cycle of an availability group. So the first thing that happens in parallel is that transaction log block is written down to the SAN, and you see a write log wait that occurs at that particular time. And at that same time, it's also then shipped over the wire to the secondary replica. And once the secondary replica receives it, then it gets hardened on the secondary. A second local write log wait timer kicks off at that point. And then we also see HADR synchronous commit wait also kick off as well. And then eventually, once that is done, we will the secondary replica sends an acknowledgement back to the primary replica, at which point then SQL Server then sends the commit back to the application. Hey, we're done. We're good to go. Now, eventually after that, SQL Server does the redo of applying the logs to the underlying data files thereafter. So when you're looking at, availability groups from a higher level, oftentimes we will investigate, how much log send queue do we happen to have, or how much redo queue do we happen to have in order to try and figure out where my availability group bottlenecks happen to be. But to kind of generalize a little bit more, it's, the three different possible places for a stall. Once we're going over the wire, whether we're writing on the secondary replica down to the secondary, and then writing out the redo queue down to stall 3. I'm assuming that the initial local hardening down to the SAN 1 is fully optimized already, since we already talked all about all of that, right? So just a quick summary of those 3 stall points. But stall point 2 and 3 are all disk related. Again, stuff that we've been talking about in the context of this particular presentation, where stall number 1 is network related. And when it comes to network and availability groups, there's really kind of 2 mechanisms behind the scenes that I want to spend a few minutes talking about, and that I feel like are things that are not talked about all that often, but should be. Flow control and UCS boxcars. And oh yes, of course, I'll give a shameless pitch to Edwin, who will be on not after me, but thereafter doing an internals availability group presentation. So I'm not going to steal too much of your thunder, Edwin, if you happen to be on right now. All right, so flow control first. Flow control is another gating mechanism. One log block, one transaction log block equals one flow control message. And the flow control gate will control the number of outstanding messages that can be in flight at any given time. There are 2 different limits. One is per database, and one is for the endpoint or the total transport as well. So, if I happen to have an availability group set up with like 30 databases in there, again, I have limits on each of the databases, but there's also a cap on all 30 databases. That's the transport total. And if you do need to start tracking this, you can use perfmon and or extended events for this. The second one is UCS boxcars. This is a communication protocol that takes those different messages and creates containers for them. And then you have a different parameter called max UCS send boxcars, which limits the number of outstanding boxcars. We'll see all of this come together in the next slide. So let's talk about the life cycle here. I have a log block. 512 bytes, anywhere between 512 bytes to 60 kilobytes, of course. That's a standard SQL Server transaction log block. That is one message, regardless of the size in between. So remember that the flow control gates will limit the number of messages in flight. Each given message is then serialized into one or more UCS packets. And then those UCS packets are then regrouped and kind of piled back together into a UCS boxcar construct. And then it's the max UCS send boxcars parameter that gates the number of boxcars that are in flight. So this is queuing theory all over again, but now on the network level. So these are the similar principles. It's not officially a queue depth, right? But it's fundamentally is a queue depth and queue length if I were to use those terms in a looser fashion. And then eventually that UCS boxcard is the mechanism that is written to a TCP connection, and TCP then chops it up, just like you remember how that storage port driver will take an IRP that's been translated into SCSI commands and chop those up into the individual storage IOPS. TCP connection will chop up a UCS boxcar into TCP network packets to then send over the wire. Latency is the enemy of every single step here. Again, this is all queuing theory. This all goes back to Little's law. So this is if you're using availability groups today, this is one of the more critical reasons why I really encourage customers to upgrade to a newer version of SQL Server as soon as possible. If you're making heavy use of availability groups and you happen to have various different bottlenecks, if flow control happens to be one of your bottlenecks, check out this. Use those extended events and or performance counters to see if you're being bottlenecked on flow control. Okay, so the limits were increased in SQL Server 2022. The good news is that if you are on an older version of SQL Server, Microsoft deemed this as being so important that they backported it. They don't backport everything, but the things that they do deem important, they do backport. So these are backported in different CUs all the way back to 2016 SP1. That's how critical Microsoft deemed this to increase the limits because of the way people were using availability groups and the way customer workloads have evolved. So understand it's behind a trace flag, and this is a startup parameter only, meaning you will have to bounce your SQL Server, meaning downtime. And SQL Server 2025 brings a new tool to play to impact or help us modify or make an adjustment to max UCS send boxcars. That limit has been increased. The default ceiling used to be 256. Now it can crank it up to 2084. This was is available to you in 2022, but it's only exposed as a registry setting. But now in 2025, it's an SP configure, so it can be done online. So, Sebastian, you had mentioned that, the amount of data had quadrupled. So, definitely check those different types of things first. Go check out, the flow control stuff. Wait, what? Sebastian? I told you this was a startup parameter. You flipped onto the trace flag. It's 1 o'clock, man. You did this during the workday to a prod server? I really wish I could take 3-hour lunches. That's got to be kind of nice. But yeah, if I was an operational DBA, I guess 3-hour daily maintenance windows would be kind of nice if no one would notice during the middle of the day. All right. Yes, Sebastian, it's almost time for your walk. Let's bring this on home. Hopefully, after this last hour or so, you have a better appreciation that IO isn't just one layer, it's very many, many different layers. And hopefully you also have a better appreciation that even in my simplified examples that we talked through, that there are queues that present themselves at multiple different layers of the stack all over the place. And hopefully you also have a different appreciation that a lot of these different defaults were set back in the Stone Ages for spinning disk or workloads that were a lot lighter weight or just more terrible network, older hardware, right? And just like a lot of the old defaults, vendors don't necessarily change those defaults. They'll just leave them in place. Cost threshold for parallelism is a great example. Instead of SQL Server, for example, we could pretty much probably afford to crank that one up as a default across the board, I would argue. But again, that's a different debate. But point is that these defaults were set for old school hardware. You need to review them, especially if you've upgraded to relatively modern hardware. The thing is, though, the bottleneck very rarely ever disappears. It just gets moved around. It's really the case. There's always going to be a bottleneck somewhere or other, but hopefully you'll be able to decrease the impact of a given bottleneck. I mentioned before that this particular presentation is part 4. I like to think of it as almost the epilogue to this particular trilogy of presentations here that I've been doing over the last handful of years. Check out all of these. These are all on YouTube. And again, you'll kind of see how each one of these build upon each other. So if I've lost you through some of this presentation, go back and watch one of these other ones, and that'll help set more of the foundational type thing. So I'm going to leave you with one other parting thought. Don't worry about trying to become a storage engineer. To become a comprehensive performance tuner, what's really important is just to have a working understanding of all of these things. Remember that you've been exposed to them. Remember that, hey, I remember that Andy talked about this type of stuff. Maybe that's something I should ask one of my colleagues about. But now you can make more informed questions or determinations about who to potentially ask more questions about. That's what this is all about. It's not becoming an expert in everything, because unless you have a photographic memory, you're not going to become an expert in literally everything. But it's to have that working knowledge, to have that exposure to things, so that way you can more effectively collaborate with other subject matter experts in other verticals, like your storage admin, like your virtualization admin. So with that, I mentioned that there are definitely more learning resources here. So, we got some stuff by Bob Dorr. We got some stuff by Anthony. SQLTableTalk.com is one of those underrated websites that I really wish would see more exposure. They do a lot of really cool stuff on internals. There's a number of different authors behind that particular site, but I wanted to call that one out here as being really cool. On this particular resources slide, there's a really cool guide to using Process Monitor, because there's some really cool stuff that you can do with it to dig in even deeper. And of course, another blog post by Anthony. There's like 8 of them. He's written a whole ton on this particular subject in general, and his blog in general is just an amazing, fantastic resource for all of this stuff. If you want to get into store port queue management, there's something and or filter driver troubleshooting. Use that last link as a jumping point. That'll take you down a completely different rabbit hole and tangent to really dig into all of that. And that's actually really, really low level stuff. When I was doing my research, I'm like, my brain definitely melted when I was digging into all of that. All right, so with that, we have about 10 minutes left of my original slot. So I ended a little faster than I expected to, but I did tell you I was going to move fast anyway. So we have plenty of time for Q&A if you happen to have any. Otherwise, thank you so much. This has been a pleasure and an honor to finally present for EightKB. Hope you had some fun. I did. Thank you.
Well, you do have a question still. There's one in the Q&A.
Yes.
How would we change how we use this for having write-heavy versus read-heavy workloads?
Change which aspect, Karen? I'm not really sure what you mean. Are you referring to queue depth settings? Given that it popped up about 1 minute or but yeah.
How to take
How we
all of
take
this
your
and use it?
Well, really, it's all about analyzing where your bottlenecks happen to be, whether it be read heavy or write heavy, and then just figuring out what you actually need to tune. Because even write I/O is still I/O that has to fly over the wire, right? And it's still I/O that can get stuck in different queues all along the way, whether it be read or write. Read is just easier to talk about, but it's still stuff that can get stuck.
I'm not quite sure if this is a question, but did you, there was a question about compression over AG mirroring ports might only apply to initial seeding. I'm not sure if there's a full question with that. If there is, if you can put that in the Slack channel.
I'm trying to find it.
About 10 minutes
Oh,
ago
wait.
from Lars.
It could help if I use the right mouse, because I have the Slack on my other laptop over here. I was using my main. Are we going to talk about compression over AG mirroring ports? Might only apply to. So I'm definitely not going to talk about that, but Edwin might. So, he's got an entire presentation about availability groups later on. I'm punting to him because, frankly, I'm not sure of that. But Edwin, like I said, has an entire presentation about availability group internals. So wait about, what, an hour and a half or so? And then bring that question back up again. Edwin will be able to answer you on that one.
Okay. There's another question that just came in. Will the same concepts work for hyperscale architecture in terms of buffer pool, resilient buffer pool extensions, page servers?
I don't see why it wouldn't. The buffer pool extension thing is one that I don't necessarily have ever dealt with, and I'm not sure what you mean by page servers either. But the point is, if nothing else, there are queues everywhere and all in your I/O paths, no matter what, whether it be HCI or whatever, versus bare metal versus virtualized SQL servers. So there's going to be bottlenecks somewhere. So it's all about understanding what those queue mechanisms happen to be in your HCA implementation. Or HCI implementation. I said HCA.
Yeah. The question about the file cache came up again. I don't know if we fully answered it the first time. This
I'm
was
not 100% certain how to answer that one, to be perfectly honest. But you know what? I have a couple of other colleagues on this call. I'm going to put them on the spot to see if any of them happen to know the
Yeah.
answer.
No, I'd answered in the chat. So basically, when you create or open a file, you can pass a parameter into that call that goes out to the operating system that defines the caching strategy that that file will use. Whether and the two key ones for like a transaction log file are write through and don't use the file system cache. So if you're on Windows, it's something like file underscore no buffering. If you're on Linux, it's auto-direct. And so what that means is to your application, it's never going to leverage the file system cache for blocks versus what you'd want out of like something like a transaction log. The last thing I'd want my transaction log to do is flush a log flush out and have the file system tell me it's done and it's not actually on storage, right? And so that's what those two flags do. Is it basically says when I push blocks down the IO stack, I'm going to wait until I get a reply back that it's out. Those bytes are actually laid down on disk. So that's the core functionality there. And you'll see that both on Windows and Linux. Well, actually, any operating system has a file system in between you and the disk.
Thank you so much, Anthony. I really appreciate it.
Yep.
Anyone else?
I have
Going
questions.
once, going twice?
you have questions.
Yeah. As we look towards NVMe, right? Windows finally has local NVMe drivers drivers for local NVMe disks. What's the fundamental change that that's going to bring to the party when we get that for like over fabrics or whatever? This actually doesn't matter. What's the fundamental change that's going to bring to the party for us as database folks?
If I remember the internals of NVMe, if nothing else, I mean, well, from the easy answer is that more performance. It's going to be a heck of a lot faster. If I remember correctly, the queue ceilings are a heck of a lot higher. I forget what the exact numbers are. But of course, Anthony, I'm going to throw it back on you because you've already done some research on this one and written a really awesome blog about it.
Oh, okay. I was just trying to throw you a softball to kill some time.
Yeah, but I'm going to throw it back at you because I'm done talking.
Good point. Yeah, so I think for us as DBAs, like all the stuff that Andy talked about and all those IO strategies that get pushed down the wire, whether it's even local or remote storage, everybody's got to get in line to do a thing. And that's going to take time. It's going to take as long as it takes to get the IO to and fro, like out the storage and back. And SCSI's quite literally serial, right? One after the other. You saw everything get in line, but there is potential for threading, yada, yada, right? More PV SCSI adapters. But what NVMe brings to the party is the queue depths that Andy was talking about are like 65,000, right? The number of queues is, I think, 65,000 as well. So there's a lot more lines to get in and a lot more queues or depths that we can queue, which means we can do more stuff faster. We did some internal testing on our side last year when Microsoft previewed the local NVMe driver, and we constructed a thing in our lab and changed nothing except the driver and got a 25% performance bump, right? So this is like for us as DBAs, that's why this matters. So when your storage folks are like, yada, 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 NVMe, it's free performance, right? That's kind of the takeaway for you all.
Sorry, I was just answering a question or a statement in the Slack channel here, but someone was just, kind of making the observation or the statement about how modern SANs, bring so much more to the table. And it's more than just speeds. A lot of modern SANs, such as the ones that we work with, bring other capabilities to the table as well. Again, I'm not going to make this into a commercial or nothing like that, but just understand that if nothing else, you as a DBA should really ask, your SAN admins, what storage are we using today and what other features does it bring to the table? Because there may be capabilities that can make your life easier. And of course, if you do happen to be a pure customer, just reach out to us and we can tell you all that.
We have a fun job.
Very much so. And we get to do cool stuff like this on the side too.
And it looks like someone has also posted the link to the previous sessions in the Slack channel. So if you're impatient for waiting for the slide deck, like this one, the dog on my lap, you have them available to you in the Slack channel.
I was wondering if you're going to bring Sebastian on camera.
Yeah, of course.
And so people, no, I'm not. If people are looking for the slides, Andy will definitely upload them to the 8KB repo as well, won't you, Andy? Won't you?
Yep. They'll be
Thank you
both
very
there and in my repo shortly as well.
Cool. Okay.
Well, with
Can
that,
I grab?
Cool.
thank you once again.
Nice work, Andy.
Yeah. Thanks.
Yeah,
Andy.
thank you very much, man. That's an awesome session. And I think we first and probably the only time we'll ever have a husband and wife team on the speaking and moderating.
You know, we may be able to wait. Where is it? Yeah.
I don't know. You want to get Paul
We-
and Kimberly on?
Well, I mean, y'all didn't
I-
ask Monica to moderate for John.
I was gonna say I can
right,
fix
Come
that.
on, y'all. Missed
Yeah.
opportunity.
I can
That was
fix
a
that.
miss.
I know, right?
Is she in the same room?
No, she's downstairs.
Okay.
I think she's eating lunch right now.
Beer's getting big, dude.
Yeah, I know, right?
Like
What can I say?
Andrew, are you still with us?
Oh, there he is.
Yeah, no, my video is flickering. It's really annoying me.
It's not that
My-
noticeable. It's okay.
I think my webcam has finally decided to go. Oh, you know what? No.
It's only noticeable if any of the attendees have you pulled up full screen all the time.
I mean,
And
he
I
might have
really,
some
really
fans.
hope
He's
you
probably
don't.
got some fans out there, right?
That'd be weird. Don't do that, folks.
Yeah, I think like one of the key points that Andy had during his presentation that quite literally every day at work we have to not debunk but just kind of clarify is the difference between what we see as DBAs inside a SQL server and what the storage folks see on the wire outside a SQL server. Like we might be doing 1 megs, 4 megs, whatever inside a SQL server, and the storage person's going to be like 64K, 128K. So just park that in your brain, and whenever you get kind of have those storage conversations with your storage team about what it really looks like on the wire to them, it's just quite literally two different worlds.
Wireshark for everyone. I love it, Andrew.
Okay, let me grab the slides. Let me actually make sure I've got the right slides up. I think after 8 attempts, I'd be better at this, and I'm not. Slideshow. Okay, so yes, please do leave feedback for Andy and the event overall. We are 3 sessions in. Everyone feeling a bit mind melty? We had 3 amazing technical in-depth sessions. We're not going to let up. We've got 2 more to go. Online resources for everyone. We've posted these in the Slack channel as well. And coming up in, what time is it?
15, 14.
So we have 15 minutes. 15 minutes, and we have John coming up with diving into ADR. So should I just leave that up there, or do we want to go back to the normal view? Let's go back to the normal view.
I don't want to steal John's thunder, but my
Full screen,
perspective of ADR is you can just turn it on.
Yep.
Right.
I
You get
gave
the goodness.
presentations on optimized locking, and the first thing I do is when I explain ADR, I say, go watch John's sessions. So I've been telling everyone to go see John and come here for this.
You want to know what my favorite thing about ADR is? And I'll mention it. It's in standard.
Yay!
Yeah.
Yay!
And it quite literally is I think we're probably getting too far into your content, but like it's
You're
totally an availability feature. It has nothing to do with like performance or
Yeah.
anything, right?
Oh yeah. Oh yeah, totally.
Actually, I have questions about that, but we'll try to hold on another 90 minutes.
Well, I'll cover some of that availability in the because there's components about ADR that facilitate that. So I'll talk about that. For
Yeah,
sure.
no offense to the rest of the speakers, but I'm super excited for your talk. This is a cool
Well, I
topic.
appreciate that.
Hey,
like this
I'm
talk.
super excited for this talk too. So
Yeah, that's a good one.
You know how I feel, John.
Yeah. I feel you.
Heart emojis all around.
Well, while you have time,
Oh,
can I
it's
test my
not going to stop flickering. Right.
can I test my screen sharing
Absolutely.
while we have plenty of time? Oh, there's the share button. You should see my slides. Oh wait, hang on. You have to push the share button, John.
Yeah.
Welcome to my world. Every time.
So you should see slides. Yes.
Yes,
Yes.
sir.
Oh, that's the wrong slide. I can't get out of it now. Oh, there we go. How does that look? You should see SMS.
Yep.
Yeah, looks good.
All right, perfect. Then everything works.
Excellent stuff.
And Matt's
Little-
here.
Little announcement too. Bandanas are available in the store now, but
Nice.
unfortunately they are out of black. They only have white. They're both listed, but hopefully black will be in stock at some point.
Why do I feel Andy is buying one now for Sebastian?
Sure he
Yeah,
is.
I am.
I just wasn't sure if anybody would want to buy a white bandana for a pet because my
How
pets
dirty
are
they get?
not
No.
clean animals.
They
Yeah,
tend to
exactly.
find where the dirt is. Yeah.
Yes.
Despite being short-haired, Sebastian will shed, and so even if it was black, it'll be white.
Okay. Well, maybe white's
Actually,
better
that's a
then.
good point. Should we get a white one?
I don't know. What do you think, Sebastian? You can't see, he's giving me a side eye.
Hmm. After this, I get to go hop in the truck and head towards Boston.
And see us.
Yeah.
Very cool. How long a ride is that?
It's 10 hours, but we're gonna break it up over a couple days, I think.
A wise plan. And some of that traffic's got to be not fun on that run.
It's straight through the heart of New York City.
That's what I was thinking. Yeah.
No, thank you.
And last time we did it, I did it with a 6x12 U-Haul trailer behind my truck. I do not recommend.
No trailer today.
No trailer. Nope.
Okay.
I fit everything in the bed of the truck.
I live in the country now, so I can't handle any amount of traffic. I just
I
lose
have
it.
found, I don't know about the rest of anybody else who works from home, but I have found that my road rage is actually significantly worse now because I've worked from home for so long. I cannot stand the idiots on the road. My sons will tell you, my sons, like I'm one of the idiots sometimes too. Like I know that I'm also part of the problem at times, but me in traffic nowadays, don't like it. Nope.
Mine's just gotten worse because I live in Boston now. Thank you, Deborah.
Maybe we're
Oh,
all
you have
just
to
getting
deal with actual
older.
twists in the road instead of the block system,
Well,
as we
I
would
mean-
call it, driving.
I mean, just because we have roads that were designed by cows, I don't know.
We in this new place, our driveway's in the corner of a cul-de-sac and at an angle, so you have to reverse up and go. And as you reverse onto the curb, you have to turn the steering wheel. And I cannot do it. My wife can just zip straight in, but because I don't drive that much because I work from home and we live in the center of Dublin pretty much. So,
Andrew,
but yeah,
your clock on the wall is kind of freaking me out.
oh, with the clock again.
Oh, yeah. We have an owl clock that's kind of like
That's
that.
like the fourth time that
it's a little
clock's been
disturbing.
mentioned.
Sorry, I mean, like I didn't notice it until like I just caught it off out of the corner of my eye. And I was like, okay, that's a really cool clock. Sorry, I didn't mean to call attention to your clock on your wall.
No worries. Look at the
I mean,
weird
we've
thing in his wall.
yeah,
I
we've
mean-
done it at intervals now, so
I mean, I got a bat on mine, so. Oh yeah, Rob just posted a picture of my truck in the Slack channel.
Yes, he did.
Oh, that's a proper truck as well. Jeez.
Oh yeah. It's diesel. Rob drove it.
I have to say, when I go to the States and rent a car, I like renting one of the big like SUV things because you just can't get. Well, it's not that you can't get them over here; it's just you shouldn't. Um,
That's the truck I have. Mine's a 2017 though. It's a bit older.
no,
That's it.
absolutely comment in the Slack channel they would not fit on an Irish road. Well, they would. There
Well,
wouldn't be any traffic coming in the other direction.
Correct.
even Irish cars in Ireland don't fit on Irish roads because I drove once and I had like scrapes on the side of my car because it was yes because the roads are like this big.
Rob and I have talked that truck, my truck, won't fit on the roads in the village that he and Trace live in.
Mine doesn't fit on the roads that I live on.
Yeah,
It
there's
is-
streets
it's
around
country.
here that your truck will have trouble with as well.
Oh yeah, oh there's roads here in Virginia that my truck is like, I'm not sure I want to go down that road.
I was gonna say there's lots by me, the narrow like horse farm roads where you would take up both lanes, and
Yeah.
lanes is a speculative term on these
And-
roads.
And this is bad, but because I have a bigger truck, my road rage gets worse. So I have to and I can't stand people in traffic nowadays. So I have to pay attention to it.
It's funny. I passed a smart car earlier, and I wonder if you have road rage in a smart car, do people just make fun of you? You're just and your car is this big, right? Having a big truck and road rage, that kind of makes sense. You can do something about it. Smart car road rage is just adorable.
I'm pretty sure I can fit the smart car in the bed of my truck.
I think you can.
I may or may not have wanted to try that more than once, just to see if I could do it. I just think it'd be funny.
It's not the worst idea.
No.
Potentially illegal, but
How's the how's the attendance been? I had missed I missed Chrissy's, unfortunately. I had to get ready to leave after this, but how's the
Good.
attendance
It's
been?
been really good.
Good? Awesome.
Really well attended sessions. Loads of chat going on in the Slack channel, which we absolutely love. There's a reason we don't do chat in Zoom anymore. We want everything in the Slack channel because it's just otherwise you end up with the Q&A panel, chat in Zoom, and the chat in the Slack channel. And our moderators are talented people, but they've only got one set of eyes and one pair of hands. So, and things get missed. So. No, it's all good to have it all in the chat, and there's been loads going on in there today.
As right of late. That's funny.
To talk about driving and road rage, John. So I live in a college town, and this time of year, everybody comes back to college,
Yeah.
right?
Well,
And for move-in weekend, right? For move-in weekend, everyone comes back to college, and all the parents come back to college with their giant SUVs. And so basically, like the Wednesday before move-in, like we do all our grocery shopping and we do all the stuff that we need to do around town, and then just avoid going out until like all that dust settles. It takes about a week and a half. But then you're left with a bunch of 18-year-olds who've had their driver's licenses for like 1 or 2 years that all just showed up on campus, right? It's about 9,000 of those folks. You're like, wow.
My favorite driving story is when you came over here. It was for my wedding, wasn't it? You drove from Dublin Airport into the center of Dublin.
Yes.
And I was just like, no, don't do that. Nobody does that.
Well, for the because I wanted to, I thought in my brain, I'm like, I'm coming straight from the downtown Dublin to the wedding, which is outside of Dublin. So I just got the car, drove it into the city, and parked it for 3 days, and then went to the wedding. Right?
I told you
figured
to
that was
pick it up
easier.
afterwards. Yeah.
I was already at the airport.
how many international incidents happened in the journey from the airport?
Anthony's never had an accident. He's seen thousands.
Right.
They tend to happen
So-
around him. It's very strange. Yeah.
So if you've ever rented a car at Dublin Airport, what they don't tell you is it's very easy to do, with the exception of this. As soon as you leave the airport, you get into this giant traffic circle where it's also like giant trucks are in.
Circle.
And so
Sorry.
you are not only like driving on the left, it's a stick, no big deal. But then it's the traffic circle. So it's like immediately level 500, go. You're like, so like eyes are twitching, shaking. It was.
is that
But
also
it's
called
the
a
same for us
roundabout?
over there. The first time I drove in the station in Chicago, you pull out of Chicago Airport, you get dropped onto like a 16
Oh my
lane
gosh.
freeway.
Yes.
Yeah,
Yeah.
you do.
I've been in Chicago. I don't like driving in Chicago.
There's a video of me my friend took of me sailing through a toll booth. Supposed to go over there to pay or go to the electronic booths. And I'm like in one lane and the other one's over on the other side of the freeway. And it's like, I need to go over there. And I'm just saying to my mate, that's just not going to happen. We'll pay the fines.
For those of you who know Frank Gill, he just posted a photo of him standing next to his car. For those of you who don't know Frank, he's a very, very, very tall gentleman.
Yeah,
He drives a very, very, very small car, which is also comically awesome.
Frank is
Normal-sized
also
car.
a fantastic individual. He's a great guy,
Yes.
but he is tall. He's what, 6'7", 6'8"? He kind of makes me look small.
I have teenagers, so whenever I hear 6 and 7
Oh,
together,
oh yeah,
I-
me too. Me too. Yeah.
there's a contract. I have to do it. Yeah.
No, I know
I'm
I'm
not
old, but
proud
I
of
just
it.
I don't understand that at all.
Me
And
either.
I don't want to.
No,
If I'm
Frank,
honest.
I wouldn't. I would just drive through Chicago with my truck. I would just drive through. I would not stop. Just go.
Say there was a run of a few years where I was only driving through Chicago towing a race car. And trailer in Chicago traffic is a level of road rage I had not previously experienced.
Oh,
Which
Dirk,
is
that's the magic roundabout in Swindon. Well,
well, that your road rage in Chicago was probably equivalent to my road rage with a trailer in New York.
Oh, yeah. Yeah.
We also had to remind John, because it's a college town, there's one area that for college move-in that U-Hauls and trailers are and the big trucks are not supposed to go on because there's a height limit. There's a term for it. It's called stirrowed, and it happens pretty much all the time where someone goes on it and the top of their truck gets like taken out by bridges and stops traffic. But the biggest times we have to tell everyone is the move-in weekends of don't get stirrowed.
That's good to know. So Louisville has a can opener bridge, but it only gets like semis.
I remember that.
so for everyone
yeah.
who's just tuned in, welcome to Trucks R Us. We are the only truck internals conference. We've got about a minute to go, so we will all mute ourselves. And John, the floor is yours.
Cool. Matt, stay on.
You want me on camera?
Yeah,
Hopefully.
I don't care. I just need your voice. You can stay on camera. I need a witness to what I'm about to do.
Okay. I'm here, and then I'll answer questions in Slack where I can. I'll save some for you.
Cool.
For
Interrupt me.
breaks.
I'll take pauses to drink and whatever. So feel free to feel free to interrupt me, whatever works.
Okay.
You should see Management Studio. Yes.
Yep.
Just to verify, we are in the ADR off demo, and I had a query that has been running for 2 hours and 1 minute and 28 seconds. Yes.
You did, so I probably wrote it. Yeah.
Okay, now we can start.
All right. Rock and roll. I'm gonna go off camera, but I'm here.
Yep. You are good. Let me get this stuff set up. Cool. While I'm getting stuff set up, accelerated database recovery. This is a thing. Microsoft every now and then comes out with. Actually, I have to swap displays.
I was gonna say, just to
Thank
note,
you.
we're seeing the secret bits.
Secret
All right.
bits.
Now we're good.
This is a product that has been out for a while, but I think Microsoft every now and then comes out with a feature or a release that I think is one of those game changers that really changes the landscape of how database administrators handle SQL Server. And so we're going to talk about that today. We're going to talk about accelerated database recovery. We're going to kind of go deep dive into the magic. I'll talk about how it works. We're actually going to crack some pages. My name is John Morehouse. I'm a principal consultant with Denny Chair and Associates. My contact information is on the screen before you. Feel free to email me, reach out to me on LinkedIn. I am on Twitter, X on occasionally, more often LinkedIn than anything else nowadays. I do blog at johnmorehouse.com. I've been in the IT world since I was 18. I turned 50 a couple weeks ago, so you guys can do the math. Honored to be a data platform MVP. So I'm pretty heavily into the SQL Server community these days. Slides and demos are available. On the left-hand side is my personal GitHub repo. So if you like this presentation, you want to see some other stuff that I might have done, feel free to go out there. I've already uploaded my slides and the demo to the 8KB GitHub repo on the right-hand side. So feel free to go check that out. Also go check out the other wonderful presentations that we've had today. it's been a truly a day of mind melting stuff. So the organizers have not let us down in that regard. And speaking of that, make sure you go support the conference. The leadership, Anthony, Andrew, and Mark, they do this out of their own accord. So if you can go out to bonfire.com and look at the store, they've got some great merchandise that you can buy. I've got a couple t-shirts myself. Make sure you go support the conference so that way we can kind of continue doing this year in and year out. So what are we really going to talk about with ADR? We're going to talk about what it is and really why do we care about it. I'm going to go through the various components that make up ADR as a whole. There are a couple components that individually we might have heard about already or not, but I'm going to go through all the components and kind of bring it all together. And then in the demo, we're going to really see why it matters and what the magic is. We'll do a review of how SQL Server handles rollbacks and recovery, both without ADR and with, so we can see what that really translates to database administrators when we manage SQL Server. And then, of course, I've got a demo. The slides are, I'm sorry, the demo script is available in the GitHub, so if you want to follow along, you feel free. Then I'll hopefully have time for Q&A. Then after I get done presenting, Edwin will do a great presentation on availability groups. If you can't read at night, or I'm sorry, can't sleep at night, this is the bit.ly link will take you to a white paper called Constant Time Recovery in Azure SQL Database. It is basically the white paper that talks about the underlying architecture of how ADR works. It is a fantastic white paper. So if you are looking for something that you want to go a little bit deeper than what I'm going to go, I highly recommend that you download it. I think it's 10 or 15 pages. It's got a really great explanation of how things work underneath the scenes. So I definitely recommend that. I did give the link to Matt, so Matt was going to put it in the Slack channel so everybody can go get it. With that, what is ADR and what does that really mean for us? So the official guidance from Microsoft is that accelerated database recovery improves database availability, especially in the presence of long-running transactions, by redesigning the SQL database engine recovery process. That's kind of long-winded in my opinion, but that is pretty much what it does. So it gives us some really cool new features on how we can handle long-running transactions and rolling those transactions back. Why do we care? Why do I, as a database administrator, really care about this new feature? Well, this is where if I was in person, I would ask the audience and ask everybody to raise their hands. Most of us probably have been in a situation where we have had a long-running transaction in SQL Server that is not running ADR, and we've had to roll that back in some fashion. Somebody hit cancel, an intern walked into the data center and pulled the plug on the server, something happened, and that transaction had to roll back. Now, we've all heard those horror stories, and some of them are really bad. I have heard rollback stories that have been days in process, and that there's nothing you can do about it. And it never fails. You've got some C-level person, a CEO, CIO, CTO, somebody standing over your shoulder, wanting that process to go faster, and there's really nothing you can do. Without ADR, you're stuck. Now, one of the worst things you can do is reboot SQL. When a transaction right now rolls back, all you've done is prevented and locked up the tables that are involved in that query. If you reboot SQL, you've now locked up the entire database. So if nothing else, if you are not running ADR, if you ever get into a situation where you have to roll back a transaction, do not reboot SQL. Your entire database will have to go through crash recovery before it comes back online. You've effectively locked out the entire database. So please do not restart SQL. But ADR gets us out of that problem. We get faster and more consistent database recovery with ADR enabled. We get almost instantaneous transaction rollback. I do say the documentation says instantaneous. It's not really instantaneous. There are a few microseconds and milliseconds delay for a transaction to roll back. So I don't call it instantaneous, but it's close. So ADR helps us get that facility. And if you were on the Zoom call before when we were chatting, one of my favorite things about ADR is that it's available in standard edition. There are still many organizations out there today that are running standard due to licensing costs. If you are, you can take advantage of accelerated database recovery as long as you are in SQL Server 2019 or higher. So I think this was a great decision by Microsoft and not gating it behind the Enterprise Edition and making it available in standard. I think was a fantastic decision by Microsoft. If you heard me talk about optimized locking, you actually heard Deborah mention it earlier, and when we were just chit-chatting earlier. It's actually a foundational piece for optimized locking. You have to have accelerated database recovery in order to enable and use optimized logging. And by the time I get done, hopefully you'll understand where that kind of comes from. But I do have other sessions on optimized locking, so go check out my GitHub, and you can look at the slides there. And actually, ADR is defaulted in Azure SQL Database and Managed Instance. Microsoft has put so much emphasis on this feature that it is defaulted in the Azure SQL Database and Managed Instance products, such that you can't even remove it with Azure SQL Database. If you try to turn it off, Management Studio will tell you to pretty much pound sand and go away. So it is such a solid feature. Microsoft has deemed this to be defaulted in those two products. And I can't remember if 2025 it was defaulted or not. I haven't looked, but don't be surprised if that becomes a default at some point in time. It might not be in the Box product yet, but at least with the platform as a service offerings, those SKUs, it is default by right out of the gate. So you can't do anything with it. Can't turn it off either. So super cool, super important. Microsoft has deemed this such that we're going to default it in these products. So let's talk about the new components that ADR introduces into our SQL world. We have a couple of them. One, and the first is probably the most important, is the persisted version store. We have a new log concept called the S log. We have a new bitmap called the aborted transaction map. If you're familiar with the internals of SQL Server, whether you have like a page free space map or the diff map, same kind of concept. We have a new concept called a logical revert. And then, of course, we have a cleaner. And we'll get into all these components. So we have 5 new things that we're going to kind of go through. And then I'm going to demo pretty much all of these. So persisted version store. The version store is the exact same thing as if you use read committed snapshot isolation. If you're not familiar with read committed snapshot isolation, RCSI, what that does is when you enable that, SQL Server actually puts a 14-byte pointer on the data page, the 8K data page, and that pointer goes to tempdb. In tempdb, SQL Server will write the most committed version of that data into tempdb. So that's called the version store. That version store currently lives in tempdb. When we enable ADR, that version store actually comes out of tempdb and now lives in the user databases. So it's the exact same version store that RCSI uses. It's just now living in the user database. In such that even if you have ADR enabled and you turn on RCSI, it's still going to use the persisted version store within that user database. RCSI will no longer use the version store in tempdb. Now, the version store contains off-row versions. So when I say off-row versions, that also implies that there are in-row versions, and we're going to get to that in just a second. And also with the version store now living in the user database, it makes it availability group aware. We were kind of talking about this earlier. So if you are taking advantage of availability groups, in Edwin's session next behind mine, he's going to do a deep dive on availability groups. The version store will actually fail over when you fail over your availability group. So SQL Server can now take advantage of ADR on both sides of your availability group on both replicas or all your replicas. This, by doing so, this helps facilitate faster recovery. And we'll kind of talk through that as well. But having this be availability group aware is a great feature because we can now fail over faster and more consistently because we can take advantage of ADR. I mentioned in-row and off-row versions. The persistent version store stores my off-row versions, but they are also called in-row versions. And these are when when SQL Server makes a data change, if the data change is small enough, SQL Server will actually store the version of that data in the row itself on that page. Now, a page is only 8,192 bytes or 8K in size. That's a fixed size. You can't change that. So there is a threshold. If the change is big enough, SQL Server will actually push that version out of the page itself and into the persisted version store. So there are two types of versions, in-row and off-row. In-row versions are just the delta changes between the old value and the new value. Now, when I get to the demo, I'm actually going to show you on the page the old value and the new value so we can actually see that change. And then I'm actually going to make a change where it'll actually push it off row and back into the persisted version store. If the row is too large, it'll be sent to the persisted version store, and that's where it's going to live. Let's talk about the S log. The S log is a secondary log. That's what the S is for. It is a in-memory object, and it stores linked list of log records in order of the LSNs. There's an example there in the bottom right-hand corner of the slides. The difference, though, it only contains non-version operations. So because we've introduced the concept of the persisted version store, keep in mind that SQL Server now keeps a version of the data change either in row or off row in the persisted version store. Because those versions are now kept on the data page or in the PVS itself, we really only have to keep track of certain operations in the log in order to facilitate faster rollback. The S log contains those operations. So think of those operations like lock acquisition. So SQL Server has to take locks on things in order to make modifications. Those locks can't be necessarily versioned, and so they are kept in the S log. Now, what that means is because the majority of changes that are kept in the SQL Server transaction log, the S log itself, the contents that it contains is pretty small. It doesn't have to be very, very large because the bulk of the change is actually changing the data itself within the page, right? The other beauty is that just like with your normal transaction log, when a checkpoint happens, the contents of the S log is also persisted to disk, which makes it durable, which also means that it can fail over with availability groups. So this is another component that really helps facilitate faster failover. It also helps provide really aggressive log truncation because we only have to keep the non-versioned records in the S log. And because the versioning happens on the data page itself, I actually can truncate my transaction log significantly more aggressively than without ADR. And when I get to the demo and when I get to the end, I'll actually show you the size differences between log files, and you might be really surprised in terms of what kind of log truncation, aggressive log truncation that ADR can provide. So that's the S log. There is a undocumented function. If you ever looked at the transaction log itself, there's an fn_db log function that you can actually interrogate your transaction log. If you've never done it, it's kind of interesting to go poke around sometimes. Don't do that on a production server. Do that on development, please. If you do it on a production box and something happens, you don't get to blame me. But this is a undocumented one as well. But you can see, even though it's an in-memory object, we can still interrogate that and go look at it if you want to. I don't show that in the demo, but I just wanted to point it out that you can go look at it if you want to go diving down into the S log. Okay. Aborted transaction map. I wish it was the ATM on the right that I could get free money out of, but that is unfortunately not the case. But we do have a new bitmap, and the aborted transaction map does exactly kind of what you thought it might do. it tracks all aborted transactions. So as transactions come and go, they get committed, they get rolled back, they get aborted. The ones that get aborted get written to the aborted transaction map, and SQL Server uses that information to know what to roll back and what to release. One of the things that I really think is an interesting architectural design with SQL Server is that they actually use bitmaps to facilitate faster identification of things. For example, if you didn't know it, when you do a differential backup of a SQL Server database, there is a bitmap called the diff map, DIFF, and that actually tracks the pages that have been changed in SQL Server in that database since the last full backup. And what that does is it allows SQL Server to quickly read that diff map and identify, hey, these are the pages I need to back up. I don't need to scan the entire database. If you've got a 20 terabyte database, a scan of all the pages to see what has changed would be really, really cumbersome. Instead, they have a bitmap that helps SQL Server to identify different pages that need to be backed up. In a similar sense, the aborted transaction map gives SQL Server a quick identification as to those transactions that have been aborted, and then it can go do what it needs to do. So it's very, very quickly, it's very efficient. It is a hash table. You can't query it per se. There is a DMV. The records in the aborted transaction map are linked to the persisted version store. So if we were to have a transaction and then abort it and watch it roll back, we can actually interrogate the ATM and then go see those records in the persisted version store, and actually link those together if we really wanted to. So there is a new DMV, sys.dm tran aborted transactions. So if you really want to, you can go look at that. We will look at it somewhat in the demo once I get there. Logical revert. This is kind of where the magic happens. This is part of the magic. This really facilitates the undo at the row level. And what that really means is when we have ADR enabled and we want to roll back that transaction, it gets aborted and we need to roll back. The next query that is trying to read that data, SQL Server will actually check the ATM for an aborted transaction. And if that data on the page was modified by a transaction that's marked as aborted, SQL Server will actually bypass that modification and go to the persisted version store to fetch that data. Now, some of you might be, well, that sounds like SQL Server is doing more work, and you're right. And so there is a potential for a small CPU uptick with this, but the benefit, in my opinion, the benefit outweighs that risk of any type of CPU pressure. I've never seen CPU pressure be part of the issue. Did I just lose my camera?
Yeah, it displayed a temperature warning where your
Yep.
video was. So I would maybe just turn your camera off for now.
Yeah.
Oh, that's
Yeah,
something new. Okay, I'm
we can
sorry.
hear you just fine, but it is
Yeah.
angry with how hot it is.
That's okay. Well, hang on, let me do something real
There's
quick.
just so much knowledge that the
Yeah,
camera
sorry. I'm
pumps
so
into
sorry.
you.
That's never happened before. Let me try this. I had a oh well, okay.
Otherwise,
Well,
I can turn my camera on and just act out what your
in
slides are.
interpretive dance.
Exactly. Yeah.
Well, so my camera is actually in a prompter, and so I had a shroud over it just to block out some of the outside light. But so I removed that. So I'm going to leave it on, and I'll just continue. Hope that's okay with everybody. I apologize for the technical difficulties. That's never actually happened to me before.
All good.
Okay. So logical revert. There with this because we're doing a little bit more heavy lifting with SQL Server because SQL Server has to determine what is my most current version of the data that I need to return to that query. There is a potential for a small CPU uptick in order to facilitate that. If you have a super busy transactional system, you might see a higher CPU uptick. Of course, you want to test anything. If you're going to enable ADR, obviously I would tell you to test it. It is asynchronous in nature, which is good. It does use the ATM to track what must be undone. And the other thing that this does is that as soon as we abort that transaction, every single lock that might have been taken get released immediately. Part of the problem we have today with SQL Server that a database that does not have ADR enabled with a transaction that has to be rolled back, your locks on your data doesn't get released until that rollback has been finished. So as we modify data, SQL Server takes locks to ensure ACID compliance to make sure that data doesn't change unexpectedly. Those locks stay in place until either A, SQL Server commits the transaction and the work gets flushed and hardened to the transaction log, or B, things get rolled back and the whole rollback process has to finish before those locks get released. Until those locks get released, you can't do anything to that data. With ADR, as soon as you hit rollback, immediately the locks are released, which means that we can come online significantly faster. And logical revert is one of the components that helps facilitate that. Cleaner. We always have to have a cleaner. So right now, the cleaner removes versions that are not needed. If we think about the different versions in row and off row, you can see how as data changes, we are going to have versions of the data that aren't needed anymore. Whether it's they've been aborted and they need to be cleaned up, or we've had multiple data modification queries come through, and so we have multiple versions. Why should we keep around versions that are potentially not needed? That takes up space. I know in the year of our Lord Betty White 2026, we have fantastic storage arrays like Pure that are super fast and provide us a great deal of capacity. But we should still keep in mind that keeping data that is not needed creates overhead. I tell customers all the time, if you've got a 40 terabyte database and 90% of that data isn't needed for that database, move that data somewhere else because all you're doing is causing overhead for SQL Server to manage that 40 terabytes. The cleaner here does exactly that. It cleans up the versions that are no longer needed. It is asynchronous in process. In 2019, and ADR was released in SQL Server 2019. It actually came out in Azure SQL Database first, but then it came to Box Product in 2019. It is single-threaded. So if you are running SQL Server 2019, unfortunately, you have a single-thread architecture for your cleaner, not for your database, for all databases. So if you've got 500 databases on your 2019 instance, you have a single thread to clean all 500 databases if all 500 databases are running ADR. So keep that in mind. And yes, sometimes being single threaded, the cleaner can get stuck. So it does have features in it where it'll automatically restart and so if it gets deadlocked against something else, it'll die and spin back up. You cannot disable the cleaner. So if you thought that you might be able to disable the cleaner, you could. Unfortunately, you cannot. I don't know why you would anyways. You can force a cleanup. There is a system procedure, SP persist version store cleanup. If you force it via that store procedure, it is synchronous in nature. So use it cautiously, but just know that if you run into a spot where you think that the cleaner is not keeping up or whatever, and you think that you can run it, you can go kick that off and manually run that cleaner. Thankfully, Microsoft has made some improvements on ADR over the years. 2022, they actually introduced the concept of a thread pool. So now we can take advantage of multiple pool of threads for the cleaner. Right now, it's defaulted to one thread, and that comes from the 2019 era, so it's defaulted to one thread. You can increase the number of threads, but no more than the number of logical cores. So if you thought that you could go, oh yeah, great, I'm going to assign 1,000 threads to the cleaner. Well, if you've only got 32 cores, then that's all you can do. And the guidance is to start with 1 and increase slowly over time. Do not go hog wild and go straight from 1 to 32 or 64 or however many logical cores you might have in your system. Start with 1, maybe increases to 2 or 4. Keep it kind of low, but just know that you can't, anything more than the number of logical cores, SQL Server is going to ignore. And that's the guidance. Start small, increase slowly until you find the sweet spot. 2022 also came out with some additional improvements that I wanted to mention. A user transaction cleanup. And what this does is it allows SQL Server and the cleaner to clean pages that can't be cleaned by the normal cleaner due to blocking on the ATM sweep. So when the cleaner wants to sweep the aborted transaction map to find out what versions that they can get rid of, sometimes it will get blocked because other things are writing to the ATM. So they made improvements from a process perspective to ensure that pages can be cleaned, even if the normal cleaner is being blocked on the ATM suite. It actually also decreased the memory footprint for the persisted version store. One of the things they did is that they actually now track the persisted version store pages at the extent level to help reduce memory consumption in maintaining the version pages. You can imagine if you have a big system that has multiple changes, like you're changing data quite frequently, your persisted version store could get pretty big. It's going to grow because just like everything else, and it lives in the user database, we are going to allocate pages or at 8K a piece to the persisted version store. But now we can track those at an extent level to make SQL Server more efficient to identify maintaining those version pages. So this was a performance improvement that they came out with in 2022. They also introduced a transaction level cleaner, and it allows the cleaner to clean up versions that belong to transactions that have already been committed, regardless if there are any indications in the ATM that they might have been aborted. And they finished, they're committed, they're done. It allows the cleaner to clean the persistent version store more efficiently. So again, all 3 of these were about increasing the performance of the cleaner. In 2025, they also made some improvements to ADR. The big one, TempDB can now be ADR enabled. So prior to 2025, TempDB was excluded from being able to take advantage of the accelerated database recovery. Of course, TempDB gets recreated every time that you restart SQL. But now you can enable ADR with TempDB. Here's the trick though. If you are running SQL Server 2025 and you decide to enable ADR and TempDB, keep in mind any database that is not ADR enabled but is using read committed snapshot isolation, you are now having duplicate version stores in TempDB. TempDB is going to have its own version store, but is also going to have the version store for any database that is running RCSI. If you have a multi-database SQL instance, and when I say multi, I'm talking hundreds of databases, maybe thousands, and a good majority are running RCSI, and you turn on ADR for TempDB, you might now have increased the workload of TempDB and caused some growth of TempDB that you might not have expected. So just be cautious if you turn that on and monitor. I kind of show it a little bit later, but you can monitor the persisted version store as well as the version store for read committed snapshot isolation. Just make sure that we're not causing excessive growth somewhere. Monitoring is the same as the user database. So just make sure that you monitor it effectively, that we don't cause any additional problems. ADR configurations. We can configure it to some degree. if you aren't aware, you can actually see the majority of your SQL Server configurations in a system DMV called sys.configurations. There are a couple options for accelerated database recovery in there. The first one is the ADR cleaner retry. So you can change the default value of how often SQL ADR cleaner is going to retry on a timeout. I think the default right now is 15 seconds, 15 minutes. I'm not sure. I don't remember the default entirely, but you can change that if you so desire. I have yet to run into a situation where I've had to go in there and change that timeout, so I would be very, very cautious about changing that. We had a client that was in a financial sector, super busy, bigger database, double-digit terabytes. We turned on ADR to help facilitate faster failover time in their AG. Did not adjust their clean out or their timeout, retry timeout ADR cleaner setting, and never noticed the problem. So this would be, I think, a very edge case for me to go change, um, as well as the ADR pre-allocation factor. There's a red star by it for a reason. This too, I would be very, very cautious in making this change. And what this relates to is when SQL Server, you enable ADR, we now have the persistent version stored in the user database. SQL Server is going to go ahead and pre-allocate a certain number of data pages specifically for the persistent version store. By default, I think it's 8 pages to start. I'm sorry, it's actually 64. It's going to pre-allocate that number of pages. You can change that depending on your workloads. This too would be a super edge case for me to go look at and see that this is a bottleneck and change it. However, just for transparency, I want to make sure that you all know that it is there. You can change these two values. I have yet to see a instance where I had to, but they are there. So you can go change these two values. How to enable ADR? We do require exclusive access to the database. So you can do it on a busy system. It's just an alter statement, but it's alter database name, set accelerated database recovery equals to on. One of the other cool things is that if you are in an environment where you split out things to different file groups within your SQL Server databases, you can actually put the persistent version store into a different file group if you so desire. So if you want to isolate it into its own file group, you can actually specify that and put it somewhere else. So pretty easy to enable. It does not take, just takes a exclusive lock on the database. So you do have to sneak it in. If you've got a really busy system, you might have to wait till you have a maintenance window. But it should be a quick thing to do once you get that exclusive access to the database. It should be done pretty quickly. Rollbacks. Okay, well, before I stop there, what questions are out there? I'm 35 minutes in, I think.
Yeah, so we've got one out of the chat. That was from about 8 minutes ago, so a couple slides back. It says, what is the driver for increasing the thread pool?
If you notice, I was trying to think if I should repeat the question. What's the driver for increasing the thread pool? If you notice, and you can track it, if you notice that the cleaner is not keeping up. So if I would look at increasing the thread pool, if I had many databases on a single instance that had ADR enabled. So 20, 30, 40, 50, 100, 200, 500, whatever that number might be. If the cleaner can't keep up, that's where I'm going to start looking to see, okay, by default it's 1. I'm going to move it to 2, see if that makes a difference, move it to 3. I'm not going to go from 1 to 32 immediately. So if the cleaner can't keep up, that's where I'm going to look at increasing the thread pool.
Got it. Everything else in the chat was talking about the broom the kid was holding and how you're hot. So I think you're good to go.
And I go to 245. Okay, cool. Uh, Rollback. Okay, so let's talk about rollbacks. We're going to talk about both without ADR and with ADR. This is documentation from Microsoft's online documentation, so most of us might have seen it. But in the normal non-ADR rollback, the first thing that SQL Server is going to do it's called phase one, it's called the analysis. SQL Server is going to look at the last checkpoint and do an analysis from that last checkpoint to the end of the log. Okay, so it's going to do that analysis. And then in phase two, it's going to go all the way back to the oldest uncommitted transaction. So if that transaction started 7 days ago, it's going to go back 7 days, right? And so it's going to start 7 days ago, and it's actually going to plow through the transaction log all the way up to the end of the log. And that's called the redo. And what it's doing is actually redoing all of those transactions all the way to the end of the log. And then once that's done, it's going to do what's called undo. It's going to start at the end of the log and undo or roll back anything that wasn't committed from the end of the log all the way back 7 days ago to the oldest uncommitted transaction. This is why when you have a long-running transaction in a database that is not ADR enabled and you click cancel, if it started 7 days ago, the rule of thumb is that it's going to take 1 to 1.5 times the length of the transaction. So if I have a customer who started a transaction 7 days ago, they roll it back. Ideally, it'd come online really quick, much faster. They'd have ADR enabled. But the rule of thumb is it's going to take 7 days for it to roll back or longer. Now, you might get lucky and it might come online faster, but there's nothing you can do. If you reboot SQL at this point in time, this is also what's called crash recovery. When you reboot SQL and databases start to come online, SQL Server goes through this process. It does the analysis. It'll do the redo of anything that was committed at the time of the crash or restart, and then undo anything that was not committed. So SQL Server has to go through this process every time it restarts. So if you restart SQL in the middle of this rollback, guess what? SQL Server has to start over and do the exact same thing again. Only now your database is completely in recovery and not online. That's why you don't want to restart SQL in the middle of this process. Rollbacks in this occasion are proportional to the longest running transaction. And that's usually true. Before I started this presentation, I actually started a rollback of a query that I had run for 2 hours. When I get done, we get to the demo spot, it's still going to be in the rollback phase. It won't be done. It actually won't be done for another 3 to 4 hours because I tested it. I know if I ran it for 2 hours, my rollback was about 3.5 to 4 hours, depending on things. But in your normal stance, your rollback is proportional to your longest running transaction. With ADR, things get significantly more faster. We still have phase one, so SQL Server still is going to do that analysis from the last checkpoint to the end of the log. So that really hasn't changed. But we talked about the S log and that the S log really only keeps track of non-versioned operations like lock escalations, lock acquirement. There might be some other, I know there's other operations that the S log is going to track because all the versions are stored now either on the data page or in the persisted version store. With ADR, now the phase two only has to do the redo from the S log, from the oldest committed transaction to the last checkpoint. Because remember, the S log is going to be very, very small. The number of log records in the S log is going to be very, very small. So it can read through the S log really, really quickly. And then from the last checkpoint, it'll do phase two will do the redo. So we'll go back from the oldest uncommitted transaction through the checkpoint and then do the redo of the normal transaction log from the last checkpoint to the end of the log. That last checkpoint to the end of the log should be very, very short. There should not be a ton of transactions between the last checkpoint and the end of the log. When it's done with phase two, because again, the versions are now in a different spot, they're not necessarily kept track in the transaction log itself like it was previously. We only have to do the undo from the non-versioned operations. And because that's very, very small, we can do phase three very, very quickly. And because phase three can happen very, very quickly, the locks behind the data get released. And so things come online significantly faster. So let's bring this all together. Now, this image was AI generated, but it's a good representation. I had to tweak it and tell AI what I wanted to do with it. So if we bring all the components together, on the far left, we have a transaction that comes through T1. The S log is going to capture my non-versioned changes. The versioned operations are going to be tracked in the data pages and or the persisted version store. And then we get number two on the right-hand side. We cancel that transaction, and then we have to roll that back. That transaction gets put into the aborted transaction map. SQL Server now is going to do any logical revert for any subsequent query. SQL Server is going to look at the aborted transaction map and go, oop, transaction 1234 was aborted. I now know that I need to skip any version that was stamped with transaction 1234 and get the previous value. It'll undo it logically and then undo that rollback. And then the cleaner will spin up behind the scenes and then clean up those versions. Sometimes in my demos, when I get done, we can actually go look and we can see that the cleaner has actually removed all the versions from the data pages in the persistent version store because the cleaner will spin up behind me and get things cleaned up. So all those components together give us accelerated database recovery, which means we can recover significantly faster. So with that, I got like half an hour left. So let's jump into a demo.
Sounds good, John. We've got a couple questions. This feels
Shoot.
like a good time to field those. Um, First one was with regard to the cleaner. It says, how do we know the progress and what makes it stuck so we help resume its work? Like, how do you figure out why it got stuck, basically?
Great question. I want to say there's an extended event or there's a way to track that. That's escaping me right now. Sometimes the cleaner can get deadlocked on things, and it's got a lower priority, so it's gonna be the victim of that deadlock, and it'll automatically spin back up. I would have to go. That's a great question. I'll have to go see. I can't remember the extended event right now off the top of my head. I'll have to go find that and
There's a
post it
lot of
somewhere.
them. Yeah,
Yeah.
no worries. Another one here. It says, do you see any benefit in enabling ADR for memory optimized databases? Somebody's talking about how they had an issue kind of around this.
I would be curious to know what issues they had. Depending on, I mean, memory optimized should not affect that. And ADR should not affect that either. So I'd be curious to learn more about what issues they had, but I would, of course,
Yeah,
test everything before you deploy it to production.
the brief explanation they have, it says, we had this issue with one of our databases and it offered little to no help whenever we did a failover. This is on an FCI 2019 and 2022. So the only thing that helped was to turn on trace flag 9944.
Well,
Since, oh, go
no,
ahead.
I'm just thinking, I mean, within memory, and somebody feel free to correct me. I mean, on a failover, it's going to want to consume that memory. So depending on how big that in-memory block is, your recovery time could be delayed.
Makes
I don't know
sense.
that for a fact. I would have to do some investigation on that one.
Yeah. And then since we've paused, we've gotten three, so we'll do a bit of a lightning round here.
Sure.
It says why slog is considered to be very small. What if we have many non-versioned operations?
It's going to be small because the bulk of your changes are going to be versioned operations such as changing data. With the even with like, if we think about like lock escalation in SQL Server is going to take a higher granular level lock in order to minimize memory consumption and whatnot. So instead of 5,000 small locks, it's going to take a one non-versioned lock on a table. That operation is very, very small in terms of capacity of the S log.
Makes sense. A couple more quick ones. This one, are there certain database workloads where you would advise against using ADR?
Yes, and I will talk about that after my demo.
Aha. Okay. And the last one from a young man named Anthony Yesentino.
I have met that person.
How does ADR impact backup and restore recovery times?
ADR, great question, Anthony. ADR should not impact um, ADR could impact backup times because now we have more pages in the persistent version store to be backed up. Um, Another beautiful thing, just like with failovers, is that the persistent version store is going to be included in that backup. So now we're adding pages. I would not expect it to be a significant change in terms of increasing backup times. Same thing with restore. Restore is just laying down the 8K pages, and the persistent version store is made up of 8K pages. So your restore time might be increased depending on the size of your persistent version store. But that's a great question. Great
Cool.
question.
Nothing else as of now, so keep the nerdiness rolling, sir.
Sweet. So you should see Management Studio. Yes.
Yes.
Cool. Awesome. And my camera has yet to come back on. I apologize. I don't know. I'll have to go look at that. This is the query you see before you is in a database where ADR is turned off. I had started the transaction and all I had done was insert some data into the database, and it ran just before we started the presentation. And Matt will confirm this. It had run for just over 2 hours. Just before I started, I had clicked rollback, and we are still in the rollback process, and we're at 49 minutes right now. So we can see that going right now. And we're going to let that go. It's actually going to run for probably another 3 or 4 hours, would be my guess. So while we let that go, we're going to go take a look at ADR. On the left-hand side, and what I've got here is an Azure SQL database. I'm sorry. SQL Server on an Azure VM. It is running 2025. It is relatively current. I think I might be one CU behind in terms of patching, but it's relatively current. And I've got a couple databases here. I have ADR off, ADR on, and then ADR. We're going to examine the internals with the top one, the ADR. My ADR off is where ADR is actually turned off, and then ADR on is turned on. And we'll use that database here in a little bit. So, and this is the demo script that is in the GitHub. So if you go open it up, you will see it there. I'm going to make sure that ADR is indeed turned on my database. It is. I'm going to look at some pages. I don't have a ton. I've only got one table in this database, and that table has a single row. But we can see that because SQL Server now allocates uniformed extents automatically, I have 8 pages. I have an index allocation map, which keeps track of all my data pages, and I have a single data page that has data on it, and the data page ID is 352. We're going to use 352 throughout the rest of the demo. So keep that number in the back of your brain because it's going to come up quite a bit. So 352 is the number that we want. As I said, the table is pretty simple. I have 3 columns, an ID, a first name, and a last name. And right now they're populated with my name, so John Morehouse. And we're going to make some changes, and we're going to see how SQL Server handles it. If you're not familiar, you can look at the contents of a data page using DBC Page. You do have to enable trace flag 3604. 3604 is not destructive. All it does is tell the subsequent DBCC command to display it to Management Studio and not the error log. If I were to run this without that trace flag on, when I were to look at the page of or a data page within the database, the output of that command would just be written to the management log, which would be very, very cumbersome. So let's take a look at it without any changes, right? If you've never seen what the data page looks like, there is a structure to it. It has a header. The header has a certain size and it contains certain information. For example, you can see what kind of page it is. This is a data page. I have a slot count, which is a row count. So I have one row in this table. If you've ever heard of ghost record cleanup, I don't have any ghost records on this page to be cleaned up by the cleaner. The header gives us some really good information. It tells me what object it's allocated to. And it also tells me my different bitmaps. So my GAM, my SGAM, this is my diff map. We can see that it's changed. So SQL Server, if I were to do a differential backup, SQL Server can quickly identify that page 352 was changed and we have to back it up. We also have record attributes. This area will become important as we move through this. So pay attention to this part of the header. The record attributes will tell us where the null bitmap lives. We have variable columns because I've got string data within the table. We also can see my actual data. So these are the various offsets on the left-hand side of where my data lives. If you were paying attention to Andy's presentation earlier, he had talked about offsets being the IO size times the size of the page, and you can figure out the offsets. This stuff is the actual hexadecimal of the contents of the row. Now, the row itself has header information about it. So the header information about the row will tell me how many variable length columns do I have? How many columns in my row are null? And where do they live in terms of on disk? How many fixed width columns do I have? A whole slew of different things. So we know that is the header of the row, but we also know if we were to reverse engineer some of this, I know that 4D right here is the word Morehouse. I know that 4A, 6F, 6.8, and 6E is my first name, John. So I know that this matches, right? So Morehouse is the last several bytes of the row on this data page. If we scroll down a little further, we can see slot 0, there's my ID column, there's my first name, there's my last name. This all looks hunky-dory. This is the way it should look. It is all great. So if I come back and say, okay, I want to start changing data. So I'm going to do a checkpoint. I'm going to start a transaction. I'm going to update the table and set the first name to Duke. Duke is the name of my father. I lost him 5 years ago to COVID. So I say his name here because then it's recorded and his name will live on for as long as the recording lives on. So I changed the first name of the row from John to my dad, Duke. And so the transaction's still active. I haven't committed it. I haven't rolled it back. So let's go take a look at the page. Now remember, if the change is small enough, it should be in row. If it's bigger than what the contents are, and the guidance I saw was about 200 bits or bytes, I don't remember, but I think 200 is stuck in my memory. If it's bigger than that, then it'll push to the persistent version store. But if I scroll down, same thing, same header, right? So I still get all this goody information. I see that I still have one row. I don't have any ghost record cleanups. If I scroll down a little bit, we will notice this has certainly changed. It has versions. And my record attributes has now changed. So now SQL Server on the page header has identified that I have versions on this page, and those versions are probably either in row or in the persistent version store. this all looks normal, right? So we have our offsets. Here is the row header has changed slightly, but quite quickly you can see here is the value that I set it to. There's Duke Morehouse, and then here is the previous value of John. So the change was small enough, and so it wrote it in row. And we can correlate that because we know that this hexadecimal, if we reverse engineer this, is going to be John. The other thing that we will notice is that we have this little wonderful block of information that it tells us some of the versioning information. One of the important key points of how SQL Server keeps track of this is this transaction timestamp. And this information is actually tracked right here. If I were to reverse engineer this, I know that 002 behind Morehouse, right? So if I go look at, this is the end of Morehouse, right? So this is page 1. And I know if you're familiar with big endians and little endians in terms of how data gets written to disk, SQL Server in some cases uses little endians. It's byte reversed. And so if we reverse this, this is the page. So I know that this is page 1, 0001. And so that is the page. The file is the other part in the slot. So the file is 0302. The current slot ID, I think, is this part. And the timestamp, actually, timestamp was at the end, is 06F3. And we can prove that. So if we reverse engineer hexadecimal 06F3, we get 1779. If we go back, oh, look, 1779. So right in the row, in the hexadecimal, SQL Server is keeping track as to where my versions live. Now, I will tell you that you'll notice that this says tempdb. I haven't quite figured out why it says tempdb because it's living in the row. I will also tell you that this file ID of 770 is directly proportional to the size of the data of the version. So if I were to have a bigger first name, such as if I change it to Monica, because Monica's name has 6 characters versus 4, the file ID in this value will actually jump to 828. It actually will jump up. I have yet to figure out, I've spent most of this week trying to reverse engineer what this file ID actually pointed to, and I was not able to get it. And we can scroll down and we can actually see, okay, there's my version, but my current value is still Duke. So, and remember, this transaction hasn't been committed yet. So I haven't rolled it back. I haven't committed it. So it is still sitting there. If a query comes along and says, hey, I want to get the latest version, because it hasn't been committed yet, it'll get John. It'll return that value. Well, okay, so that's hunky-dory. What happens if we change more data? But first, let's look at, this is the index physical stats. This DMV tells us some information. We can see quickly that we have one page, we have one record count, we have one version record. We also have one in-row version count. We know the payload size is 24 bytes. We don't have any off-row versions, so they haven't been pushed. We haven't made a change big enough yet to push it to the persistent version store. So let's go make another change. I can't remember if there's anything that's gonna be in here or not. Yeah, we'll come back to that. So within the same transaction, now I'm going to change the first name from Duke to Pete. Uncle Pete was my dad's brother. I actually lost him 2 months before I lost my dad to COVID. So again, I say his name here, Pete Morehouse, just with Duke Morehouse. Therefore, it's recorded and it'll live on in infamy. So if I change the name to Pete, I change that, and let's go look at the page. All looks normal. We still have the same, haven't changed the row count Still no ghost record cleanups. Same object, same versions, still has versioning info, but what does it actually contain? Well, I've made a change that is big enough, so it actually pushed my change, my previous values, to the persisted version store. We know that because it's not actually physically here on the page. We can see Pete. We know that this is the end of Morehouse. That's Pete, and this is Morehouse. So I know now that well, I haven't proved it yet, but I will, that my version now lives in the persisted version store. It's no longer on the page. And we can reverse engineer that. And this tells you right now that version is in the persisted version store. What's also interesting is that we can, just like before, if this is the timestamp. This is the page. I'm sorry, the file. And if we were to reverse engineer this, I believe that is the page 632. So 00. Nope. Nope. I had to go back and look. Anyway, this value is indeed in here in the hex. I would have to go look and see where it's at. But we can go look at that page. So if we scroll down further, yep, Uncle Pete in the last name, nothing else has changed, but we can see that my current version is Pete in the on the page, but I haven't committed anything. So let's go look at the index physical stats of the table again. We should expect some things to change. We still have a single page, single record. We do have a versioned record count, but you'll notice that the in-row number has decreased to 0 because I've now pushed it to the persisted version store. And SQL Server confirms that because we now have an off-row record count. So somewhere in the persisted version store, that record lives. Because the version store has pages allocated, we can actually track that. And if you happen to notice, if we go back and look at the timestamp, what was the timestamp? Anybody remember? 1779. If we look at this DMV, persisted, what is it? Tran persist version store, we can interrogate the version store, and we will see that we actually have a row that matches our 1779. So we know now that in the version store, we have a record that is being tracked by this ID value, right? So that's a transaction ID of some nature that is used in the version store. We can also see that here's the hexadecimal of the row version. If we wanted to, we could probably reverse engineer that, but I'm not going to. So now we've proved that, yes, your versions will live on the page itself if it is small enough, or if the change is big enough, it'll push it to the version store. So with that, I'm going to roll that back because we're not done yet. I'm going to start a extended event session where we can now track some activity with the persisted version store. So let's do it again. So I'm going to start a transaction. I'm going to get the current transaction ID. I'm going to copy that. And they never say type in a demo, but I'm going to anyways, because I like to live on the edge. I'm going to go ahead and skip because I want to identify version store activity. I want to skip doing the in-row version bit of this and go directly to, I want to push it off row. And now we see extended events has now captured some of this data. So we can actually go interrogate the version store because because we're curious, we want to go actually verify that this thing lives in the version store. If we look at this extended event, and I make this a little bit bigger, a couple things get correlated. One, we can see our text, right? So we know that we updated the first name to Duke and then updated it to Pete right behind it. It is the version store right here. We added a primary record to this row ID. A RID is a row lookup pretty much, so there's no heap. I'm sorry, there's no clustered index. And we see that it's file ID 1 and page 632. If you remember, 632 was the page ID that was found in the hexadecimal of the page of my version. So that is now linked to the version store. We also can see that this is the same transaction ID that we identified when I started this query. Now, can I go see that actual page? Yes, we can. So I can actually go interrogate that persisted version store page and look at it and go, oh, hello, there are my previous values. Because remember, Uncle Pete is the current value on the page. I haven't committed it yet, but my previous values, Duke and John, now live in the version store, and we confirmed it. So we can actually look at the persisted version store page itself and verify that this data is accurate. Now, would you do this in a real world situation? Probably not. But understanding how ADR works with your different versions allows you to make better decisions in terms of like, do you want to enable it? Do you want to use it? I usually recommend all my clients to turn it on, unless you have an edge case. But now we can see that, yep, it lives in the version store. And if we were to do some more interrogation, we can see and ensure that that page lives in the persistent version store. It has in-row data. Yep, its ID is 632, and it is indeed a data page. So that all jives together. Oh, I already did that. We can do some more interrogation in terms of looking at the various transactions. You can do some further investigation on like tracking all these transactions put together. I just showing you these, just let you know that you can go look at that information. And you can see it here too, right? We can see where he actually added a record to the persistent version store. Now, what does I don't think there's anything else in here we've already looked at. Yep, we still have an off row. That all looks right. So I'm going to roll that back. But what does that really buy us? Now you're probably going like, oh, this is all great, John. Like, show me the real magic. Okay, so here's the real magic. We all agree that this transaction ran for 2 hours prior without ADR, and it's still rolling back. An hour and 9 minutes later, we're still waiting for that rollback. I ran the exact same query on a database that had ADR enabled. In a transaction, it ran for an hour and 3 minutes. With a normal rollback, we would expect this thing to come online 3-4 hours from now. If I roll this back, I'm done in less than a second. My database is online. It is functional. I can do whatever I want to it. I am still waiting, and I have to wait for this thing to finish before I can, like, I could destroy the VM, but I'm going to wait. So that's the magic. Because we're using the persisted version store and we're storing versions now in a different spot, with the introduction with the logical revert, the slog, the cleaner, we now can roll back and release the locks on data significantly faster and come online significantly faster. Now, take this with availability groups. Because SQL Server has to go through that crash recovery, even on failover, this also applies when you bring a database online in a failover. So SQL Server is going to bring that database online most of the time significantly faster because ADR, we don't have to worry about redoing all the locks. We just have to replay the locks from the slog or whatever the non-version operations in the slog. The other thing I want to show you is, and to prove this, so this is the data file for both databases. Here is the one that's turned off, and this is the one that's turned on. So I inserted about the same amount of data, 239 gigs worth of data is the amount of data. Because when I started this, both databases were about 8 or 10 megs in size, right? So it's a default database or blank database that I created, and I inserted a bunch of data. Now, I mentioned aggressive log truncation at one point. Check this out. This is the transaction log when it was done after 2 hours. This is the transaction log after it was done. If that's not startling, that's the difference, and that's the aggressive log truncation that SQL Server can now do with ADR. And you might not have to worry about that excessive log bloat because you don't have to worry about it because SQL Server has to keep track of all those operations and the transaction log of ADR is not enabled. And SQL Server cannot truncate that log file until that transaction is either committed or rolled back and or a log backup happens, right? With ADR, we get significant savings in the transaction log size because we can do that aggressive log truncation. That right there, I think is mind-blowing. So with that, I'm going to flip back to slides real quick. And we're going to wrap up, and I'm going to wrap up almost right on time. When not to deploy ADR. If you have a system that is super smoking, highly transactional, and I mean busy, I'd be very cautious to enable ADR. I would want to test it very, very thoroughly because if you think about it with the persisted version store and the versioning on the data page, you are going to introduce some level of extraneous bloat because we're storing more data on the pages and or in the database. It also would probably affect your cleaner operations. So if you are extremely highly transactional, um, I would be very, very cautious to enable ADR. If you have a high volume of data modifications, that obviously is also going to take a toll. Every client that I usually interact with, I advise them to turn on ADR because the benefits outweigh the risk. Of course, there are going to be edge cases. Do your due diligence, test it effectively, make sure everybody is comfortable with the feature before you turn it on in production. But it's really, really cool when you have a huge transaction and something happens and you have to fail over and the database comes online very, very quickly without having to go to your CIO, CTO, CEO and go, we're stuck for 7 hours because Billy Bob from accounting ran a transaction for 7 hours and we have to wait for that thing to roll back. Monitor, of course, if you are in that situation where you're highly transactional, make sure you monitor things effectively for issues. If you have transactional or snapshot replication and or CDC enabled, unfortunately, that's the one thing that will disable the aggressive log truncation. You still get the advantage of ADR, but you're not going to get that really nice disk space savings from the aggressive log truncation that you would if you turn this on. And that does make sense because of the way that replication and CDC work. It's going to have to keep some of that records in the log file in order to actually replicate to, or at least scrape the log file and do what it needs to do, especially with CDC. So a quick summary, and I think I'm right on time. Ooh, I'm right on time. We get faster rollbacks, which is fantastic. We get faster crash recovery upon startup and failover. And as a diehard operational DBA, this is one of the biggest things. And again, this is one of the reasons I think that this is one of those features that is a game changer for SQL Server DBAs because it makes my life easier. And honestly, it's all about me. I get the aggressive log truncation out of it. I showed you that where the log truncation was significantly smaller than what was with the non-ADR enabled database. We're talking 80 gigs versus 4. That's a huge, huge savings. Enable it for a majority of your use cases. Really simple to enable. It's just an altered database statement. There is one article that out on Redgate that has further information about ADR and how does it work. Fantastic article. I do another session where I actually open up the debugger and we start to break apart the call stack of the persistent version store. I unfortunately didn't have time to do it here. But there's information about the call stack resolver. And then the white paper that I posted earlier is there at the bottom. Questions, answers.
Yeah, so we've got I'll go in chronological order. We've got a few, and I don't want to take up the whole break. You just talked for 75 minutes.
Oh, you're good. You're good.
So we've got one It basically says enabling ADR will increase database size. That's a question. And what would be the best way to evaluate this impact?
Great question. So ADR by nature isn't going to necessarily, it all depends on your rate of data change, right? So if you have a highly volatile system where you're changing data very, very quickly and very, very often, you will most likely see some bloat of your database size. It should not be significant per se. I would monitor it like you monitor your database sizes today, because we're all monitoring things effectively today, correct?
Of course.
Because the cleaner will come around and clean things out. So there's a balancing act that SQL Server has to do between the cleaner and keeping versions in where they need to be. So hopefully the cleaner is, and if I went back to my demo, well, I rolled back. If I'd committed stuff, the versions would be gone anyways. Um, so certainly enable it, but just monitor that your database size effectively, and then monitor individually your persistent version store within that database.
Gotcha. Okay. And then we've got a few from Slack here. So again, chronological order. It says when you enable RCSI, TempDB can get hit pretty hard. Have you seen any performance impact to highly concurrent workloads running under ADR?
Yes, TempDB will get hammered with RCSI because every database using RCSI is going to use that version store in TempDB.
Right.
With ADR, you're going to see some utilization of the persisted version store. But one of the beautiful things is because that version store comes out of TempDB into the user database, enabling ADR will actually help offload some of that RCSI work to your user database and remove it from TempDB. So you can actually reduce your contention of TempDB by enabling ADR because now it's going to use the version store in the user database.
Gotcha.
It's obviously going to have, you could have some contention, but again, test it effectively in production.
All right. Yes, always test.
Test.
Next one. Do you know whether ADR's persistent version store benefits from page compression on the underlying table? In other words, if a table is page compressed, are its row versions of PBS compressed as well, or is PBS storage independent of the table's compression setting? That's a deep cut there.
That is a deep cut. That's a great question. Nobody's actually ever asked me that question. Compression should not affect ADR. I would assume that the compression or vice versa, meaning compression is going to affect ADR or vice versa.
Right.
The data on the page is going to be compressed whether it's ADR or not. Because once we get to the page level, it's all bits and bytes and hexadecimal, right? So if SQL Server's compressed it, then it's going to be compressed pretty much everywhere.
Yeah, makes sense. Couple more here. What happens if the change is small, but the page doesn't have room for storing the versioning information? A page split? And then there was some additional discussion on that, but that's the main.
Great question. So a page is fixed at 8K, 8,192 bytes. So if there is not room on the page, things will have to get shuffled around. And that's one of the reasons, one of the things that I think Microsoft did with when they started to architect SQL Server is that they actually left room on the page for certain operations. For example, the 14-byte pointer for recommitted snapshot isolation, it has to have room for that 14-byte pointer somewhere if you turn on RCSI. That has to live on that row. And so there is extra room on the page, not a lot, but there's extra room on the page that SQL Server has that the architects of the product can put things. But that doesn't, I mean, I'm just saying that there's room on the page, but if there's no room, it's got to move somewhere. My assumption is that if it's totally jam-packed, you got a fill factor of 100, it might have to push it to the version store.
Okay. And then last question. If you have both turned on, does RCSI live in the ADR version store in the DB instead of TempDB?
Correct.
So it does.
It does. Yep. Yeah. If you have a database with RCSI enabled and it's using the version store in TempDB, you enable ADR, that version store will actually move down to the user database, and both ADR and RCSI will use that persistent version store.
Got it. We just got a late breaking one. It says, can we turn ADR on and off whenever we need it, like when running long running transactions?
Technically, yes. but you do have to get an exclusive lock on the database to facilitate that. I don't know why you would want to do that.
Yeah, there was some discussion earlier where, especially in a busy environment, even in maintenance windows, it's really hard to get an exclusive lock.
I
So
I would not want to flip flop back and forth like that. But technically, yes, you could. I mean, it's just an alter database statement. So yes, you technically could do it.
yeah, that is all the questions. The only other discussion was around that this should have a cooler name.
Should it have? I think it's cool myself. And again, I find this stuff really interesting and like how it all works. But ADR, I mean, it does accelerate the recovery of the database. So it's pretty much the way it says.
If you're worried about long transactions, exploring your transaction log, just switch it to simple mode and then run
You
your
are
transactions.
fired.
Solved.
You are fired.
Hey, he's just solving problems.
I'm thinking outside the box. John, that was awesome. Thank you so much.
Oh, my camera might be back.
It's
Oh.
different.
As it cooled down, you put some bag of frozen peas on top of it.
Oh, that's what I should do. Oh, yay! It came back. Oh, wait. Why can't you see me?
Yeah. So you should do
No.
what every bit of electronics likes. Pour some cold water on it. That's going to fix it quickly. Yeah. Pro tip.
Right, can I grab the screen there, please, John?
Oh, yes, sir, you can. I know why. Hang on. Yay! Well, ceiling fan.
You're back.
So sorry about the technical glitch with my camera. I've never had that happen before.
I'm just glad I didn't have to interpretively dance my way through ADR.
As glitches go, that's absolutely fine. If you lost your sound, then there's an issue. But losing the video, it's not the worst in the world, is it? So,
Hopefully the sound was okay.
sound was great.
All
Yeah,
right, good.
absolutely.
Yeah.
So everyone, please do leave some feedback for John.
Yes.
EightKB.online/feedback.
Yep, I love feedback.
Make it constructive. I wanted some feedback saying at the stage I was almost too squeaky. So you're like,
I've had that one.
no.
I'm in is kind of warm. Can I leave John that feedback? Can he fix that in my house?
I could, but your wife probably won't like it because I'll make it really, really cold.
Also, lunch wasn't great, so
I have not eaten lunch yet.
Oh man.
All right, we've got a bunch of resources for that, and I will put all of these into the Slack channel. And of course, we have our bonfire store where you can not only now buy t-shirts, you can also buy
handkerchiefs.
Are we going to call them limited edition like we do the other t-shirts, or are they just going to be there forever now? 8KB bandanas. Never say this conference does not listen to attendee feedback. You asked for it, you got it. They are there. White only for now, but we will let you know as soon as the black ones come back into stock. Anyway, up next, last but by no means least, we have Edwin. Edwin, are you on the line? I pressed the promote button, but
Yes, I am on the line, and hopefully you guys can see me.
Yes,
we go.
See you. How you doing?
Right. Cool. You may see like 2 entries on the Zoom. Zoom link.
Yeah, we were sort of our plan of not giving speakers actual speaker links and just promoting them through the Zoom session. Mark, we're not going to do that again. It's been before every session. We're scrolling through all the attendees going, well, that could be him, but are we just going to promote some random attendee who's going to pop in and go, hello, everyone?
So does that mean there's an Edwin and a shadow Edwin in the Slack or in the chat or something?
Hi, Reed.
Does shadow Edwin have like a mustache so that we know which one's the bad Edwin?
Is that like
no?
Juan Morcasa?
Yeah, like
right.
like
I
Don
will stop
Morcasa,
sharing.
Yeah.
There we go. No, usually I would have my phone as my my monitor, so I can watch myself. Because when you're running like multiple monitors, it it's a little bit confusing which one to look at. So in my case, I force myself to look at the camera whenever I'm doing presentations online. And the way I do that is by putting my phone that's running Zoom just right below the camera. Kind of like an idiot board for some of the people who are in film. Good afternoon, everyone. Or late night, good evening. Hopefully you can all hear me. How's my audio going through, by the way?
You sound good.
Okay. I forgot. I didn't realize there was a setting on Zoom that says, like, sound for musicians, specifically. I never knew that existed. And so
Neither did I. Where's that?
Yeah, I didn't know that either.
One of the clustering MVPs told me about it. He's a guitar player, of course. Audio settings, right down below, like microphone modes. Under that, original sound for musicians, and then high fidelity music mode, echo cancellation, and stereo audio.
Oh yeah.
Yes.
Not only technical content, but we get Zoom tips as well. This is just the best conference.
And I only found out last week. So I've been using Zoom for quite a while, but I only found out last week. There it is.
Okay, so we've got 2 minutes to go. Do you want to share your screen?
Oh, this is my screen. So here is, I don't know, maybe I should test. I should test how it should work, like, something like this. Screen. And then my...
Gonna be interesting. How
my demo, if that works. So far, I've done, like if I'm switching back and forth between my slide deck, this and that, sometimes it works, sometimes it doesn't. Totally up to you. I can share my screen, but then I like multiple screens, so which one am I supposed to be sharing?
Yes, please share the screen, because we have everyone in like a gallery view, and so I'm not sure how to change it to get you just to show you on the screen.
Gotcha. Let me see. I will share.
Is there a way of doing that?
Let me do this instead. Let's see. Give me a quick second.
No worries.
Instead, I will use this. I have to stop this. Come on. There we go. Nope, not that one. This. Really? It says failed to start the camera. Let me get back. A quick second. Close that. And
Mark, you're a residential Zoom expert. Nope, come back.
and then he's gone.
What?
All right. So
hang on, we might have
there
a
we
technical question. Oh, here we go.
And then let me share my screen, my entire screen. But before I do that, I want to make sure that I'm not sharing anything unnecessary. Well, it happens. Alrighty. Share screen. Okay. Share. Screen 2. There we go.
Yes, we can see your slides.
Okay. What about this one?
Excellent. Yes, we can see Failover Cluster Manager.
Gotcha. That and this. Cool.
And you're back. So you are sorted. Fantastic stuff. Okay.
For now.
It is.
No.
It is. Oh no! Happy thoughts. Happy thoughts. Okay. It is top of the hour. So Edward, the floor is yours.
All right. Thank you so much. Really appreciate the opportunity, and hope you can hear me well. Really appreciate the opportunity to be a part of EightKB. Man, back in 2020, I was watching some of the recordings from way back when, and I try to keep up as much as I can and watch all of the previous videos. This is all about availability groups and failover clustering internals. Bit of a caveat. A lot of the things that I'm going to be talking about are no longer in the documentation, but they're still supported. I wish Microsoft would bring back the documentation and keep them up to date as far as the failover cluster internals are concerned. Contact information, blog, email, X, LinkedIn, YouTube. Let's get on with it. I want to emphasize that SQL Server actually does not have its own, let me move my Zoom thing out of there. Oops. SQL Server does not actually have its own high availability capabilities. It leverages always on, it's leveraging failover clustering as far as high availability is concerned. And again, whether we're talking about failover clustered instances or availability groups, they're practically the same. And I want to start off by sharing the fact that I love to fly. When I was a kid, I really wanted to be a pilot. Unfortunately, my dad did not like the idea. Worked and retired with United Airlines, told me to never ever work in the airline industry. My thinking was, I have no intentions of working in the airline industry. I just wanted to fly. And so years later, I decided, hey, why don't I take a shot at it? Scheduled my very first introductory flight, got on a plane. My flight instructor was like, go ahead, take over the wheel or the control, not the wheel. It was fun. It was really fun to a point where I'm actually now working my way towards earning my private pilot's license. But here's the thing. The one thing that I learned during that hour-long introductory flight, the most important thing in flying has nothing to do with flying. Mind blown. What do I mean by that? The most important skill, and it doesn't matter how good of a pilot you are. It doesn't matter how recent your license is. The most important thing that I learned during that 1 hour introductory flight was the importance of communication. Everything that happens between pilots in the airport, that is, has a lot to do with the communication between the pilot and the air traffic control. In fact, this spells the difference between having an amazing time flying versus not making it back home. This was a clip from a tragic incident that happened at the LaGuardia Airport earlier this year, where an Air Canada flight hit a fire truck. Yeah, it's kind of... I got this clip off of Reddit, but again, it's a reminder that miscommunication could tragically end lives. Okay, and that's why I said the most important skill, the most important lesson that I learned while I was on that plane is the importance of how communication is when it comes to flying. I want to ask this question: how many of you here have had issues, outages, disasters when it comes to communication? What I mean by that is, how many of you have had outages with your databases in an availability group or databases running on a failover cluster that had something to do with communication issues? I'm pretty sure I'm not the only one who had that issue. Or better yet, maybe I should reframe the question. Who here has experienced outages due to miscommunication issues, especially in large organizations where you have segregation of duties and the DBA teams not coordinating with the VM admin team or the storage team or the networking team or the sysadmin team? But here's the thing though. I kept emphasizing about how important communication is because SQL Server in and of itself relies on another platform for high availability, and that is the Windows Server Failover Cluster. SQL Server leverages and piggybacks on the capability of the Windows Server Failover Cluster for high availability, fault detection, automatic failover. But in order for SQL Server to be able to do that, it has to communicate properly with the Windows Server Failover Cluster. Okay? And that's why we're going to dive into the internals, how important the internals is when it comes to troubleshooting and monitoring always-on availability groups, because your availability groups run on top of a Windows Server Failover Cluster. of course, I'm going to put a caveat there, highly available availability groups. Because when Microsoft introduced SQL Server 2017 with read scale availability groups, that is not highly available. And again, it's the confusion between, well, it has availability groups in the name, so it might be highly available. But again, just making sure that we set the expectations that highly available availability groups depend so much on cluster resource manager in the case of Windows, because SQL Server has been running on Windows for decades before SQL Server on Linux was introduced. Now we have a cluster resource manager outside of Windows. Okay, and an understanding of the internals, failover cluster internals, is very, very important in the context of managing, administration of, and troubleshooting of availability in outage situations. Okay, I did mention this is one of those things where I wish they did not call this. I'm just moving my my Zoom controls. I wish they didn't call it availability groups. I wish they called it something else, right? Because prior to SQL Server 2017, you cannot even check this box, the enable always on availability group checkbox. Now, Microsoft did a really great job making life easy for people working with their products. This, for most people, might seem like an ordinary checkbox. It is not. And this is where I will start to dive deep into how important this checkbox is to keep your SQL Server databases highly available. Let's start with the cluster service. So what is the cluster service? Every node in your failover cluster runs an instance of the cluster service. Think of this as the engine. It's like when you open up the hood of your car, this is the engine, and within the engine there are different components that make the engine work. As a mechanic or as an administrator or as a DBA, you need to really understand how these things work. The challenge, of course, with a large organization where you have segregation of duties, it's kind of challenging because sometimes as a DBA, you do not have visibility over what's happening inside a failover cluster, despite the fact that your job now relies so much on a failover cluster. Okay, so when you add or rather when you turn on the failover clustering feature, it creates the cluster service, but it doesn't run it until you build your Windows Server failover cluster. So let's have a look at some of the components inside this engine. The first one is the database manager. Think of this like SQL Server, where you're storing data, you're retrieving data, you want to keep the data consistent. Of course, it doesn't function like a relational database, or it is not the same as a relational database, but it functions similar to a relational database. It stores data in key value pairs, and this is stored on every single node in your failover cluster. There are two locations for this. The first one is the cluster registry hive, or the Windows registry. Okay. The second one, and I put an asterisk there, is in the file system. When you deploy a Windows Server failover cluster with a disk witness or witness disk, a copy of the cluster database also gets created in the file system. What does the database manager do? Well, just like SQL Server, your database manager is kind of like the engine, and then the cluster database is kind of like your MDF file. Any change you make to the failover cluster, I'll create a cluster, I'll add a node, I will create an AG, I'll add a replica to an AG, I will switch the AG from automatic to manual. All that information is stored inside the cluster database in addition to storing that information inside SQL Server. Okay. The second one is the node manager. From the name itself, it manages the nodes. This is responsible for keeping track of the health of every node in the failover cluster. It sends heartbeat messages, and if the node does not receive any message or heartbeat message from any of the nodes, it sends a multicast message so that the other nodes can respond back and say, hey, we're all okay. Maybe that guy is the only person not okay, or node. It also takes responsibility for membership, kind of like a gatekeeper. We're adding a new node, we're evicting a new node, right? Then the other component is the failover manager. From the name itself, it takes care of resources, the resource groups, the state, and if they're not healthy, trigger a failover. Moving that resource from node A to node B is an example. And these three talk to each other. Like for instance, you add a replica to an AAG. The node manager picks it up and say, hey, this guy is now a member of the availability group. I want you, database manager, to write that information onto the cluster database. The node manager also talks to the failover manager and says, hey, that replica over there, or that node over there, we can fail over to that node because it's now a possible owner. I'm using terminologies here that are specific to failover clustering. And so they're talking to each other. Failover manager also communicates back to the database manager. Let's say, for instance, hey, I moved this resource from node A to node B. I'm now the primary. Make sure that that's recorded in the database manager or in the database cluster database. Okay. There's another component called the global update manager, and I kind of look at or think of the global update manager as your good old telephone switchboard operators. I did a presentation last year at the PASS Summit on tour in the Netherlands, and people were like, I remember that. Tells us so much about how old the people were. The global update manager is kind of like the telephone switchboard operator. If you make an international long distance phone call back then, you would have to call the operator, and the operator will then patch you in to redirect your call to your destination. That's the job of the global update manager. Every copy of the cluster database on every single node needs to be updated. So the changes have to be passed on to the global update manager for it to send over to the other node in the failover cluster, where its corresponding copy of the global update manager receives it and then passes that information back to any of the components. If that happens to be, hey, we need to update this record in the cluster database, then the global update manager will pass that information back to the database manager and stores it in the cluster database. There are other components here like the checkpoint manager, the membership manager, the resource control manager. There's more to it than this. Checkpoint manager is no different from how a checkpoint process works inside SQL Server. Membership manager is, oh, and by the way, because of the fact that this is guaranteeing that every change you make in the failover cluster has to be replicated across the nodes. So it not only has to be persisted on the local copy of the cluster database, it also has to be persisted on the remote copies of the cluster database. Think of it like a distributed database, right? And then your membership manager, in coordination with the node manager, coordinates whether, hey, this member is misbehaving. Maybe we need to, quarantine that node. And then the resource control manager, from the name itself, it takes care of managing and controlling the resources. I did say some of this, a lot of this information is no longer available on the Microsoft website. I grabbed much of this information from the good old Windows 2000 server distributed enterprise distributed systems. In modern versions of Windows, the resource control manager actually now takes over the functionality of the failover manager. In fact, the failover manager is now a subset component of the resource control manager. The reason I'm highlighting all of these things and the components because it will start to make sense later when we look at the cluster error log. Let's move forward. All of these components are accessed by cluster API, and your cluster API is what you use when you're running failover cluster management console, you're running failover clustering PowerShell commandlets, SQL Server, when you're interacting with a failover cluster, like in the case of a failover clustered instance or availability groups. And I'm going to pop that cluster resource DLL right there because it's part of it. Even your monitoring tools are taking advantage of cluster API. So anytime you're doing something in your availability group, it's using this cluster resource DLL, talking to the cluster API, and coordinating the messaging between what SQL Server knows and what the failover cluster needs to know. Moving on, we have another component within the nodes or within the cluster called the resource monitor. Your cluster service talks to the resource monitor, and the resource monitor hosts cluster-aware applications. I did pop in that cluster resource DLL specifically for availability groups. But what's happening is that your cluster resource DLL for your cluster-aware applications run within the process space of the resource monitor. Okay, let's zoom in on that resource monitor. What's actually happening within the context of the resource monitor? Cluster-aware applications like SQL Server, Exchange, or Storage Spaces Direct, they have their own cluster-aware or cluster resource DLLs. In the context of SQL Server, that's SQSRV res.dll for the longest time, because failover clustered instance has been around since SQL Server 7. And then HADR res.dll for availability groups. Of course, with SQL Server agent running on a failover clustered instance that has its own cluster resource DLL. There are generic cluster resource DLLs like for shared disks and listener name and virtual IP addresses. You have your cluster res.dll and others. As more features are introduced within Windows Server failover clustering, more generic resource DLLs are introduced. In the context of SQL Server, the resource monitor runs the cluster resource DLL specific to that workload. In our case, in this case, it's SQL Server, so it's HADR res.dll. I kind of think of the cluster resource DLL for SQL Server kind of like an interpreter. SQL Server speaks a different language, the availability or the failover cluster speaks a different language, but they need to understand each other. And so the cluster resource DLL functions like an interpreter. This is where two checks that the cluster resource DLL need to implement. An application can only be considered a cluster-aware application if it implements these two checks for the cluster resource DLL, the looks alive and is alive. Of course, with names like looks alive and is alive, it's kind of self-explanatory. Looks alive, it checks for SQL Server service every 5 seconds, and then if the looks alive check is or fails, this is where the is alive checks. By the way, these are how it looked like prior to SQL Server 2012. Because your failover clustered instance runs in the context of Windows Server failover clustering, your SQL Server service is controlled by this Windows Server failover cluster. The looks alive check needs to validate whether the service is up and running, right? With the is alive check, well, just because the service is running doesn't mean the whole instance is functioning well. Now, starting with SQL Server 2012, Microsoft came up with something specific to availability groups. Because keep in mind, your availability groups do not have the SQL Server service running in the context of the failover cluster. Right? Standalone instances, the SQL Server service runs outside of the process space of the cluster. And so in order for a SQL Server to coordinate and communicate properly with the failover cluster, Microsoft implemented the HADR res.dll, and the way it implemented the looks alive checks and the is alive checks have to be more specific to availability groups. Okay? This is where the context of having SP server diagnostics, which captures information and data, but of course, the results of which only us in SQL Server understands. But that information needs to be passed back to the failover cluster. And in order for the failover cluster to really understand what that means, that's where HADR res.dll comes in and interprets that data, passes it back to the cluster so that it knows, based on the information, what kind of decision does it need to do, or what kinds of action that you need to do. Okay. Then you have your failure condition level, which determines what constitutes a trigger for the failover cluster to decide to move an availability group to one node versus just keeping it there. And of course, health check timeout. The HADR res.dll runs SP server diagnostics within the context of the health check timeout value, and if it does not return back within, by default, 30 seconds, then the failover cluster takes that information and says, hey, this guy's not healthy, let's move it to a different node. Because availability groups do not have the SQL Server service running in the context of the cluster service process space, it needs to implement its own version of the looks alive check. For an availability group, that's the least timeout. It's kind of like the failover cluster checking, hey, are you fine? Are you healthy? And it's not just looking at the SQL Server service, because the SQL Server service, again, does not exist in the process space of the failover cluster. So the least timeout is the looks alive check version of how the failover cluster would know if the SQL Server instance is up and running. So let's put it all together. You got your looks alive check, which is your least mechanism, which has the least timeout of 20 seconds. Then your is alive check, which is calling SP Server Diagnostics, and it runs every 10 seconds, which is 1/3 the health check timeout value. This is how the cluster resource DLL determines whether SQL Server availability group is healthy, or if it is not healthy, passes that information back to the failover cluster, and then the cluster can then decide what to do next. Running inside the process space of the resource monitor, information is passed back to the cluster service, and then the cluster decides. Okay, so let's look at this in action, because I'm going to show you that in a second when it comes to how it works internally. It's a very simple task. We'll create an availability group. Okay, how does SQL Server communicate with the failover cluster for the creation of an availability group? You type create availability group, you use the wizard, or in my case, I'm going to be using the DBA tools, PowerShell commandlets later. SQL Server passes that information to the hadrres.dll, which runs in the context space of resource monitor. The resource monitor passes that information over to the cluster service. The cluster service then receives that information. Like in the case of creating a new availability group, the resource control manager takes that information and says, hey, we need to create a resource group for this. Oh, we need to create a resource for this. Wait a second. You said you want to create an AG? We'll create an AG. Oh, we wanted a listener? We'll create a listener, and then we'll create a virtual IP address. The resource control monitor passes that information to the database manager as well, but in the process, it also passes that information to the node manager and says, hey, this node is running this command. We're going to make it the primary replica. Those information is passed to the database manager and stores it in the cluster registry hive, the local copy of the cluster database. Okay, let's and of course, at the end of the entire process, that information is sent back to the global update manager for it to send over to the other nodes in the failover cluster, stores that information for it to be persisted to their local copies of the cluster database. That being said, let's look at how that works inside the Windows Server failover cluster. And hopefully you can all see my screen. And I'm not going to bore you to death. Pretend for a while that I'm using, oh, by the way, for context, I have a 3-node Windows Server failover cluster. I have a file share witness, and I will create an availability group, but only make these 2 nodes as replicas in my AG. I've already enabled my always-on availability group feature, so it's there, but I'll also limit the availability group to only have these 2 databases, because later on I'll add the 3rd database. Run that. I'm not going to bore you to death, but here's what I'm going to do. Let's get back to the slide and show you what's happening while we're creating the availability group. The failover cluster will create the resource group, and then in the process it will create the resource. It will start off with the availability group, and as a side effect of it, because I've also added a listener name, it will create the listener name as well as the virtual IP address alongside with it. Notice that the listener name showed up. State is offline, and then added the virtual IP address. And notice while the cluster is adding the virtual IP address and virtual network name, the availability group is up and running. Now I know that's a little bit fast, so why don't we do this with text? Because I recorded the entire thing, put some text in it. So the process goes, let me backtrack a bit. Process goes, the cluster resource group gets created. and then the state changes from offline into running. In the process, an availability group resource gets created. The state of the resource group gets changed until the process starts adding resources like the virtual IP address and the virtual network name. What's not shown in here, which we are going to be looking at, is how the dependencies are also defined alongside with it. Okay. Now here's the thing, and again, I also want to make sure that the process is already complete. Yep, process completed. It opened up this thing. Let me walk you through what happens whether you're creating an availability group using SQL Server Management Studio or T-SQL scripts or the PowerShell commandos like what I use with DBA tools. This is what's happening at the high level. You're creating and enabling the HADR endpoint, again, on the assumption that you've already enabled the availability group feature. Step number 1, 2, and 3 are happening in the context of SQL Server. Because enabling the endpoint, creating the SQL Server logins, and granting the permission on the SQL Server logins, they don't have anything to do with available cluster. Okay. Steps 4, 5, 6, and 7 are processes that involve the failover cluster. So the way I look at it is, it's kind of like steps 1 to 7 is an entire transaction. It's one of the reasons why when you run a T-SQL script to create an availability group, when it fails, it has to roll everything back. Okay, so I kind of look at it as an outer transaction with a nested transaction underneath. Steps 4, 5, and you might be wondering, wait, how come you didn't include the creation of the listener name and the virtual IP address? Well, for one, you can choose to create the listener and the virtual IP address later on, right? But if you add those as part of the availability group creation process, the transactions increase, meaning the steps in the outer transactions increase. Now, steps 4, 5, 6, and 7 happen with the cluster resource DLL. Okay, let's look at this in more detail. Let's go back to our failover cluster, and I've already opened up the. By the way, you might be wondering what the heck did he do? At the end of it, I opened up the cluster. I generated the cluster error log immediately after creating the availability group, and then I opened up the cluster error log, which happens to be this. Let me go over to the operational section. Ooh. Operational. And there we go. Operational logs. And let's walk through exactly what I showed you in the video. First, cluster role was added to the available cluster. Now, I still like calling it resource groups because technically it's a group of resources. First step is the, let me make sure that you can see everything. There we go. First thing is that the cluster created the role. This is step number 4 in the AG creation process. SQL Server handed over the control to the failover cluster, and then the cluster created the role. Name, AG01. I want you to pay attention to the GUID value because this will come in handy later. Then the cluster resource, AG01, got added. I wish the naming convention was a little bit intuitive because Microsoft calls it role and resource. So the availability group resource is the same name as the availability group resource group or role. Anyway, so upon creation, and again, paying attention to the GUID value, the object ID. Okay. Then the cluster resource has transitioned from offline state to online call issued. Let me move word wrap. Online call issued, and this was the state change that you saw in the video. Resource entered from offline to online issued, and then the cluster resource change the role state from online called issued to online pending, and so on and so forth. And then at the end of it, the group transition from online to partial online. This is where the resource AG01 or the available group got created. Okay, and if you also look at this section over here, so from this point onward up to here is where the availability group and the available group role got created. This is the transaction in and of itself. Now, if you look at the timestamp, that's 12:26. By the way, this is GMT. We'll look at the details of this later. That's less than a second. Now, you might be wondering, wait a second, it doesn't take a second for me to create an availability group. What about I got like hundreds of databases, which I don't recommend? What if I got like terabyte-sized databases? The cluster only needs the metadata from SQL Server in order for it to do what it needs to do. It receives that information from SQL Server. Thank you, HADRres.dll, because that information is passed to the cluster resource DLL. The cluster then took that information, created the corresponding resources and resource groups and dependencies. And by the way, this is the first, up to this line over here is what I've included in the steps for creating an availability group. That's one transaction. And then the cluster decides, based on what I told it, I want you to create a virtual IP address, right? And then a virtual network name. Notice that these two are separate transactions from creating the availability group in and of itself. Creation of the availability group ends at this point, and then the creation of the virtual IP address starts at this point, and the creation of the virtual network name or the listener name starts at this point. Okay. Let's ask SQL Server what those values are. By the way, let's look at our availability group. I got the name of the available group AG01. I got 2 replicas. Despite the fact that I have 3 nodes in my failover cluster, I got 3 nodes, I only configured 2 replicas as part of it. I got 2 databases and 1 listener. Let's ask SQL Server what those information are using the SQL Server DMVs. And I want to put these side by side so that you can see that this GUID value over here, object name, AG01, object ID, AA1C, that is the GUID value stored inside the cluster database, as well as the metadata that you can see from the DMV. Let's move on. AG resource ID. Remember, the cluster has to create the available group resource as well. Object name AG01. Object ID 179B. That is the availability group resource from the point of view of the failover cluster. So this object ID GUID value pertains to, if I look at the resources in my failover cluster, pertains to this resource. And all of this information exists in the context of SQL Server, but also exists in the context of the cluster database. We've already started looking at the cluster database, but let me, part of the script that I did was to open the cluster error log. You can use Windows event log for this, or my favorite, I use the get cluster log PowerShell commandlet. Typically what I'll do is I will narrow down the time span, especially when I'm troubleshooting, because sometimes people would like, I made a mistake, I don't want to tell people. So sometimes they would try to solve the problem first before they tell you that there is a problem. And so when they call you, you kind of have to do an estimate. maybe this problem has been running for like 40 minutes. Okay, let's look at an item, an entry in the cluster database, or rather cluster error log. What I've shown you is not the full-on picture. It's part of the operational log. This is an entry in the cluster debug or verbose log. First entry before the dot is the process ID. Typically, this is the cluster services process ID, and sometimes there might be other processes running as well alongside that helps the cluster run properly. And then you have your thread ID. Every resource running inside your failover cluster is monitored by a separate resource monitor. Okay. Then you have your date and time in GMT. Info, whether that's a warning, an error, or debug. Component, this tells you so much about the different components that we talked about earlier. Is that the database manager? Is that the resource control manager? Is that the node manager? And then the resource name or the API call. And then the description. In this case, when I simply look at this entry in the cluster error log, it tells me at this date and time, the resource control manager created a resource with name AG01 with this corresponding GUID value, and the name of this resource is a SQL Server availability group. Let me preface, let me just mention this real quick. Please, 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 what I'm about to show you, do not do in a production environment. Do it on lab. Don't mess around with the registry, because if you do, you render your systems unsupported, and I don't want that for you. So let's hop back onto our registry. By the way, I'm running everything from my local machine. Right? I'm running everything from my I typically do the work on a what I call a DB workstation, where I install all of my tools and then do all of this from here. Now, typically, if I'm diving deep into the processes and all, I would log into one of the nodes in the failover cluster. But for this example, I can call the registry remotely. Here, I'm actually connected to my remote cluster node, TDP-RD071, which currently runs my availability group. Okay, it's currently owned by TDP-RD071, and when you look at my availability replica, it is my primary replica. So, again, word of caution, do not try this at home. Do not do this in a production environment. What I want to look at first is groups. Let's start off with groups. If you expand the groups, you see a couple of GUID values. And as you look into this, you kind of have an idea of what these are. Let's see. I'm going to put them side by side with SQL Server. This GUID value refers to my availability group, as I see from inside my SQL Server DMV. Okay. So when we're looking at this specific GUID value under the groups hive, inside it you have other information, like for instance, preferred owners, persistent state, the name. The name of my availability group, resource group, or role is AG01. Auto failback type. What I'm really interested in is the contains column. Let's see. Let's put this side by side with SQL Server and ask what this is. We already know that this one, this one pertains to my availability group resource. Okay. Then what's that other number? 8A something. Well, let's look at the other information that we collected from our DMVs. If I explore this specific DMV that contains my listener, this GUID value over here is exactly this. So I got my GUID value for my listener ID inside SQL Server as a metadata. I've got my availability group resource. But what about this? This one is actually the virtual IP address. Now you might be wondering, why is it not inside SQL Server? Well, it actually is, but SQL Server doesn't really care about the consistency of that, because that's something that the cluster takes control, manages rather. SQL Server knows what the virtual IP address associated with that resource, but doesn't need to know what the GUID value is. It is the cluster's responsibility to keep that consistent, not SQL Server. The only thing that SQL Server needs to know is, hey, this has to be consistent with this. Please, please, please do not make any changes to your cluster registry app, because it's very easy. I can introduce extra characters in here, and all of a sudden SQL Server does not behave the way it behaves, or it needs to behave. Let's look at these resources. Okay, let's start off with resources, specifically with this value, 1790 something, which happens to be this. Let's open up this particular resource. This is where we start to see, oh, this is my availability group named AG01. It's of type SQL Server availability group. It's the possible owner for this. Okay. Now, the failover cluster does not really know, or does not have any context about synchronous or asynchronous. The only thing that the failover cluster understands is who owns, or who can potentially own this. When I look at my failover cluster and I look at my availability group, this is specifically what I'm looking at. The cluster only knows possible owners. So in the context of what is stored in a cluster registry hive, possible owners simply mean, oh, TDPRD071 and TDPRD072 are the possible owners. Now you might be wondering, where'd you get that? We can ask the failover cluster, get cluster node, cluster TDPRD CLS AG070, and let's add ID and then name. ID number 1 is for TDPRD071. ID number 2 is for TDPRD072. So from the cluster registry hive's point of view, these two are simply TDPRD071 and TDPRD072. Let's move on. I'll expand this, and we'll see additional information like configuration. What is this? Well, first off, let's expand this. Under configuration, we see another GUID value, 12D3 something. Let's ask SQL Server what that is. 12D3 something. Let me that this GUID value under configuration pertains to the current primary node. If you move your availability group from one replica to another, the cluster needs to update that information. So SQL Server passes that information. Let's say you're doing a manual failover. SQL Server passes that information to the HADR res.dll. The cluster resource DLL passes that information to the cluster service and then stores that information in the configuration settings. So this value changes when you fail over to another node. What else? Parameters, replica status. What are those two? Let's look at SQL Server and ask, what is that value? Let's look at the different databases. Oops. F5. I've got my 15A93 is for my sales database. And then my 4.4 something is from my Northwind database. By the way, do not judge. I'm still using Northwind because I simply want to demonstrate how this thing works. Replica status tells me that these are the databases that are part of my availability group. If I add an additional available database in my availability group, the failover cluster needs to update this information and adds that GUID value corresponding to the database that I have. Now you might be wondering, wait a second, what else do I need to know about this? I did mention that the failover cluster does not really care about automatic or manual failover, or rather synchronous or asynchronous commit. So these changes, like for instance failover mode, they only exist, or only SQL Server understands what these mean. The failover cluster doesn't really understand what it means, but that's what the job of the resource DLL is for, is to translate what values these are to the possible owners. Okay, and that's why it is very important that the communication between SQL Server and the failover cluster stays consistent, because otherwise something goes wrong when somebody else is doing something that is not consistent with what both the failover cluster and SQL Server knows. I'll explain that in more detail when we get to the section on some of the things that you're not supposed to be doing outside of SQL Server. Okay, so we're kind of aware of what these are, right? We have the GUID value, we have the name of our availability group, configuration settings, which is the primary replica, and so on and so forth. Now, I did mention I've only showed you a portion. Okay, I've only showed you a portion of what the cluster error log tells us, and all in the context of the operational logs. Let's look at kind of like the verbose logging section of the cluster error log. Let's start off from here. This is the part where the failover cluster started creating the resource group, or in the context of failover cluster manager role. Yeah, I know there's some confusion. It still says create group, but the failover cluster manager still calls it roles, so there's a little bit of confusion there. You see the GUID value of the resource group, the name of the resource group, and because this is a transaction, it has to tell the global update manager, I want you to start a transaction. Right? Starting a transaction, there's a single transaction, and as part of this, it will create the group, it will create the owner of that group, and all of this information is also being stored in the cluster database as a part of it. It will create, the group, the subkey, name, and then contains and the values preferred owners. All of this is happening in the context of our resource group, which is this. Cluster created this, added all of these keys with the corresponding values, at the end of which it has to make sure that the entire thing is committed as a single transaction. That's why you see the code for resource control manager, the database manager, global update manager, because this is not just happening as a transaction inside the Windows Server failover cluster database. It also has to be sent over to the other nodes in the failover cluster for their copies of the cluster database to be consistent, and so on and so forth. And that's just for the resource group. We're looking at other components like, let's look at, there we go, creating of a resource. Yep, it's called AG01. This is the GUID value, and it's of type SQL Server availability group. I need to update the other databases in my failover cluster nodes. I'm going to tell the global update manager, let's start a transaction. And that's why you see started group transaction, started single transaction, and then started creating the resource inside that and checking if the resource is marked busy and so on and so forth. And then we'll refresh that. All as it is creating this resource. It's creating this cluster entry with the different key value pairs and then additional parameters. And you can walk through the cluster error log and looking at what is happening as simple as creating a simple or creating an availability group together with creating a listener name. Okay. In fact, we can let's try and add. Let me keep replica status there. That. Let's add a new database in our availability group. And again, nothing exciting, but it just makes it easy for us to keep track of what SQL Server is doing. I have HRIS database. I'll connect to TDPRD072. Oops. And then automatic seeding. Next and finish. Once that's done, if you query the DMV, you now have a third entry, which if you look at the cluster resources, say refresh. Sometimes it's hard to refresh. Disconnect. Oops. Disconnect and reconnect. Oops, not import. Connect to TDPRD071. And when you look at the cluster registry hive for that, for the same resource, we now have like an additional database under replica status. Now it appears as a third entry. 1837 is this, which now has the GUID value information for the current primary replica. And these are, again, these are things that are happening inside SQL Server, getting passed back to the cluster resource DLL. Cluster resource DLL communicates that back to the failover cluster for it to store those information inside the cluster registry hive, and then replicates those changes inside the cluster database of the other nodes. Okay. Now we have been looking at the cluster error log, generating the cluster error log. But of course, when you're troubleshooting issues, it's a little bit challenging opening up the cluster error log, doing what I'm exactly doing, like going through every single entry. But I do highly recommend that you start going through the logs similar to this, just to give you an idea of what the cluster is doing as you are performing tasks from inside SQL Server. But there's a better way, okay? Because I don't expect you to be doing this when you're troubleshooting an outage, okay? I hope you don't. You do this during an RCA or a root cause analysis, where you start looking at what these are and what could potentially have caused the issue. Better way to do this is by using an open source tool that the Microsoft support team came up with called SQL Log Scout. This will collect not just the SQL Server error logs, or not just the cluster error log, but it will collect the always on health extended event session. It will collect the SQL Server error log. It will collect other Windows event log, and then compile them all in a zip folder that you can extract and then analyze with another tool. And that is, and I wrote an article on MS SQL Tips on how to troubleshoot your always on available groups with SQL Log Scout. But collecting the logs is just one part of it. The other part is analyzing it, and not just going through every single log. Because again, keep in mind, I only took 5 minutes worth of the cluster error log. Imagine having to collect error logs from like yesterday and the day before in order for you to do root cause analysis. This is where you can run SQL Log Scout to collect all of that information, and then use SQL AG-Diag rather to analyze that information. Okay, like when you're troubleshooting. I wrote an article on how to use both SQL Log Scout and AG-Diag to further troubleshoot an issue, because again, you don't want to be spending so much time looking over and scouring the SQL Server or the cluster error log. Now, let's pretend, okay? Let's pretend something went wrong. And I'm going to do something that you should never do in a production environment, where I'm going to cause a crash. And part of that is if you observe AG01 would move from TDPRD071, which eventually will be moved to TDPRD072 as a side effect of the crash that I invoked. Again, not something that I would recommend that you do in a production environment, but this is one of those things where, wait a second, I need to generate a cluster error log. And if you noticed, AG01 went offline, and now it's currently running on TDPRD072. Let's generate the cluster error log as part of this. Okay, we'll run this. Let me open up a terminal window in administration, administrative privileges. And for this, probably 1 minute. Want to generate a cluster error log. And as a part of this, I'll open up the cluster error log for TDPRD072 because this is where my AG failed over. TDPRD072. And I'll look for, say, core, and then or something like core. Now, again, it's a little bit challenging if you don't know what you're looking for, and that's why I highly recommend that you use AG diag for this, because it's just so many things I have to look at and scroll over just to find out what caused the issue. In fact, when you start looking at what happened to the AG, and here it says RCM group set owner node. At this point, the cluster decided to move the availability group to TDPRD072. But what happened before that? If you look at this, there's something that happened. By the way, what I did was I simply caused a crash on TDPRD071 that caused the failover to happen to TDPRD072. Again, that is going to be part of your root cause analysis, but just giving you a sense of what is happening as you are going through the cluster error log. That's why for troubleshooting outages, I don't actually recommend that you start going through the cluster error log, because when something is offline, you have to think on your feet. You want to make sure that you bring the failover cluster and the availability group online as quickly as you possibly can. And that's why, again, highly recommend that you use these tools, SQL Log Scout and AG Diag. I did mention one thing, that when it comes to performing administrative tasks, there are things that you should not be doing outside of SQL Server. And this is a common problem and a common issue. Well, customers don't actually see it as an issue until they encounter an error or they encounter an outage. Performing administrative tasks using Failover Cluster Manager, okay? And tell your admins, your sysadmins this, especially if you don't have permissions to work on the failover cluster. Here's an example. Let me close these. My availability group. So I'm going to put on the hat of my sysadmin, and let's say I am going to install patches on one of the nodes. One of the things that may have been doing, for one, is maybe using the drain node feature. What is that thing? Right click. Oops. This, more actions, or drain node. Where is that? Or evict. These are things that your administrators are doing without them even knowing that they are causing issues. But I'll go back to this. advanced policies. If I'm looking at my availability group, note that the failover cluster does not really know anything about synchronous or asynchronous or automatic or manual failover. It only knows possible owners. How the failover cluster dictates which node becomes a possible owner is by looking at the failover mode. Let's switch TDP-RD 072, and of course I have to do this on the current primary replica. What if I wanted to switch TDP-RD 071 as an asynchronous commit? So I'm 71, but first I have to switch it to manual and then asynchronous commit. Then, oops, where is that? Let me cancel out of it. Let's say I wanted to switch the availability mode from synchronous to asynchronous. We'll start off with failover mode from manual to, or automatic to manual. And then hopefully I can find the OK button. Let's see. What ends up happening is that, because I can't find my OK button, what ends up happening is this will turn off or uncheck the possible owners list. Okay, but here's the challenge. Let me size this. What could end up happening is your admins or sysadmins might end up unchecking this. Oops, not this one because I'm currently the node. Unchecking this. Okay, so now what the failover cluster sees is no longer consistent with what SQL Server knows. Because as far as the failover cluster is concerned, TDP-RD 071 is no longer a possible owner. When you look at this, of course, I have to connect to TDP-RD 072. As far as my cluster database is concerned, if I look at my availability group, it only sees one, which is TDP-RD 072. But as far as SQL Server is concerned, TDP-RD 072 and 71 are both synchronous commit and automatic failover. So there's this inconsistency between what SQL Server sees within its DMV and the metadata and what the failover cluster knows. Your sysadmins, your VM admins, your server admins are not aware this has to be done from inside SQL Server. So they may have been doing things that they've been doing as part of their day-to-day, but not aware of the fact that they're actually causing problems. The typical issue that I see is a DBA would change the availability group replica from manual to automatic failover, but from inside a failover cluster, it still shows, or the sysadmin sees, hey, how come this is not checked? They will check all three and then attempt to failover and move this, let's say, perform maintenance, and then they would failover, and then the failover is not going to happen. Why? Because, well, for SQL Server, it's not supposed to run that. Okay? Like for instance, they decide to fail over to TDP-RD 073, but TDP-RD 073 is not a replica. And so that's why it's very important to communicate the risks associated with what SQL Server sees and what the cluster knows, especially in organizations where you have segregation of duties. And the DBAs are sometimes surprised when something happens on the operating system side, specifically on a failover cluster side, that they were not told about. Next thing you know, the database administrators are getting blamed for something they didn't even do, like in this case. Okay, so again, that's one of the reasons why I wanted to point that out, because this problem exists especially if a totally different team takes care of the virtualization platform. Sysadmin takes care of the server operating system, but the DBAs are only taking care of SQL Server. So now the database administrator's job is at risk for things they are not even familiar with or not even aware of that the sysadmins are actually doing. Okay, what's next after this? Please do not do this in your production environment, but I do recommend that you start poking around, looking at the cluster registry, and in part of your exploration, I would highly recommend that you do this in a lab environment. You poke around, mess around with the registry, and see the behavior of how SQL Server behaves when the cluster database is not consistent with what the SQL Server DMVs reflect. Part of that is just mastering the fundamentals of the failover cluster, because availability groups depend so much on Windows Server failover clustering as far as high availability is concerned. By the way, failover clustered instances don't have this problem, because only the cluster database keeps track of what's happening within SQL Server as far as availability is concerned. There's no GUID value for SQL Server instance name, nothing like that, because everything is stored in the cluster database. So there's no worry about, hey, is the metadata inside my cluster database inconsistent with the metadata that's inside my SQL Server DMVs? Nothing quite like that. But with availability groups, very, very important. Okay, keep track, and change management process, communication with teams, because the last thing you want is for somebody else doing something that you're not aware of. Next thing you know, you're fixing the problem that they caused, but they're not even aware that they caused the problem, because they've been doing the same thing for years as part of their day-to-day operations, but they're not aware that SQL Server availability groups is running underneath that. That is about it for some of the demos that I've shown. Have any questions, feel free. And Mark was saying, yeah, communication is key.
So, Edwin, we have one question from the chat that I'd like to ask you, if you're good with that.
Sure.
Okay. Outside of a SQL monitoring solution, which will notify of a failover, what can be used to alert at the operating system level, specifically for Windows Server failover cluster?
Your monitoring tools, and here's the thing, and it's a little bit challenging, because with the state of the monitoring tools available in the market today, SentryOne was my go-to. SQL Sentry was my go-to way back in the days until SolarWinds took over, and now there's not much of an option. But they did a really good job when it comes to monitoring both the operating system and the availability group as well. In fact, they have a feature where they're monitoring even the quorum, because again, just because of the fact that you have 2 or 3 voting members in your failover cluster doesn't mean you have quorum. And by the time that you lose quorum, you will lose the availability group or anything running on top of the failover cluster. So monitoring, check with your monitoring solution. Are they monitoring not just the AG, but are they also monitoring the operating system? Are they monitoring the SQL, the cluster service rather? Are they monitoring the cluster name object? Are they monitoring the witness? Are they all of these things? In fact, I have this concept called the wrap monitoring. You monitor for reliability. So you're monitoring for the cluster name object of your failover cluster. You're monitoring the connectivity to your listener name, your nodes in your failover cluster, the cluster service, because just because the node is up and running doesn't mean the cluster service is healthy, because it could crash for whatever reason, right? Some third-party solutions sometimes would lock services, and all of a sudden cluster service hangs, or SQL Server sometimes hangs. So Andy was saying SentryOne. That was my favorite from way back when. So understand the capabilities of your monitoring solution, and just look at, are they capable of monitoring for reliability, availability, and performance? And when I mean performance, monitor for how the infrastructure and the platform behaves as far as availability is concerned. And there's got to be that consistency, because sometimes missed or false positive, ran a probe on a node, didn't return successful results, and all of a sudden I freak out. So there's consistency, and there's making sure that you're clear on what you're trying to monitor. But also, and here's the problem with a lot of monitoring tools, you turn on the default, or the minute that you turn something on, next thing you know, you're receiving a ton of alerts that sometimes you get what I call alert fatigue. And now you're spending more time configuring alerts, tuning alerts, rather than doing the very thing that matters most, which is taking care of your databases. In fact, even with System Center Operations Manager, there's a reason why there's a dedicated team just for System Center Operations Manager. Because when you install a SQL Server Management Pack for Operations Manager, next thing you know, you're getting dozens, hundreds of email alerts, and next thing you know, you're spending more time again tweaking and tuning your monitoring tools rather than taking care of your databases. Chrissy was saying, I'm jealous at how easily you can say availability. I read the blog post that she wrote a couple months ago. I'm like, I tell customers, do not implement availability groups just because you heard it's a great thing. You have to be ready for it, and there's responsibility. The idea behind building something, and I always go back to the question, what business problem are we trying to solve? Are we just trying to implement something because it's cool? And I've had engagement with customers where they've implemented something like an always-on availability group because their previous DBA decided it was cool. Next thing you know, he left the company and nobody's taking care of it. So now they're responsible for something that they don't even know how it works, and now they're responsible for something that has turned into something mission critical. And now they're scrambling around trying to figure out how to manage it, how to monitor it, how to patch it. Even worse is when somebody from a different team, because here's the thing, somebody decides to design it, to build it, and then they would hand it off to operations. And next thing you know, operations don't have a clue how this thing works, and now they're responsible for, Anthony was saying, my first rule of availability group design is don't. Yes, totally agree. Just because it's cool. And I tell my customers that this is my bread and butter, but I don't, unless of course you don't like sleeping at night and you prefer reading cluster error logs when you couldn't sleep at night. It is not for the faint of heart, right? And if you really want high availability, I mean, failable clustered instances are still a thing. They're easier to manage, and it's not, again, just by looking at how we correlated the data in the cluster database versus the data in the SQL Server DMVs. With failover clustered instances, I don't have to worry about that because there's nothing stored in SQL Server as far as those GUID values are concerned. They are all inside a cluster database. So even your sysadmins can take care of it, no problem. But with availability groups, you have to tell your sysadmins that this is how it needs to be done. Whether they're patching the operating system or changing hardware, you have to coordinate and communicate. That's why I started this whole presentation by emphasizing how important communication is. Not just in the context of SQL Server and the failover cluster talking, but in the context of one team communicating with another team who's causing problems. Or sometimes they don't even know they're causing problems.
We have one more question. Just really quickly, because you have 0 time left. Is there any advantage if the primary replica is also the cluster host?
There is no advantage other than the fact that sometimes it just feels good that both my cluster core resources are running on the same node as my primary replica. But also keep in mind, you're running your cluster core resources require additional compute resources, memory, CPU. So offloading that from your primary replica gives your primary replica more compute resources to handle the workload.
I will say there's something to be said about having been a DBA before, that when I log into a server, I know what is supposed, where everything is supposed to be sitting. Right? Like just knowing, because you know this kind of thing happens at 2 a.m. What server is everything supposed to be on? Got it. Right? Like that's how I planned my life. How well is my brain going to work at 2 a.m.?
And it just makes life easy for everybody.
Right.
Thanks, Ray.
That was it. That was the last question. So I release you, but I don't know what Mark and Andrew and Anthony are going to do.
Fantastic stuff. Thank you so much, Edwin. That has truly capped off a fantastic 2026 edition of 8KB. Thank you so much. We've just got some closing out slides to go. So if I could grab the screen off you there, please, Ed.
If I know how to stop, there we go. I'm not going to share my screen. How do you stop sharing? Oh, there we go.
Excellent stuff. So final things. Just to remind everyone that if you want to support us, please do go buy a t-shirt in the Bonfire store, bonfires.com/store/8KB. And as I mentioned earlier, we now have the bandanas. Thank you to Mark. I want to say a thank you and a massive thank you to our amazing speakers. Once again, this year they've delivered such a high standard of sessions. So thank you to Chrissy, Marla, Andy, John, and Edwin. Truly mind-melting content. We will get all the sessions split up and uploaded to the YouTube channel. Please monitor the Slack channel for when that'll be happening and when all the resources get uploaded as well. We also want to say thank you to our awesome moderators. They do a fantastic job of fielding questions to the speakers so they can concentrate on delivering the sessions. So we have Deborah, Jess, Kevin, Ree, Matt, and Rob. Thank you so much. You do such a fantastic job that me, Mark, and Nancy can sit back and actually enjoy the sessions. So thank you. And then the final thank you is thank you to you. Thank you for attending. Thank you for joining. Otherwise, it'd just be me, Mark, and Anthony sitting in a room chatting all day, which we do often enough, actually, because we all work together. So, but no, thank you so much for coming. We really hope that you've enjoyed this edition of 8KB. And please leave feedback for Edwin at the feedback site. There's a link to his session there. And please do leave feedback for the entire event. Tell us what you liked, what you didn't like, and so that we can make this event as great as it possibly can be. Mark, Anthony, any closing words? I will stop sharing.
No, just another great event. And a lot of interaction in Slack, which I always like to see. So hopefully everybody had a good
Slack
time.
channel is one of the best things we did is build up the community there. Loads of good conversations happening in that day, and with speakers hang around for the entire day and answering questions for attendees. Absolutely brilliant.
Nothing from Anthony.
Nothing from Anthony.
I think one comment I will have. I probably took the most notes for things that I need to do personally from the sessions today. Like I picked up a whole bunch of homework. So thank you for all the speakers for that.
Wonderful stuff. Okay. That is us signing off. We will be back next year, won't we, chaps? Yes, absolutely. I'm just signing them up for this. They're sitting there going, I didn't agree to that. We will be back in 2027. So keep an eye on that Slack channel. We'll post up, as I said, with all the YouTube videos when they get uploaded, and keep an eye on it for when we announce the next event. Thanks again, and have a good one.